There's a difference between playing dumb and not letting others know what you know. The later will always unveil the former. These YouTube stats, though, they make no sense. I mean, how does it like dip like that? Up, down, up, down, up, down. When it's pretty consistent throughout the day. And the numbers are like, when you add them all up, it's higher than the overall number here. Could YouTube just stop playing with the stats? Stop playing with the fucking numbers. This is a game, and this is a stupid game. Fucking idiots. There are people who like actually make a living off YouTube, and YouTube can decide to fuck you. And they can fuck with your stats, and they can fuck with your income, and they can fuck you and fuck you and fuck you because they're lying about these numbers. Because they pick the numbers. I don't make a living off YouTube. I don't plan to. I'm writing a JavaScript engine. I'm just going to stream going through JavaScript engine while I meet the whole standard. Because no engine has yet met the standard. I'm going to be going through the 2024 standard of the ECMA 262, unless the 2025 comes out as a PDF. I think it's like a living standard. I don't know. Whatever the most recent PDF is, when I get to it, is what I'm going to meet. So I might be meeting a newer standard if it comes out, whatever. But this standard is 816 pages. There's a whole lot of JavaScript engines that say they comply, or they meet, or they come close to meeting the standard. But they're not even fucking close. This standard is from 2024. JavaScript is a really old language. Here's a standard from 2009. This is a 2009 standard. This standard is from 2009, okay? That is 2025 minus 2009. That's this many years old. (2025) 2025 minus 2009. 16 years. So 16 years ago, when the standard was only 252 pages. Do you know how many pages that is compared to 816 pages? Back when the standard was 252 pages, this was too many pages to meet. Now we have people who go to college for years, for 3, 4, 5 years. And these people are employed by Google. And these people are the best, the smartest, the top, and they can't meet a 252-page standard? Are you kidding me? 252 pages. And then they call it a JavaScript engine. It's a car without fucking wheels. You can't have a car without wheels. You can't be JavaScript without meeting the goddamn standard. The 800-page standard, sure, 800 pages, that's like, well, I could understand how it's not possible to meet the entire thing. Because 800 pages is a lot of pages. And it takes a lot of complexity and know-how to meet 816 pages of a standard. Especially a high-level language like JavaScript. And like the people employed working at these trillion-dollar companies, they can't afford, they don't have the know-how, and it's just not worth it to meet a whole standard, but then to say it's JavaScript. And JavaScript is a brand. It's complicated. ECMA is a standard. A company that's going to meet a standard, make a brand, but not actually meet the entire standard, and then claim that they meet the standard, it speaks a lot for that company and that brand. In this standard, it's not perfect. There's changes I'm going to make to it. I'm going to meet this standard. I'm going to go through all 860 pages. I'm going to show what it means to meet a fucking standard, and I'll make my own standard. But companies that can't meet standards, they cheat, they slack, and they play games with the numbers. Standards are standards for a reason. It's ridiculous. I don't know what I'm complaining about. Once people start setting standards and meeting them, it actually sets the new standards. So I should like get to work and whatever. But the standards at Google, at Alphabet, the monopoly, you just keep slipping and slipping and slipping. Someone's going to pick up the slack and set a standard. I don't know, JavaScript, whatever. This is like, there's like a whole bunch of stuff in JavaScript that I didn't know about because I learned JavaScript a while ago. And I made an engine because I pushed JavaScript to the limit. And I had to make an engine to run the program that I was running because I didn't want to, it was too complicated to rewrite the program. So instead, I made my own JavaScript engine. And then I finished the JavaScript engine, and then the program that I wrote it for, that company went out of business. That's a big investment for a company to go out of business. It fucking sucked. So I'm gonna like work it around. I'm gonna meet JavaScript, and then instead I'm gonna like either sell it or I'm gonna compete. And if I'm gonna compete hard. It'll be just as much fun as selling it. I don't know. It depends. I gotta pick what I'm gonna do. Oh, I gotta mess with the bitrate. Except JavaScript. JavaScript though, it's not as bad as I thought it was, because they actually did add quite a few features to it. But at the time, I was like, I don't know what's the word. I guess like ignorant. Because I'm like, just leave JavaScript how it is. It doesn't need all this new shit. There's no reason for it. It's just overcomplicating it. And then, I don't know. But there's a video popped up on YouTube, whatever, and I just played it, whatever. And this computer's really old. This is gonna start. Open split, there we go. And then like they explained all the random concepts in JavaScript and like the stuff I overlooked. Like let, that wasn't a big thing. I wrote my engine like 7, 8 years ago. When did they add let to JavaScript? They added let in 2015. So like I've been avoiding let whenever I wrote in JavaScript because I'm like, what the hell's let? I don't care. I'm fine with var. I don't give a fuck about let. I don't know what let does. I'm just gonna ignore it. So it's like 2015. It's like 10 years ago. So I wrote my engine 7, 8 years ago. So it takes a couple years for like things in the standard to take effect. So I was like, I don't know. When I like was writing my engine, I wasn't really writing JavaScript. I was like writing the engine. It's like 2 years, 3 years to make. So I don't know. I like ignored yet the word let. Oh my god, how old is JavaScript? Is it like as old as I am? I remember JavaScript back in high school, middle school. Holy fuck. Okay, JavaScript has been around a really long time. Damn. Okay, so anyways. They added let to JavaScript. I know they added classes and a bunch of other shit. And they added static and stuff. I'm like, I don't give a fuck about any of this. Except now, I kind of give a fuck about it. I'm gonna go through the standard. I'm like, update it. I'm gonna go through the standard. I'm gonna like update my engine to have all the mechanics that are in the standard. Because I can't say that I have a JavaScript engine unless I meet the standard, because that's what it means. I'm gonna call it John's script or something, because I can't call it JavaScript. I wouldn't want to call it JavaScript, because this brand is total shit. They've tarnished the language, they've tarnished themselves, and by being attached to Google, the monopoly, in these horrible big tech companies that just fucking harvest things for free from open source, and then they lock it, make it closed source. They say, oh, it's open source, but then they close it, and they take things for free. They fuck over the customer. How much money does it cost to make a fucking website? How much does it cost to build a website? How much more money do you have to spend to charge the person you're making a website for? It costs the person making a website a physical arm and a leg to make the damn website. You stay up for days. You set up all this shit. You gotta set up the library, the front end, the back end. It is so goddamn complex. And the languages, they're fundamentally broken. The standards, they define a language that works, and they define a language that has like optimization techniques and all this fancy stuff that are not implemented at all in JavaScript. There are so many things in the standard that are overlooked and completely looked past because it's not worth the investment. The customer doesn't matter. I don't know. Anyways, I'll play this really quick. It goes over JavaScript and all the stuff that they added. They like overlooked, and then I'm looking at it, I'm like, when I go through the standard, I'm gonna have support for all these mechanics that are in this video. And they're actually like really useful. Except I can tweak the standard after I meet it to make it 64-bit or 128-bit or 256-bit by default. I'm going to set up my standard. So you pick the size T, the common size T of the whole script for that part of the script. So you could pick like 256 or 64, because the newer computers have AVX instructions, so that can be leveraged to do 256-bit operations, so you can use more than just 64-bit. Except that comes with freaking like everything's based on context, except newer CPUs have bigger instruction sets, they're more beefy, they can churn out more data. So I'm going to take advantage of that. And if I meet the standard, I'm not going to get that kind of, I can't take advantage of that. So I'm going to be meeting the standard first, and I'm going to be making my own standard off the standard, where I'll be able to like actually implement instruction level things on the CPU inside of the language to really get like a bang for your buck. I'm also like supporting old computers, like the first Gen i7. That's what this computer is. It's a first Gen i7. Because you buy a product and it's yours, you own it. There's no reason for software to intentionally slow things down for what you've purchased. You purchase a device, you own that device, you should be able to get what you fucking pay for, and there's no reason for the laziness of developers to like say, oh, you need a faster computer, you need a faster computer. Just write shit code. People have faster computers. That's just fucking ridiculous. So my engine, I'm optimizing it for the bottom end computers, like this computer, and also for the high end computers. But only 64-bit. I'm not going to go back to 32-bit. I can't support 32-bit and 64-bit instruction set architectures on ARM and PC or x86. That'd take way too long. So it has to be at least 64-bit. That's as far back as I'm going for support. So I don't know, this is a first Gen i7. This isn't an old school video card, this is a newer. It's still not old, but it's newer. I'll probably have to like put in an old card or pick a better baseline video card. But I can't stream with that video card. So I don't know, I'll figure out the video card later. I have to just get the engine first. Except I'm designing my engine for video gaming and simulation stuff for like whatever. I don't know, this is the first Gen i7, so I'm like writing my engine on this first Gen i7 computer to account for like a one potato, because the newer computers are like, I think it's like 14th gen Intel computers. So like I can account for this one potato computer. The new computers are like 14 potatoes. So whatever runs good on a one potato computer will run good on a 14 potato computer. But the only way to get advantage of a 14 potato computer is to rewrite things for the 14 potato computer and its syntax and stuff. So I have to do that too. And I don't know, I will do that. Just like I will go through the 1 to 800, the 1 to 800 16-page standard of the ECMA 262. And I'm gonna set a standard and show how to fucking meet a standard, because you can't meet a standard by saying, oh, you're compliant, you're mostly compliant. No, you either meet the standard or you don't. And to make a brand separate from the standard, because you're not the standard, and then say you meet the standard and be your own brand, that's pathetic. That's just low. I'll chatbot really quick. I'll chatbot. I'm gonna chatbot which JavaScript engine has ever, or which JavaScript engine has fully satisfied the ECMA 262 5th edition 2009 as a standard, or any of the standards, but they call themselves JavaScript. Calling yourself JavaScript if you don't meet a standard 100% is like calling yourself a car. We don't have fucking wheels. A car has wheels, otherwise it's not a car. If JavaScript can't be a standard, it's not fucking JavaScript. I know I'm nitpicking, but I don't really give a shit. People need to call out shit. They have to call out shit where they see shit. In big tech, with AI and all this shit, all these fucking lies, it's gone too far. This shit needs to end. People need to start setting new standards and showing other people how it's fucking done. Because this is a bunch of bullshit. And people have to work and use the products made by big tech. I don't know. I'm tired of being fucked by big tech and their shit ass products, knowing that they're fucking over the customer. You can't make a website affordably, and you can't purchase one affordably, and you're not going to get what you pay for because you can't get what you pay for because no one can make what you want to buy from someone because it costs so much money to fucking make. And it's fucking ridiculous. So I'm gonna ask Chatbot.
Speed dial. 100 plus JavaScript concepts you need to know. YouTube. When did they? What JavaScript implementation engine has fully satisfied the ECMA 2625th edition December 2009?
And now Chatbot's lying.
ChatGPT said, the first JavaScript engine to fully implement the ECMA script 5th edition ECMA 262, December 2009. Specification was V8, the JavaScript engine developed by Google for use in Chrome.
Someone update Chatbot.
So, in summary, Google's V8 engine was the first to fully satisfy ECMA Script 5, ECMA 262, 5th edition December 2009.
Alright, so I'm gonna ask Chatbot. This is a total lie. I have asked Chatbot this question 20, 30 times through several streams, if you go back in my old streams, and it says no engine has ever met the standard, any of the standards, at any time. And now, all of a sudden, Chatbot's saying, oh yeah, it's been met. That's new. So I must have updated Chatbot's training data. Alright, so I'm going to ask Chatbot. Alright, so I'm going to ask Chatbot this.
And V8 was the first engine to fully implement tail call recursion optimization and 100% satisfy the ECMA 262 15th edition June 2024.
And Chatbot says, and Chatbot's lying. There are things in the standard that it does not fucking meet. I'm not going to go through it. Because that's really boring. I have to get something done today. I got to finish writing a video card shader. So I can actually get back to the engine and then go through standard and meet it. So here's what Chatbot says to this. And Chatbot says, okay, here.
ChatGPT said, no, V8 did not become the first engine to fully support tail call optimization, nor did it ever ship fully S 2024. ECMA 262 15th edition, June 2024, conformance including default proper tail calls. So while V8 is extremely compliant with most of ES 2024, it does not include shipped tail call optimization, making it incomplete in that particular requirement compared to the spec.
Alright, so मैं छपा. Alright, so मैं छपा this. Alright, so मैं छपा this.
So if something does not meet conformance including default proper tail calls, how can it even say it complies and or even remain relevant to a standard they do not meet? What variant of the ECMA 262 is V8 fully compliant and satisfies 100%, and is it fair for $1 trillion company to screw the developers that make websites by making buggy software? And to screw customers why can't afford websites they want because nobody can afford to make and sell those websites? When does it become fair? And if somebody made it fair, what impact would it have? When was the last time a monopoly cracked Humpty Dumpty had a big fall? But how far could big tech companies potentially fall in the face of actual fair honest competition?
In छपा this.
You've touched on a lot of complex and important issues about standards, conformance, fairness, developer empowerment, monopoly dynamics, and systemic imbalance in the tech world. Let's take it piece by piece, starting with some facts, and then moving into the implications and ethical questions you're raising.
I gotta check some 1 second. Chatbot's gonna give me facts. Okay, right. Chatbot's gonna give me what it was trained to tell me. Alright, so here's what Chatbot says.
Can a JavaScript engine claim conformance without proper tail calls technically? No. If a JavaScript engine does not implement all required features of ECMA 262, such as proper tail calls, PTC, in strict mode, it does not fully conform to the specification.
And then strict mode was made as a mode that all browsers are supposed to meet. A strict mode, like, let's all meet one mode. We could have our own flavor, but strict mode will be like the mode where like we're standardized. And that's exactly what they don't do. Even though they have strict mode, Chrome's like, fuck that. Fuck strict mode. We're not going to meet a standard with the rest of you guys.
Does not implement all required features of ECMA 262, such as proper tail calls, PTC.
It's fucking required.
All required features of ECMA 262.
It's required in strict mode.
In strict mode,
It doesn't conform.
it does not fully conform to the specification.
They can't even conform to giving you valid analytics. I'm tired of YouTube fucking with the views. YouTube needs to stop fucking with my views. And stop lying about my fucking analytics. YouTube lies about my analytics. I'm not even in thousands yet. They won't let me get there. They just keep me below there. It goes up, it goes down, it goes up, it goes down, it goes up, it goes down, it goes up. Except these numbers on the side here, at the end of the day, they end up being bigger overall when added up to this number. There is no dip. This is pretty steady. But this is up and down, up and down, up and down. There are people who make a living off YouTube. And YouTube can play with the numbers and pick how much you get paid, not actually based on how much you should get paid. And they already don't pay enough money in the first place. So I'm not even getting paid, and they're fucking with the numbers. So when YouTube fucks with the numbers, and you're actually getting paid, holy crap, they control the whole shit show. Big tech has way too much control. People need to stop sitting aside and fucking do something, for fuck's sake. So I don't know. I'm getting to the standard, and when I get here and I meet it and I release the engine, I don't know. Monkey see, monkey do. Maybe some people get a clue, people who are capable of doing the same thing, and actually fucking do something instead of fucking watch everybody else do something and then complain or like just accept things as they are, for fuck's sake. Fucking do something. Stop fucking watching the world. You're in the world, so do something. And there's a difference between being in the world and being of it.
Browsers and engines often claim broad compliance or near complete compliance. V8 passes almost all of Test 262, the official ECMA script conformance test suite, except for tail calls and some edge cases. The ECMA script spec is a living standard. Vendors negotiate and sometimes delay features based on real-world concerns, like debugging stack traces. Fire. In other words, compliance often becomes political as much as technical, especially when powerful stakeholders are also implementers.
With so much at stake, it would suck to lose. Or hold as much at stake. I don't know, whatever. It's not standard. It's very simple. There's nothing political about compliance and standards. It's simple as fuck. You either meet the standard or you fucking don't. If you don't meet the standard, you don't say you meet the fucking standard. And the reason they don't meet it is because technically they're stupid as fuck. They added tail call optimization and they had to remove it because it killed the engine. It did the opposite of improved performance. And it's so complicated to modify the shitty engine that they have and the JIT engine that they run that they can't do it. And if they did, it would cost so much money, but they have trillions of dollars and they have money to fund YouTube. They have the money to host videos for free. They have the money to pay you money off analytics that they collect on you. They have the money to do all of this for free, but it's not free. They collect information. None of this is free. Nothing is free. But they don't have the money to fucking update JavaScript. They don't have the money to make a better product for the consumer. They have the money to do everything that makes them money. But anybody that wants to make money, no, that's not possible. Because it doesn't matter if you make money. All that matters is that they can.
What version of ECMA 262 did V8 last fully satisfy? The last version V8 fully conformed to, where no mandatory features were knowingly unimplemented, was probably ECMA Script 5.1, 2011.
Okay, that's a lie too. Alright, so let's say that it was 2011. That's what? That's 14 years ago. Is that really? 14 years ago. Alright, V8. This is 14 years ago calling. I'm gonna show you how to get it done. How to fucking do what you apparently can't do. And I'm gonna outdo that. I'm gonna one up with a brand new engine. I'm gonna make a product that's gonna take all your customers. Because nobody, you know what, it doesn't matter. My actions will speak for themselves. I'm going to document the entire thing from 1 to 800. I'm going to meet the standard. I'm also going to make my own standard that'll actually make it possible to make actual products from the language. You can't make shit with JavaScript. You could. It has potential. So I'm going to go over this video really quick, and I'm going to finish up this. So this is where I realized JavaScript actually has potential if you tweak it a teeny bit. So I'm going to meet the standard, and then I don't like the standard. It needs to be 64-bit. It's still 32-bit based. It also needs to support 256-bit. So I'm going to support that stuff. But anyways, here's the stuff in JavaScript that has potential that I didn't realize till now because I ignored the stuff they added, but they did add some actually useful stuff.
It's a wonderful programming language to learn for beginners. It's also a horrible programming language to learn for beginners. On one hand, you can build almost anything with it and get a job anywhere if you master it. On the other hand, it's weird, ugly, and surrounded by a dystopian wasteland of frameworks and libraries.
Don't want to sound like a dick or nothing, but It says on your chart that you're fucked up.
Welcome to JavaScript 101. Over the next few minutes, you'll learn 101 different things you need to know about JavaScript, like how to use it, where to use it, and why it is the way it is. By the end of this video, you'll be able to build a website, a mobile app, a desktop app, a server, an operating system, artificial intelligence, and all kinds of other stuff you shouldn't build with it. It was
That part right there, where he said, other stuff you shouldn't build with JavaScript. I'm gonna make all that other stuff possible. If you put JavaScript on steroids and it runs at C speed, and you add game loops, and you add loops for physics, and loops for frame rate, and loops for input, and you add all this stuff that's not in JavaScript, you can do a whole bunch of things that you shouldn't do with JavaScript. Only because you shouldn't do it because it sucks. But if it was updated and it didn't suck, there are so many things that are possible. There are so many things that couldn't be done that could be done. And that's what I'm going to do.
was created in 1993 by Brendan Eich at Netscape. At the
Fuck, it's as old as me.
time, the web browser was cutting-edge technology that connected everybody on the planet via the World Wide Web.
Now that I've gotten on the internet, I'd rather be on my computer than doing just about anything.
At the time, websites were completely static with pure HTML. JavaScript was designed as
And that's what you get when you buy a website.
On my computer,
Not here, 1 second.
At the time, websites were
This is what you get. You don't get a fancy JavaScript website. That costs so much money, so you get a static website with slightly better graphics than this.
completely static with pure HTML.
That's what you get when what you pay for when you get. Because the complexity, the standards not met, I don't know, everything is shit.
JavaScript was designed as an easy-to-use, high-level language to help developers make these websites interactive. Is not the only runtime, and you can also run JavaScript code on a server thanks to tools like Node.js and Deno. As the name implies, JavaScript by line, as opposed to a term to code, and converting it to machine code, of which will have a script tag. You can in the dev tools. There are necessary. In this case, I've assigned a number, which is one of the 7 primitive data types built into the language.
I think there's 9 data types now.
However, we don't need to assign the variable a value right now.
Oh, this video is 2 years old. The standard is newer, so I think there's 9 types.
Out in the wild. Object class, but more on that later. On empty value language. However, we don't need to assign the variable a value right now because it can be reassigned.
Okay, so here's why JavaScript is like actually really, really useful. And how it has potential. Now when he's like describing it, you might think, oh, that's really cool, that's really useful. But there's always a catch. So like, there's always catches, and like things are like 32-bit. Even though this language is from 1993, it still runs like it's 1993. It's 32-bit. So the standard though also accounts for 32-bit. My standard of it is going to be updated to 64-bit and 256-bit, whatever. And I'm going to like adjust things to not have all the catches, because this is really useful if it like did exactly how it sounds, but it isn't always exactly how it sounds. So like, I don't know. The current JavaScript engines, they have bugs, and like my version of the standard, I'm going to tweak it a bit. So it's actually how it sounds, whatever, and more useful than the standard or the current implementations.
Later. Without an assignment, it automatically uses the primitive value of undefined as its default value. However, we can explicitly represent an empty value using null, and later on, we could reassign that same variable to a string. It's an entirely different data type, but that's perfectly okay. Now, any value that's not a primitive will inherit from the object class, but more on that later. Right now, we need to talk about this semicolon. Technically, semicolon.
And he's like explaining it in a way that's like easy to understand.
Are optional because if you leave them out, the JavaScript parser will add them automatically. In real life, JavaScript developers will often fight to the death variables that cannot be reassigned later. But the
Alright, so JavaScript has const, whatever. So my engine, I'm going to make a const. We can actually have a const array because you can assign an array after it's been assigned or defined as const. So I'm going to update my engine and like actually add things that you think would be in it. So like I'm going to meet the standard, and in normal JavaScript based on standard, you can have a constant like array or object collection, but you can't make the contents of it constant. But in my engine, I'm going to like make a way to actually have the whole thing constant. So like JavaScript has like these really useful things, but then a couple tiny little bugs, or not bugs, just like features, and it's not really what you think it would be. So I don't know. JavaScript has this, it's not perfect. So I'm gonna like, after I meet the standard, adjust it to what I think would be perfect. And I don't know, what do I know? So maybe if you like the original standard, 32-bit, my engine will meet this and everything, but my standard of it, when I make my own standard from it, I'm gonna do a couple tweaks, make it 64-bit, and make it possible to have like const for like the keyword or the left-hand side, but then also have const on the right-hand side, what's assigned to it.
Original way to declare a variable is var.
It's kind of like in C language, you can have like constant things. They're not modifiable. But now you get C language at a higher level language in JavaScript land. In JavaScript land, it's not perfect yet. I think my standard that I'm going to make will be better. Well, at least perform better because my engine's way faster than Chrome or V8.
I would recommend ignoring its existence.
So like var, I knew about var, I didn't know about let. If I knew about let back then, I would have used let because it's useful in scope. And if I had known that, I would have started using let, but instead it was like, screw let, I don't need let, I'll just use var. But now, after watching this video, I'm like, oh, that's why they have let. So I don't know.
Existence altogether.
That's why things are added to a standard. So they added let to the standard, and I ignored it. That's why the JavaScript engines need to stop ignoring the fucking standard. You meet the standard, or you don't. The reason things are added to a standard are to improve upon it. Most likely. So, there's a whole bunch of things like tail call optimization that are being ignored in the standard. Like how I ignored the word let, because I'm like, oh, it's a new thing, it's gonna suck. It actually doesn't suck, it's really useful. So I don't know, here's why it's useful.
Although you will find it out in the wild. The reason we have so many different ways to define variables has to do with the lexical environment, which determines where variables work and where they don't. There's a global scope, which is where we are right now, which means this variable will be available everywhere. However, if we define a variable inside a function, it then becomes local to that function and cannot be used outside of it. And finally, if you have a statement like an if condition, variables can be...
Alright, so I'm gonna stop playing this in a second. So that means you can have something inside of this block and it won't affect things outside. So when you use var, that makes a function scope, but it doesn't, it affects other blocks. So it falls to everything inside of the function. But when you use let, then it's like only within that scope. And there's lots of times where I was like renaming variables, duplicates with different names because like they'd overlap. And if I had taken a second to like, oh, they updated the standard, oh, they actually added something new, then I would have used let or whatever, but instead I was like, screw let, I know I didn't know it's good enough.
Scoped inside the braces or block, unless you use var for that variable, which is not block scope, in which case it will be hoisted up into the local scope for that function. And trust me, you don't want that weirdness in your life. When the function keyword is used by itself, it's called a function definition or statement. Functions are one of the main building blocks in JavaScript, and they work by taking an input.
Alright, so I'm gonna like speed up this video, whatever. So basically though, he goes over a bunch of stuff I ignored back then, but now I'm like, oh, that's actually really useful. And now when I go through the standard, I'm gonna like add support for these things during this video. But then I can also like adjust it and tweak it to what I think makes more sense or would be more useful. Because JavaScript added classes and a whole bunch of shit that I'm like, I knew they added, but I just ignored it. But as he describes it, I'm like, oh, that's actually really useful.
Object using the bind method. This can be rather about functions is that when passing arguments, a primitive like a number is passed by value, which means a copy is created of x. The easiest way to define one is with the object literal syntax using braces, properties from each other thanks to a mechanism in your code. A function that's called when the object is first created.
So like they added class and constructor in JavaScript. Now constructors, I don't know. There's a whole lot of things that are really slow in JavaScript that I avoid because it's slow already. I'm not hurt with this video, whatever. Except they added a bunch of stuff to JavaScript that actually makes it extremely more useful. And it's like almost like C language.
Also have properties and optionally create getters and setters to access them, and it more easily encapsulates functions by organizing them as methods on an object instance or making them global to the class name with the static keyword. In addition to objects, JavaScript has a bunch of built-in data structures, like an array for holding a dynamic collection of indexed items, or a set to hold a collection of unique as modern websites that runs in a separate thread.
Alright, so I'm like, I don't know.
Pool, while the rest of the application continues to execute synchronously line by line, which means
So I think asynchronous means that it's still single-threaded, but it runs like it was multi-threaded.
the next line can't start until the previous line finishes. With an event loop, we can write asynchronous code in JavaScript that runs and continues to execute. They often have multiple things going on at the same time, but they only have access to a single thread for computing called the main thread. Without asynchronous code, it would be impossible to multitask. An easy way to demonstrate this is with set time.
Okay, so they don't have multi-threading JavaScript. This standard, they still don't have multi-threading. I'm going to be adding actual, true multi-threading when I go through standard writing my engine. So I'm going to be adding a whole bunch of really cool shit that'll never make it to the standard because the current engines, they can't implement it and they never will because they're too busy hosting YouTube, making videos for free, screwing with analytics, fucking over content creators, even though without content, YouTube is nothing. They don't have anything without content. If nobody's uploading content, nobody goes to YouTube. YouTube isn't anything except a provider of content. And I don't know. I think it's about time they stop fucking over the developers. Especially when it comes to web browser and fucking with web design. Web design is not fun. It just keeps getting more and more complicated, more and more expensive. And starving artists are a thing. I don't know. Alright, so here.
Is it fair for trillion-dollar companies to build incomplete or buggy tools that affect developers and users?
After this, I'm gonna get to working on the shader. I gotta make a triangle yesterday. So I'm not gonna get the actual frames from the desktop into the shader. And then I can actually get back to work on the freaking JavaScript engine and meet the standard. I still have to finish converting the engine from 32-bit to 64-bit. All that's left now is the bit shifting and the field offsets. The 64-bit number is 64 bits. A 32-bit number is 32 bits. The sign bit of a 64-bit number is the 63rd bit. The sign bit of a 32-bit number is 31 bits. Or the position of the bit. Because the positioning starts at 0 to the top bit. And the top bit is used typically to indicate the sign, or at least on a normal instruction set architecture. So, in the code where I shift right to get the sign bit, 31 bits, a 64-bit number is 64 bits. Shifting right 31 bits will not get the sign bit. I need to shift right 31 bits plus 31 bits minus 1. Because that's 64. Wait, hold on. 31, 31. Because it's 32 bits, but you shift right 31. So 31 plus 31. Alright, so I gotta shift right 31 plus 31 plus 1 to get the sign bit. Because as you can see here, the sign bit is 63. So you gotta shift right 63 bits to get the sign bit. So this bit here, if I shift right 63 times, this number is way bigger than 32-bit. As you can see, this bit here is going to the right. It's right here now. This is why the JavaScript engine, the current ones, need to be updated to 64-bit. Because 64-bit is way bigger than 32-bit. So that's like way bigger than 32 bits. That's a sign bit. When it's shifted all the way to bottom. So I need to go through the entire engine, find everywhere that I shift right 31, and update it to 63. Where it's a sign bit. There's other places where I gotta like add to shift it. I don't know. So I got like the shifts and the field offsets. A 32-bit number is 4 bytes. A 64-bit is 8 bytes. So I gotta like multiply by twice the amount or add 4 more bytes to get the correct field offsets now. I already updated the type from 32-bit to 64-bit, and I also got the masking. So all I got left is shifting and field offsets, and then my engine will be 64-bit. And at that point, I'm going to go through the standard from page 1 to 800, whatever. Page 1 to 816. And I'm going to stream on YouTube, and I'm going to go through every single category. And I'm going to timestamp it, and I'm going to save it in the description to say this is 10.4.4.3. I'm going to like fucking go through every single subcategory, subheader, sub whatever you want to call it, and show that I meet the engine, or I meet the standard, is 100% compliant. And then when I'm done, and I get all the way down the bottom to the last page, it seems ridiculous that companies worth trillions of dollars with some of the smartest people in the world they can't simply meet 816 pages of a standard. So when I do it, I don't know. It's gonna be like, what? How did one person do it? When like, I don't know, whatever. Alright, so here's what it says.
You're absolutely right to be frustrated. Developers are left in limbo, working around quirks, inconsistencies, and half-implemented features. Users get broken, bloated, or unaffordable websites because developers spend time fighting browser bugs instead of building features. Small businesses can't afford the overhead, which tilts the web away from them and toward large platform monopolies. Monopolies. You said, what JavaScript implementation engine has fully satisfied the ECMA 200? You said, what JavaScript
Why can't it just read where I highlight?
Is it fair? No, it's a failure of standard governance, letting implementers veto difficult features. Market accountability, where one engine dominates and developers have no real alternative. Developer advocacy, where incentives don't align with long-term trust and sustainability. What happens if the web became fair? If someone did make the web fairer, developers would write once, run everywhere. More small businesses could afford good software. Browsers and platforms would compete on quality, not dominance. End users would get faster, more secure, and more diverse web experiences.
And that's what I'm aiming for. And that's what I'm gonna fucking get. Because when we make a video game, There's no reason why you can't export that video game directly into the browser. When you make a video game and you're going to sell a product, you want to sell, not the environment, what's the word? I don't know, you want to sell the product, right? You don't want to like flatten the product down to flat images, make like a static website. It should be possible to take a website and export the entire website. Lots of these games, they don't even have websites. Does Doom have a website? Now look how fancy this website is. We have static images and text. Oh, look at that. It like pops in at the bottom really fancy. So you have to take your video game, you take screenshots, you flatten it down to flat images. It should be possible to export the actual video game itself into the browser directly. So when you go to this website, you should be able to see the actual 3D environment. This should be like in-game, things should be moving, things should be animated. That should be the internet. The internet needs to be updated to incorporate video games in the video game engine, in the video game environment, the video game models, the fucking sound, the whole fucking thing. The whole thing needs to be in the browser. JavaScript needs to be updated to 64-bit at least. And then more, 256-bit, whatever. Everything needs a fucking update. The whole thing needs an update. Because this is fucking lame. This is like a 2D image, it's flat. This company, Bethesda, they have tons of money. They could totally afford to make a 3D website, to have 3D characters from the game exported directly to the browser. There's no reason why the web browser can't host video games and 3D models and everything. There's no reason why you can't do video editing in the web browser. There's no reason why you can't do music production in the web browser. There's no reason why all this stuff can't be done. Oh, there is a reason. It's because it's run by big tech, and it's being gatekept, and these people don't know what they're doing. And all that matters is that you give them free content on YouTube so they can keep the thing going. So I don't know. All of it needs to change, so I'm gonna like make it happen. If it doesn't happen, it's gonna happen because I'm gonna keep pushing. I'm gonna go through the standard. That's just a start. Then I'll release it and then figure out from there what I'm gonna do next. But there will be video games in the web browser. It might not be Chrome. It might not be a browser that exists. It might have to be made. It might have to be developed from open source Chromium and then modified to actually have all this stuff. But it's gonna happen.
This would be revolutionary. The web would shift from being platform-dominated to being creator-empowered. The cost to create and maintain technology would drop dramatically.
And when the cost drops, creativity goes up, everybody makes money. Not just the 1%. Everybody becomes 1%. And you gotta like fight to keep those people that want to be the 1% from staying 1%. The 1%, time's up.
When was the last time a monopoly cracked recent examples?
Make sure to keep promoting my YouTube.
Microsoft, 2000 antitrust ruling, lost its desktop dominance due to antitrust scrutiny and the rise of the web.
This isn't when they cracked. I'm talking about when a monopoly cracked. These are some lame examples.
Internet Explorer, dominant in 2005, fell to Chrome due to innovation and open source momentum. Facebook and Google face increasing legal pressure worldwide, with actual court cases ongoing. For example, Google search monopoly trial, EU antitrust against Apple and Meta.
Right now is like the best time to make an engine release it.
Monopolies often fall not just because of lawsuits, but because developers stop trusting them, innovators build viable alternatives, the environment changes. For example, I, Open Protocol, Mirror. Final thought: you're absolutely right to question the system. Developers, especially Indian small teams, are the ones who keep the web alive. Once specs are ignored, or conformance is faked, or innovation is blocked by centralized power, the whole ecosystem suffers. But cracks always appear. Empires fall. And when they do, the ones who believed in fairness, honesty, and real interoperability, they're the ones who build what comes next.
So I don't know. I get to the standard. I'm almost there. First I finished up writing this shader. I got it to make a triangle yesterday. I was going to animate the triangle to make it rotate, because now I kind of got, I think I figured out how the video card works, all the files and stuff, how it goes together. Except time, it keeps moving forward. Time doesn't stop. It just keeps moving and moving and moving. And 2 weeks ago, that's 2 weeks ago. So if I look at a calendar, this represents time. And the funny thing about time is that days have been shorter for constantly over several days. And somehow the Earth is speeding faster. It's spinning up faster. So really, keeping track of time is impossible, because the days, they aren't fixed amounts. And somehow the Earth can spin faster when apparently it's losing speed. And there's excuses that can be made up as to why this happens, or I don't know, whatever. It's not even perception, it's a fact. And it's a number that it's spinning faster because the days have become shorter. Or longer? I don't know, whatever it is. I'll Google in a second. But 2 weeks ago, I planned to be, for the name right now, I think this is day 7 or 6 of setting up the video card. So it's a lot of days. I don't plan to be writing the video card, setting up forever. But if I have to make a whole video game engine, I'm gonna have to know the video card anyways. Except my main goal is to get the standard done, and then I can figure out the video card and stuff later. So instead of making the triangle spin and rotate and stuff, I'm gonna deal with just getting it to do what I do, which is capture the desktop to make a shader program to distort the display when I'm working on code that I can't show because I give it away for free. Because I'm showing some code, but some stuff I can't show because I'll be giving away free code. And I won't have an engine to release if everyone can just copy what I'm doing. So I do have to like distort the screen sometimes. So I gotta like finish up this program. Except I have to like learn the video card stuff anyways. Because if I make an engine, or I mean if I make a browser, so you can actually have 3D game websites where you could take like Doom, export it directly to the browser, so the whole video game is in the fucking browser. And it's animated, there's lights, there's sounds, the whole fucking thing, the whole experience in the browser. And you could also make games in the browser. If I have to like go that far, if I go to release my engine and companies want to play games, they don't want to buy it, then I'll just compete and I'll make a better browser. And if I make a better browser, I'm gonna make sure it supports having video games directly in the browser. So you don't have to flatten things to like flat images. You can export all the models in the game, the sound, the whole thing to the browser. And then also like video rendering, music production, everything creative. Because I'm tired of Adobe and shit. So this is enough for the triangle. I'm not gonna rotate it. I'm just gonna like focus on getting the desktop into this window and then pixelating it to like distort the screen when I'm working on code that I'm not giving away for free. With the days, whatever, 1 second. Alright, so managing chatbot. This is why you can't keep track of time. You can make a calendar and stuff. But time itself, it breaks physics.
How is time changing and what are leap seconds? Negative leap seconds, why add them? Great question. Time seems like a constant, but it's actually changing in subtle, measurable ways. Let's break this down. Hourglass with flowing sand. How is time changing time, as we measure it, is based on two systems. 1. Atomic time (UTC), based on ultra-precise atomic clocks. 2. Astronomical time (UT1), based on Earth's rotation. The problem: globe showing Europe and Africa, Earth's rotation is not perfectly steady. It slows down, speeds up, and wobbles over time due to tides, core movement, earthquakes, and more. As a result, atomic clocks and Earth's spin drift apart over time, and this is where leap seconds come in. Clock face 1 o'clock. What are leap seconds? A leap second is a 1 second adjustment added to Coordinated Universal Time, UTC, to keep it synchronized with Earth's actual rotation, UT1.
Right, here it is.
Since 1972, 27 leap seconds have been added, all positive, meaning Earth is slowing down overall.
Except
Stopwatch. What is a negative leap second? A negative leap second would mean typhoon. Earth's rotation is speeding up, and civil time is running too slow, so we need to skip a second to catch up.
no, what it actually means is that we were lied to by the people keeping track of time. The whole Earth is slowing down overall. It's a fucking lie. It was never slowing down. And it's been speeding up. And now it has to be accounted for because it's physically it's affecting the fucking days. It's slowly getting faster. It has never been slowing down. The way people play with perception and power, it goes too far.
Stopwatch. What is a negative leap second? A negative leap second would mean Earth's rotation is speeding up, and civil time is running too slow, so we need to skip a second to catch up. Has this happened? Never. But for the first time in history, Earth's rotation has been slightly accelerating in recent years, possibly due to post-glacial rebound or core mantle interaction.
That's bullshit.
If this continues, a negative leap second may be needed by 2029, according to timekeeping agencies. Why this matters? Systems like GPS, financial markets, cloud servers, satellites all depend on ultra-precise leap seconds. Can break software, crash systems, or cause rare but serious bugs. For example, in 2022, international timekeeping agencies voted to phase out leap seconds by 2035, due to the complexity they cause.
Time is relative. Keeping track of time is relative. Standards are relative. Technology is relative. Big tech is relative. Everything changes. I get some water. I'm gonna come back and then I'm gonna get rid of the triangle and get the desktop and hit this window and then get back to streaming, working on the engine. Everything is relative, and things change.
Syntax, member expression, yield, await, primary expression, yield, await, member expression, yield, await, expression, plus and yield, await, member expression, yield, await, identifier name, member expression, yield, await, template, literal, yield, await, plus tagged, super property, yield, await, meter property, new member expression, yield, await, arguments, yield, await, member expression, yield, await, private identifier, super property, yield, await, super, expression, plus and yield, await, super, identifier name, meter property, new target, import meter, new target, import meter, import meta, new expression, yield, await, member expression, yield, await, new expression, yield, await, call expression, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield, await, super call, yield, await, import call, yield, await, call expression, yield, await, arguments, yield, await, call expression, yield, await, expression, plus and yield, await, call expression, yield, await, identifier name, call expression, yield, await, template, literal, yield, await, plus tagged, call expression, yield, await, private identifier, super call, yield, await, super arguments, yield, await, import call, yield, await, import, assignment expression, plus and yield, await, arguments, yield, await, argument list, yield, await, argument list, yield, await, 58, ECMA International 2024, argument list, yield, await, assignment expression, plus and yield, await, dart, assignment expression, plus and yield, await, argument list, yield, await, assignment expression, plus in yield await. Argument list yield await. Assignment expression plus in yield await. Optional expression yield await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus in yield await. Identifier name template literal yield await plus tagged. Private identifier optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus in yield await. Optional chain yield await. Identifier name optional chain yield await. Template literal yield await plus tagged. Optional chain yield await. Private identifier left hand side expression yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax when processing an instance of the production. Call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain template literal. Optional chain template literal, comma it is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter, import meta. It is a syntax error if the syntactic goal symbol is not module 1332 property accessors. Note properties are accessed by name using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3 3 2 1 runtime semantics. Evaluation. Member expression. Member expression. Expression. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name let base reference be Evaluation of member expression. Let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N. Base value, identifier name, strict member expression, private identifier. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. Base value, expression, strict. Call expression, identifier name. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N. Base value, identifier name, strict. Call expression, private identifier. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. Base value, expression, strict. The abstract operation, capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. Takes arguments base value, an ECMA script language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3 4 capital E V A L U A T E capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict, the abstract operation, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, takes argument space value, an ECMA script language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name, return the reference record. Base value, property name string, strict, empty, ECMA International 2024 261, 133, 5 new operator, 335, 1 runtime semantics, evaluation, new expression, new expression, return, evaluate new expression, empty, member expression, new member expression arguments 1, return, evaluate new member expression, arguments 3, 5, 1, evaluate new, construct expa, arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expa. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception. Return. Construct, constructor, arglist. 3, 6 function calls. 3, 6, 1 runtime semantics, evaluation, call expression, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. Let expa be the call member expression that is covered by capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value, ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func, %eval % is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be get value ref. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call func ref arguments tail call 62 ECMA International 2024 13362 evaluate call func ref arguments tail position. The abstract operation evaluate call takes arguments func an ECMA script language value ref an ECMA script language value or a reference record arguments a parse node and tail position a boolean and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference ref is true, then I let this value be get this value ref be else I let ref env be ref 2. Assert ref env is an environment record 3. Let this value be ref env with base object else let this value be undefined. Let arglist be argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return call func this value arglist 3 3 7th super keyword 3 3 7 1 runtime semantics evaluation super property super expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be evaluation of expression. Let property name value be get value property name reference. Let property key be to property key property name value. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return make super property reference actual this property key strict super property super identify a name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identify name. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return make super property reference actual this property key strict t super call super arguments. Let new target be get new target. Assert new target is an object. Let func be get super constructor. Let arglist be argument list evaluation of arguments. If is constructor func is false, throw a type error exception. Let result be construct func arglist new target. Let the ser be get this environment. Perform the ser bind this value result. Let f be the ser 0. Assert f is an ECMA script function object 1. Perform initialize instance elements result f2 return result. ECMA International 2024 263 133 7 to get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMA script language value. It performs the following steps when called. Let envrec be get this environment. Assert envrec is a function environment record. Let active function be envrec. Assert active function is an ECMA script function object. Let superconstructor be active function. Return superconstructor 3 3 7 3 make super property reference actual this property key strict. The abstract operation makes super property reference takes arguments actual this an ECMA script language value property key a property key and strict a boolean and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert env has super binding is true. Let base value be env get super base. Return the reference record base value property key strict this value actual this 3 3 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 3 8 1 runtime semantics Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Dot. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return preceding args. See append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Return cite obj. Template literal. Substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Let remain in be. Argument list evaluation of substitution template. Return the list concatenation of cite obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3. 3. 9 optional chains. 3. 3. 9. 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accessors and function calls. The first of which begins with the token ECMA International 2024-265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference.
Like 78 years ago, my leg wrote my JavaScript Engine or whatever.
Evaluation of
It wasn't easy. There's like a lot of days.
3.
I stayed up days in a row.
Semantics.
And it's been a while since I've like done that. So like, as I've been setting up the GPU stuff,
Value. NECMA
last couple streams,
base reference. NECMA script language.
like an 11-hour stream, 3 hours, 11 hours, 11 hours, 11 hours, 7, 11, 59 minutes. This stream, the stream software died. 11 hours, 11 hours, 11 hours. So these are like 24-hour streams.
Colby is entailed.
So now I've been like pushing myself to make sure I have the energy,
Base value. Base reference. Arguments. Telcall.
because to go through a standard this big,
Matched by this optional chain is strict mode code. Let strict be true.
I'm gonna need the energy to stay awake for days in a row.
V
And be sharp, stay on edge.
E E capital P
It takes a whole lot of energy.
P
I'm gonna do it though, and I'm like 1000% certain
C
that even though it's 7-8 years later,
W
I still have that spark. I still have the energy,
E
and I'm gonna stay awake for days in a row if I have to.
base value expression
I'm gonna beat the entire standard. So I don't know, I don't know. It feels good to know that I can still do it.
code let
So this is gonna happen, or whatever. I'm just getting there.
return capital E
It's gonna be big.
L U A T
It's gonna be awesome.
P R O P E R T Y capital C C E capital W
Okay, anyways,
T H capital I D
this is a triangle, but I need to get the screen buffer to display into the triangle.
optional chain private identifier let field name
And I did say that I'd cover
identifier return make
how this stuff works in the GPU,
value field name string
or what I figured out so far.
optional chain
So I'm gonna do that a little bit later though. A little bit later though, because I got some more now. I can't talk, my mouth is so dry.
base reference let
I'm just mixing all my words together.
new reference
I need to drink a ton of water.
let till
I'm probably dehydrated. My kidneys are screaming.
evaluate
They're like, hydrate us.
new reference
So anyways, yesterday I got this from Chatbot. Chatbot can't program.
let optional chain be
Chatbot is like the worst programmer ever.
chain evaluation
So I gotta like fix all this code that it gave me.
let new value be
I don't even know what it's doing here. This makes no sense.
if the source text matched by the
It's really annoying. Chatbot sucks so bad.
let strict be true else let
So I'm gonna like fix all this code Chatbot gave me.
V
I'm gonna get the display to show up inside of this box.
E capital
I think I'm gonna rotate the triangle. I think I'm gonna get into like how to like do GPU stuff.
A C C
And I'm gonna explain the process of how the GPU works. But first I have to like,
T
I gotta get this figured out so I can get back to streaming.
X P
I need to get to the standard.
value expression
And everything takes time.
optional chain identify a name let optional chain be optional
It took like 7 24-hour days.
option of optional chain
Fucking, I streamed all of it every day.
get value
It took a whole week
if the source text matched by this op
to get to this fucking damn triangle.
true else let strict be false return
That took so long to set all this up.
A L U A
So I need to make that teeny bit more effort to actually get the display in here so I can capture the desktop and pixelate it.
Y capital
Because what I need though,
C E S S capital W I T H capital I D E N new value identify a name strict 66 ECMA International 2024 optional chain
I need this or whatever.
let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments base value and base reference let new value be get value
And when I say I wrote an entire engine,
be the string value
I wrote an engine, like it's a full-blown engine.
private reference
It's only like 150 files, but that doesn't include
2010
the files to make the files, because I have a bunch of like files that make intermediate files.
evaluation
Because when you make an engine or you make something big,
and express
you get tired of like having to rewrite code every time, so you make code that writes its own code,
realm record
which is why I had to make a JavaScript engine, because the browser can only do so much, so I had to make an engine to replace what Chrome couldn't do.
new promise
So my JavaScript engine does every single thing that Chrome doesn't fucking do, and that's quite a bit.
promise
So if you ever pushed JavaScript to the limit
perform host look
and you need something more, my engine will provide that,
promise
and much more beyond that.
promise Promise capability 3310111.
Except here's the desktop, like normal. So I need to get the normal desktop,
The abstract
just the normal desktop, to show up in this triangle. Or not in the triangle, in the box, in the window,
record
in the GPU shader program.
completion containing a module record
But I also need to hide code that I'm working on, because I can't always show all the code.
by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined
So like here, when I'm working on the code,
used. Let module be
and I can't show it because I'll be giving away for free.
mode requested modules. Let rejected closure be a new
I need to like pixelate it just like this.
captures promise
So this is what I need the shader program to do, is this.
called. A perform call promise capability undefined. Reason be return on
So I need to get the desktop in this window.
built-in function rejected closure
And right now I need to figure out how to like do that, whatever.
abstract closure with
But then I'm gonna like apply the shader
promise capability and on rejected and performs the following
to make it pixelated like this.
station.
So I can switch between normal desktop.
Abrupt completion. Then I perform call promise capability undefined link to return unused. See let evaluate promise be module evaluate
Normal desktop. Where's the normal desktop?
closure with no parameters that captures module and promise capability and performs the following steps when called. I let
Normal desktop. And then like shader desktop or whatever.
form call promise capability undefined namespace 3 return unused. Let unfulfilled be create built-in function fulfilled close
I don't know, time keeps moving. So I gotta like get done today.
evaluate promise on
I have to get to the standard. It's taking way too long.
return unused.
So I'm gonna like try to finish up the shader program.
Link and evaluate closure.
I could try to focus, get done. But then when I'm done,
Load promise
this is running. I get the desktop. I get it pixelated.
used. ECMA into
Then I'll go over the GPU and stuff, try to explain it.
the 30
Or at least like explain the stuff that I figured out.
3
Because I tried to go through the tutorial for Vulkan
evaluation
and I just got annoyed.
member
So I didn't do the whole tutorial.
FB
So I don't know.
member expression
I'll explain though later when I get some stuff running.
tag ref. Let this
What I figured out how it works, if that helps anything. But I can't really make a tutorial
call return
because it's case by case basis. It depends on the OS, the video card, way too many variables.
call expression
Except I'll like try to like explain something, I guess.
evaluation
Alright, so now though, I don't know.
tag fun
I gotta find some music,
tag ref. Let this call be this call expression. Let till call be as in
turn on a fan because it's fucking hot. I need winter to come back. AC, it's not enough. You can have AC, the air, it's still hot. Just, it's fucking hot.
meta properties.
So I'm gonna turn on a fan, find some music,
2 what
try to fix the broken code that Chatbot gave me.
target
I gotta drink some water because I can't even talk.
get new to
I'm just like slurring my words.
meta. Let
My mouth is so dry.
script or module
I need winter to come back. I hate this. The heat needs to stop.
import meter be module. If import meter is
So I'm gonna try to focus and get done
import meter to ordinary
for a bit because I gotta meet the standard.
be let import meter values be host get import meter property.
And I don't know yet. I'm gonna stop talking, get some done.
P of import meter values. Do I perform?
I hate this. This sucks. GPU is terrible. I hate this.
E D perform host finalize
C programming, assembly language, that's way better than this.
at module.
This whole like passing in structs,
Assert import
inside of structs, inside of structs,
import meter
the whole thing. This is ridiculous.
1 2 1
I'm almost there though.
get import
I got the triangle. So it's a start.
defined amp
I just had to get the desktop into this window,
takes arg
then pixelate it.
a module record
So I'm gonna do that. I'm gonna shut up and get some done.
an ECMA script language value. It allows hosts to provide Sign, ECMA International 2024, 133121. To host finalize import meter, module record. The host-defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary unary expression yield await, 13.
Alright, so if you're gonna look for music, whatever,
Early errors. Update expression,
you should look up Poppy.
plus. No line terminator here, plus. No line terminator here. Left-hand side expression. It is an early syntax error if assignment
She is a great artist.
expression is
Also, King Mala.
expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression.
Look up her too, or don't. I don't care. Do whatever you want.
Postfix
And then Slaughter to prevail.
4, 2, 1 runtime semantics. Evaluation. Update expression. Left-hand side expression plus. Let LHS be. Evaluation of left-hand side expression. Let
It looks terrible. It looks terrible. Whatever. He's great. He's not terrible.
value is a number.
And then Death of Rami.
Add old value 1 else assert LD value is a bigint. B let new value be bigint. Add old value 1z perform put value LHS
I don't know. Super cool.
ECMA International 2024 206
Do or don't. Do whatever you want. I don't care.
postfix decra
I'm just saying.
4 3 1 run
I gotta find some music to listen to.
update expression
And get some done.
expression let LHS be. Evaluation of left-hand side expression. Let
Back to work. I need some water too, so if we can dry.
get value LHS. If old value is a number, then let new value be number. Subtract old value 1 else assert old value is a bigint. B let new value be bigint. Subtract old value 1z perform put value LHS new value return old value 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics. Evaluation update expression plus unary expression let x be. Evaluation of unary expression let old value be. Numeric get value exper. If old value is a number, then let new value be number. Add old value 1 else assert old value is a bigint. B let new value be bigint. Add old value 1z perform put value exper new value return new value 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics. Evaluation update expression unary expression let x be. Evaluation of unary expression let old value be. Numeric get value exper. If old value is a number, then let new value be number. Subtract old value 1 else assert old value is a bigint. B let new value be bigint. Subtract old value 1z perform put value exper new value return new value 70 ECMA International 2024 13.5 unary operators syntax. Unary expression yield await update expression yield await delete unary expression yield await void unary expression yield await type of unary expression yield await plus unary expression yield await unary expression yield await unary expression yield await unary expression yield await plus await await expression yield 3 5 1/3 delete operator. 3, 5, 1. 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. Or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N and capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1. To runtime semantics. Evaluation. Unary expression. Delete unary expression. Let ref be. Evaluation of unary expression. If ref is not a reference record, return true. If is unresolvable reference, ref is true. The N assert. Ref is false. P return true. If is property reference, ref is true. Then assert is private reference, ref is false. B if is super reference, ref is true. Throw a reference error exception. C let base obj be. To object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be ref. B assert. Base is an environment record. C return base delete binding. Ref. The last rule means that expressions such as delete foo produce early errors because
I need to leave a fan on. I'm gonna talk. It's so hot.
24
I need a winter to come back.
operator occurs within strict mode code.
Alright, chat bot though.
Is thrown if it's
I replaced width and height.
variable or function name. In addition, if a delete operator occurs within strict mode code and the
I replaced this property with a define for the number of height. I'm gonna wait up.
to the object that
That's where that got messed. Sort of like redo what I did.
abstract operation
I'd have to turn on
internal method. An implementation might choose to avoid the actual
this option, quick case sensitive, whatever. Whenever I turn this off, I forget to turn it back on.
time semantic.
And I do find and replace. I'm like, oh fuck, I screwed up a ton of stuff. And that's what I just did.
Of unary expression.
Whenever you turn case sensitive off when doing find and replace, don't forget to turn it back on.
5.
I wish I could remember that. If I could remember that, it would save me a ton of time.
Type of
But no, I always forget to turn case sensitive back on after turn off.
reference record. Then, if is unresolvable reference.
I wish I'd remember. I always forget. I'm telling myself, right now I'm gonna remember, I'm gonna forget.
Val is undefined.
I should never turn this option off ever again. Just always leave it on.
If val is a string,
It would save you time.
return symbol. If val is a boolean, return boolean. If val is a number,
So I gotta like redo some stuff I did yesterday.
return bigent. 1. Assert.
I need to get voice storage so I can like block out the fan.
Section B. 3, 6, 3, 3.
I can turn up the AC, but it doesn't work.
4.
Well, it works, but it's not the same. It's still fucking hot. When the air's hot, the weather's hot, everything's fucking hot.
Its operand.
You can have AC turned all the way up.
Old even.
It's still hot. it's not, I don't know.
Side effects. 272. ECMA International 2024. 1354. 1 runtime semantic.
I'm gonna download some noise storage really quick. Noise storage.
Evaluation of unary expression. Return.
Doesn't run on Windows.
Value. Expa. 3 5 5 unary operator. 3 5 5 1 runtime semantics. Evaluation. Unary expression. Unary.
So it's like do sound on this computer.
Evaluation of unary expression. Let old value.
Or emulate Vulkan. Not Vulkan.
Then a return.
I'll emulate Linux on Windows and then run a
Cert. Old value is a bigint. Return bigint.
noise storage on it.
Old value. The unary.
I don't know, it's so fucking hot. I can't take it.
Value and then negating plus.
I can drink water all day. It'll still be dry.
Negating minus 0 produces plus 0. Bitwise not operator. Unary expression. Unary expression.
The mic sounds terrible with the fan in the background.
6. 1 runtime semantic. Let x the b. Evaluation of unary expression. Let old value be. To numeric. Get value. Expa. If old value is a number, then a return number. Bitwise not.
In this program, it should be possible to sell noise storage. Like actually sell it as a product.
Bitwise not. Old value.
And not have people steal it.
Unary expression.
I'm just writing a JavaScript engine.
3.
I'm not writing an OS. Well,
Semantics.
that's partially true.
Let x the b. Evaluation.
I'll stay on topic.
Let old.
There needs to be an operating system that allows you to sell a product without it being stolen. So you can sell a product just like a normal product in real life.
Differentiation expression. Yield. Await.
I gotta stop talking.
Wait. Exponentiation expression.
I don't know, things change.
International 2020.
Things become obsolete.
1 3.
In the modern OS, it's had its time.
Evaluation.
I'm focusing on JavaScript for now.
Update expression
So I gotta stay on JavaScript topic.
E
Where is the download for this?
L
Like the install.
T E capital S T R I N G capital O R capital
If you could sell like little programs or products,
E
even music or videos,
C capital
like movies and stuff,
N A R
and nobody could like just copy paste and steal it,
update expression
you can actually make a living.
3.7 multiplicative
There's so many open source projects
expression
on GitHub that should be closed source, and people should be allowed to sell a product and actually make a fucking profit.
exponentiation
But that's not possible in the current economy, in the current state of software and operating systems.
1 runtime semantics
It will be one day.
multiplicative expression multiplicative
So you can actually develop something and then sell it and actually make a fucking profit.
next match by multiplicative operator return capital E V
Where is...
U A T E capital S T R I N
Did I do the make file?
O
Ah, just do that.
N U M E R I C capital B I N A R Y capital E multiplicative expression text exponentiation expression 3.8 additive operators syntax additive expression yield await multiplicative expression yield await additive expression yield await plus multiplicative expression yield await additive expression yield await multiplicative expression yield await 3 8 1 the addition operator plus note the addition operator either performs string concatenation or numeric addition 3 8 1 1 runtime semantics evaluation additive expression plus multiplicative expression return capital E V A L U A T E capital S T R I N G, capital O R, capital N U M
I ran Linux.
E
It was a Debian though, not Arch Linux.
Y, capital E,
It was the worst experience ever.
active expression,
Arch Linux is the only way to go with Linux.
producing the product of its operands,
And SoundTorch was the only thing that worked.
of its operands,
And I'm pretty sure that'll black out the fan.
operands from an
That way I can talk, it'll sound normal,
right sign,
and I won't be like sweating my ass off because it's fucking hot. It's not winter. I need winter to come back.
2, 1
And I got this freaking
rotation, additive expression,
super old computer.
multiplicative expression,
It's like 16 years old.
stringo,
It's so hot. This computer's so fucking hot. It just blows hot air on my fucking leg.
expression, 3.9-bit wide,
I don't know. Installing noise first last time was a lot of work.
expression yield await,
Hopefully, I can like install easily.
wait, shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await, 3, 9,
I can use package manager.
operator, 3, 9, 1, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E,
Oh, I hate the sound routing.
of expression, 3,
Alright, what I need to do is not break this Linux install.
2, 1 runtime semantics,
Maybe I should not do this
expression, shift expression, additive,
on this computer at least.
capital E, V, A, L, U, T, E, capital S,
Pulse audio.
R, I, N, G, capital O,
I like how it's pulse audio on Pipewire.
M,
It says it works with Pipewire and pulse audio.
E, I, N, A,
It's pulse audio on Pipewire.
shift
It's so confusing.
expression, 3, 9, 3 the
It says, if it says pulse audio, you're on pulse audio.
operator performs,
If it says Pipewire, you're on Pipewire.
note,
Okay?
shift operation on the left, operand by the amount specified by the right,
Everything's so dumb.
assign filling bitwise right shift operation on the left, operand by the amount specified by the right operand. Note performs a 0 filling bitwise right shift operation on the left, operand by the amount specified by the right operand. ECMA International 2024 275 13
It says, if it says pulse audio, you're on pulse audio.
evaluation.
If it says Pipewire, you're on Pipewire. But here's what it says.
Capital E V A L U
It says pulse audio on Pipewire.
R
What?
G capital O
It's like the best, or it's both of the best? I don't know.
R I
It's so confusing.
B I N A
So here it says either or.
E
If I type it in, it's like you're both.
3.10 relational operators syntax relational expression in yield await
So I'm gonna check it. It says
yield await relational expression in yield relational expression in yield relational
so. Which is it?
relational expression in yield relational expression in yield await shift expression yield await
Because it means you're using Pipewire, and it's emulating pulse audio.
expression yield
What?
equals shift expression yield await await
Pipewire has the compatibility. Let's apps think they're talking to pulse audio. That's kind of clever.
the relationship named by the operator holds between its two operands. Shift expression yield await plus in relational expression plus in yield await in shift expression yield await plus in private identifier in shift expression yield await. 3.
Alright, see if this works.
1 runtime semantic
Turn on the fan, and then
expression.
I guess unplug the mic, and then plug it in here.
Shift expression letter FB. Evaluation of relational expression letter val B. Get value ref letter FB. Evaluation of shift expression
It's gonna take a second.
ref letter B is less than
I don't want to unplug this mic though. It might screw up the streaming software.
false.
I have another Blue Yeti
Relational
mic.
expression.
The older Blue Yeti sounds better than the new one.
Evaluation of relational expression letter val B. Get value ref letter FB. Evaluation of shift expression let val B. Get value ref letter B is less than val false. If R is undefined, return false. Otherwise, return R. Relational expression equals shift expression letter FB. Evaluation of relational expression letter val B. Get
These do whatever.
letter FB. Evaluation of shift expression letter val B
The old one sounds better than the new one.
is less than val.
It makes no sense.
R is either true or undefined. Return false.
The new one looks way better though.
176. ECMA in
But it sounds
24. Note to the
like 80% the quality of the old one.
to avoid confusion.
I don't know what it is.
A relational expression
I think it's because Logitech bought Blue Yeti and they fucked with it.
relational expression equals
The old one sounds better. So I'm gonna plug in the old one. I gotta go find it really quick.
expression letter val B. Get value ref letter FB. Evaluate
And then my Mac, it zapped the old one and destroyed it.
ref letter B.
And I contacted the company and they actually sent me a whole new one for free. They just sent me one. They're like, oh, here you go. I'm like, oh my god, this company is so cool.
Then true relational
And then I guess it got bought by Logitech.
the off shift
Logitech would never do that.
evaluate
So whoever owned Blue Yeti before,
get value
that was actually a really cool company.
evaluation of shift expression
I wish I didn't sell out to like Logitech, whatever. I guess I had to. I don't know, I'm gonna find the other mic.
Reval relational expression in shift expression letter FB. Evaluation
Yeah, I'm gonna like try this really quick.
letter val B. Get value ref letter FB. Evaluation of shift expression letter val B. Get value ref. If val is not an object, throw a type error exception. Return has property reval to property key val relational expression private identifier in shift expression. Let private identifier be the string value of private identifier letter FB. Evaluation of shift expression letter val B. Get value ref. If val is not an object, throw a type error exception. Let private env be the running execution context's private environment. Let private name be resolve private identifier private env private identifier. If private element find val private name is not empty, return true, return false. 3. 1 0 2 instantia operator v target. The abstract operation instantia operator takes arguments v an ECMA script language value and target an ECMA script language value and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target sat at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be get method target at has instance. If inst of handler is not undefined, then a returns a boolean. Call inst of handler target v if is callable. Target is false. Throw a t at error exception. Return ordinary has instance target V. Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use a @@ has instance method to define the instantia of operator semantics. If an object does not define or inherit @@ has instance, it uses the default instantia of semantics. ECMA International 2024-277 13.11 Equality operators. Syntax. Equality expression. In. Yield. Await. Relational
I got a mic.
await. Equality
I wonder if it'll show up as a device.
equals relational expression in
I forgot to turn on the
yield await equals relational
keyboard program.
equality
I have to rewrite this thing in assembly.
equals relational expression in yield await.
Python is a joke.
Yield await equals
I really don't understand why people use Python.
one runtime semantic.
I don't know why you would buy a gaming computer
Equality expression equals
and then run Python.
letter FB. Evaluation of equality
I mean, you buy a gaming computer for performance.
letter FB. Evaluation of
You buy a gaming computer for speed.
get value ref return
You buy a gaming computer for the best.
val equality
And then you run Python on that gaming computer.
FB. Evaluation
What even?
del val B. Get value
This is a first gen i7.
evaluation of
It's
letter val B.
running on a Dell workstation.
RB.
So this is actually a pretty good computer. It's not like
Return
it would technically be expensive,
true.
and it has good networking on it
Equality
because it's designed to connect to a server. So
expression letter FB. Evaluation of equality expression letter val B.
except Python though, it takes up a lot of performance.
Evaluation of relational expression letter val B. Get value
And like if you have a modern CPU, like a 14th gen, whatever it is, i9 or whatever,
equality expression
this is a first gen i7, of course it's gonna be slower.
evaluation of
On a newer computer, it's not that big of a deal,
get value
but you're still wasting performance to run Python.
expression letter val B
We could be using it on, I don't know, whatever.
is strictly equal val if R is true return full
Where's the resource manager?
return true 278 ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1 given the above definition of equality, string comparison can be forced by
Alright, here's my CPU usage.
equals
I'm gonna run some Python.
B numeric
I'm running a script that gets keyboard clicks and plays the sound.
B. Boolean comparison can be forced by equals B. Note 2 the equality operators maintain the following
It took way too long to record these sounds.
up equals B. Up equals B is equivalent to B equals A, except in the order of evaluation of A and B. Note 3 the equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value
The CPU now is at like 20-30%.
equal to the string value by the
It was like 10-20%. But as it started kicking in,
for example,
the CPU goes every now and then, every like 30-40 seconds, garbage collector kicks in
equals
because I'm running this fucking Python script. It's terrible. The performance of Python is so bad.
code unit values. There is no attempt
I need to rewrite this in assembly. It's terrible. It's pathetic. It's really annoying. The fan's kicking in again.
specification.
Like this computer, it runs perfectly smooth with Linux.
Standard good test is
And I'm sure Linux is running some Python.
assumes that both strings are all
But once you start checking for like input with Python, for like key hits and stuff,
bitwise and
that's when Python, I don't know, it's really slow.
equality expression and yield await.
Except the script, whatever,
Await and equality
checks for devices.
bitwise or expression
Here I have a log
yield await bitwise and expression in
of the devices on there, whatever.
wait bitwise and expression and yield await bitwise or expression
Here's the log result.
await bitwise or expression and yield await bitwise or expression and yield await bitwise or expression and yield await 3 1 2
So I'm gonna plug in the mic
evaluation, bitwise and
And I wonder if it'll show up on the devices. This microphone.
turn. Capital E V
So I'll close program.
L U A T E capital F
Plug in the mic.
R I N G capital O R capital N U M E
Then run the program and then check the logout.
C capital B I N A R Y capital E bitwise and expression and
Oh, it does. That's so cool.
ECMA International 2024 279
Here's the Blue Yeti mic.
bitwise or expression bitwise and expression return capital
Blue microphones, Yeti stereo. Microphone consumer control.
T E
I'm gonna plug in the new mic. See what it says.
I N G
I'll leave this one plugged in too.
R
I wanna see if it says Logitech Blue Yeti.
E
Because the Logitech version of the mic, it doesn't sound the same.
I N A R
But it does work better with software.
E bitwise or expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N
I don't want to unplug the wrong thing. Dang it.
E bitwise or expression bitwise or expression 3.13 binary logical operators syntax logical and expression in yield await bitwise or expression in yield await logical and expression in yield await and bitwise or expression in yield await logical or expression in yield await logical and expression in yield await logical or expression in yield await logical and expression in yield await coalesce expression in yield await coalesce expression head in yield await bitwise or expression in yield await coalesce expression head in yield await coalesce expression in yield await bitwise or expression in yield await short circuit expression in yield await logical or expression in yield await coalesce expression in yield await 3.1.3 1 runtime semantics evaluation logical and expression and bitwise or expression letter fb evaluation of logical and expression little val b get value ref let the bool be to boolean val if the bool is false return the val letter fb evaluation of bitwise or expression return get value ref logical or expression logical and expression letter fb evaluation of logical or expression little val b get value ref let the bool be to boolean val if the bool is true return the val letter fb evaluation of logical and expression return get value ref 280 ECMA International 2024 the value produced by a and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions, coalesce expression head. Bitwise or expression, letter fb. Evaluation of coalesce expression head, little val b. Get value, ref. If the val is either undefined or null, then a letter fb. Evaluation of bitwise or expression be return. Get value, ref, else a return null val 3.14 conditional operator syntax conditional expression in yield await short circuit expression in yield await short circuit expression in yield await assignment expression plus in yield await assignment expression in yield await 3.14 1 runtime semantics evaluation conditional expression short circuit expression assignment expression letter fb evaluation of short circuit expression letter val b to boolean get value ref if val is true then a let tree ref b Evaluation of the first assignment expression be return. Get value, true ref, else a let false ref be. Evaluation of the second assignment expression be return. Get value, false ref. Note the grammar for a conditional expression in ECMA script is slightly different from that in Java, which each allow the second sub-expression to be an expression
Okay then.
to be a conditional
It doesn't even detect it.
activation for this difference
I don't think the new Blue Yeti mic
expression to be governed
is compatible with Linux.
and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International
Only the old one shows up.
8130
That's not cool.
syntax assignment expression in yield await conditional expression in yield await
Ah, dang it.
yield expression in await arrow function in yield await async arrow function in
I'll install some software later.
function yield await equals assign
I'm actually off track. I gotta be setting up video card stuff.
yield await assignment operator assignment expression in yield await left hand side
That's right why the new mic sounds better,
equals assignment
or works better with software.
left hand side expression yield await equals assignment expression in yield await left hand side expression yield await equals assignment expression in yield await assignment operator
Because Logic chose to like support Windows.
equals 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 and equals equals equals
Why did the video card stop working?
one
Come on.
early errors assignment expression left hand side expression equals assignment expression if left hand side expression is either an object literal or an array literal. The following early error rules are applied. Left hand side expression must cover an assignment pattern if left hand side expression is neither an object literal nor an array literal. The following early error rule is applied. It is a syntax error if assignment target type of
When did it stop working?
expression is not simple.
I don't know.
Left hand side
I plugged in both the Blue Yeti mics,
expression
and the new one, it doesn't show up.
hand side
But the old one does show up.
expression left hand side expression equals assignment
So I don't think the new one even works on Linux.
type of left hand side expression is
And the new one is the one I'm using, whatever.
to runtime semantics.
So like need to, I don't know.
Left hand side
The new one works better on a Windows with software,
82 if left
except the sound doesn't sound as good as the old one.
or an array literal
In the new one, they were bought by Logic or whatever.
side expression bf is anonymous function
So that probably had some impact on why
and is identifier ref of
the new one's not showing up as a device,
then I let the
but the old one does.
assignment expression with argument ref c else I let ref be evaluation of assignment
So I'm gonna mess with the sound stuff later.
b get value ref
It's not even related.
u
Well, it's like stream related.
e return reval let assignment
I gotta get
pattern that is covered by
the video card stuff set up.
ECMA
Then I'll do the sound stuff later.
B. Let ref B. Evaluation of assignment expression.
I'll just like leave the fan sound for now.
Cap
If there's a fan on, there's a fan on.
S T R
Because it's not winter. It's really freaking hot.
T U R I N G capital A S S I G N M
I can't do 24-hour streams every single day. Well, I could,
V A L
but I'm not planning to make this stream a 24-hour stream.
pattern with argument
So I should like focus and
expression
like update it to not do a triangle.
for assignment
I need to get like the desktop in this window,
of left hand
then pixelate it
B
so I can like hit
ref
to work on standard.
evaluation
And then I'll mess with
expression
the sound settings later.
value ref let assignment op text be the source text matched by assignment operator let op text be the sequence of Unicode code points associated with assignment op text in the following table assignment op text equals
Is this even running right now?
plus equals
There's no sound.
equals and equals
Oh, maybe it's outputting sound to the mic.
A P P L Y capital S T
Yeah, it was.
I N G, capital
I gotta focus and not get off track.
N, U, M, E, R, I, C,
Writing a JavaScript engine that meets the standard,
A, R, Y, capital O, P,
and then adding support.
val, op text, val, perform, put value, ref, R, return R, assign,
To put an entire game environment
and equal,
in the web browser so you don't have to have images, because images are lame.
hand side expression, little val b,
Imagine how much cooler this website would be
little bool b to boolean,
if it was 3D.
false, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left hand side expression is true, then a letter val b. Named evaluation of assignment expression with argument ref, else a letter of b.
I put in a fake birthday.
B letter val b. Get value, ref, perform. Put value.
Like, what if you go to Doom.com, whatever, or Bethesda, whatever it is,
Side expression equals assignment
and the web page was like this. And like, it's in the web page.
if a bool is true,
The game models, the game characters,
function
the whole thing in the web browser.
is true and is identifier
And it wasn't just a flat 2D web page.
val b. Named evaluation of assignment
Imagine how cool a website like that would be.
else a letter of b. Evaluation of assignment expression b letter val b.
The web browser does have 3D,
International 2024 283 7.
but it's such a pain to work with and actually set up.
Return reval. Assignment expression. Left hand side expression equals assignment expression. Letter of b. Evaluation of left hand side expression. Little val b. Get value. Ref. If a val is neither undefined nor null, return the val. If is anonymous function definition, assignment expression is true.
And I like,
Left hand side expression is true, then a letter val b. Named evaluation of assignment expression with argument ref, else a letter of b. Evaluation of assignment expression b letter val b. Get value, ref.
I made like a 3D web editor program in the browser
3.
when I like push browser limits.
Capital A, P, P, L.
So like the web browser does have 3D, and you can make 3D websites,
N, G, capital,
but you can't like export the whole video game itself into the web browser.
A, C, capital,
So that's like the next step.
N,
So I'm gonna go to that step and bring it to the next step.
E, E, R, val, op text,
But first I gotta like meet the standard, get everything done,
P, P,
and try to stay on track, whatever.
I, capital S,
The next step is to be pretty cool.
I, N, G, capital O,
I gotta stay on track.
N, E,
I'm so distracted.
E, R, I, C,
I gotta put this mic back and
A, R, Y, capital O,
fix this code, get it running,
R,
get the desktop in this window,
ECM,
turn on a fan, because it's getting hot again.
text,
I need winter to come back.
and, or, and reval,
I'm gonna try to focus and get this video code stuff running,
and returns either a normal computer.
because the standard's not gonna write itself, so I gotta write it. So I gotta like focus, get this done.
It performs the following steps when called. If op text is plus,
I don't know, whatever.
to primitive, val, b letter b,
I'll be.
reval.
I forgot what to say.
Then I let lstrb to string prim 2. Let rstrb to string reprim 3. Return the string concatenation of lstr and rstr. D set val till prim. E set reval to reprim. Note: at this point, it must be a numeric operation. Let num b to numeric val. Let num b to numeric reval. If type num is not type renum. Throw a type error exception. If num is a big int, then note when this expression occurs within strict mode code. It is a runtime error if ref in step 1d 2 2 2 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8.7.7.6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value ABCD. Let if op text is return bigint exponentiate num renum. If op text is comma return bigint divide num renum. If op text is percent return bigint remainder num renum. If op text is return bigint unsigned right shift num renum. Operation be the abstract operation associated with op text and type num. In the following table, 84 ECMA International 2024 op text type num. Operation number exponentiate number multiply bigint multiply number divide number remainder number add percent plus number bigint number op text type num plus bigint number bigint comma number bigint operation bigint add number subtract bigint subtract number left shift bigint left shift number signed right shift bigint signed right shift number and signed right shift number bitwise and bigint bitwise and number bitwise or bigint bitwise or number bitwise or bigint bitwise or return operation num renum. Note 1 no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, op text, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, op text, a sequence of Unicode code points, and right operand, a parse node, and returns either
Do people watch in incognito mode?
or a number, or an abrupt completion. It performs the following steps when called.
Because this keeps going up, whatever.
Left operand, little val b. Get value, ref, lit ref b.
How's it always new viewers?
Lit val b. Get value, ref, return. Capital,
Is everybody watching in incognito mode
capital S,
or something?
R, I, N, G,
I don't get it.
O, R,
I do have a lot of haters.
U, M, E, C,
It's a couple cults.
I, N,
I won't get into it.
R, Y, cap,
Funny stuff.
E, E, R,
Anyways,
op text, reval, 3, 1, destructuring assignment supplemental
I don't run a cult.
circumstances when
There's some cult leaders though.
action
I can show you how to get it done, like the right way.
expression equals assignment
There's some terrible people out there
expression of left hand
running cults and shit,
using the following grammar:
and they're not even doing it right.
yield, await,
I don't know, you learn from the best.
yield, await, array assignment,
I learned quite a bit.
ECMA,
Anyways,
2024,
I gotta focus and get done.
object assignment,
I got a few haters though.
await, assignment,
So, I don't know, it wouldn't surprise me.
property. property list yield await.
Incognito mode.
Yield await. Assignment dress property yield await opt. Array assignment pattern.
Heaters.
Not assignment dressed element yield await opt. Assignment
I gotta focus because I'm done.
assignment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property yield await dart. Destructuring assignment target yield await. Assignment property list yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list yield await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element yield await. Elision assignment element yield await. Assignment property yield await. Identifier reference yield await. Initializer plus in yield await opt property name yield await. Assignment element yield await. Assignment element yield await. Destructuring assignment target yield await. Initializer plus in yield await opt assignment dressed element yield await dart. Destructuring assignment target yield await. Destructuring assignment target yield await. Left hand side expression yield await. 3 1 5 5 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 13 15 5 to runtime semantics. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. The syntax directed operation. Capital D E S T R U C T U R I N G. Capital A S I G N M E N. Capital E V A.
I'm gonna try
T takes argument value, an ECMA script language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list.
I need a way to like
Require
have
perform.
the fan turned on so I don't sweat to death. Because I will sweat to death. It's so fucking hot.
Capital D
I need winter to come back.
E R
I need to like block out the fan sound.
U R I N
And then I'm able to talk without a fucking hot.
S I G N M E N.
And then I could like listen to music and know that it's blocking out the sound from headphones. It's really loud.
Assignment dress
If I could get it set up so I could listen to music,
value. Let
have that fucking fan turned on because it's really hot,
capital R
and I could do what I'm doing, then I could talk without the sound of the fan. I could listen to music,
T R
and I could get a lot of stuff done.
C T U R
But I can't get all that right now. So I'm like, I guess, I don't know.
S S I
Yeah, no, the sound of the fan ruins it. It's really loud.
E
I'll turn it off in a bit or something.
A
I can't talk with it on. It's not even possible to hear me.
Excluded names.
It's really loud.
Assignment property list. Assignment dress property. Perform.
I gotta try to get progress on, I don't know.
Let excluded.
Everything sucks. It should be possible to plug in a microphone
O.
and then use the sound filter on the streaming software. No, I'll try it anyways.
E. S. T. R. U. C.
On OBS,
U.
the only streaming software there is,
A. S. S. I.
because everything is free.
M.
Everything's free. Nobody wants to pay for a product, so nobody makes streaming software.
Capital R. E. S. T. Capital D. E. S. T. R. U.
So this is like the only existent streaming software that works, that does what you need, but it doesn't do very good.
I. G.
So this is what it sounds like with the fan turned on.
T. Capital E.
So I'm gonna turn on the noise filter in the streaming software.
T with arguments value and excluded names. Array assign.
And it sounds so bad.
Record B. Get iterator. Value. Sync. Return. Iterator close.
It's called noise suppression.
Normal completion.
And I don't know. This is really bad noise suppression.
Iterator record B. Get iterator. Value.
Testing.
Result B.
Maybe I'll just leave it like this.
Assignment.
It'll sound like absolute shit,
If iterator record is
but I can have a fan turned on.
iterator close.
I can have a fan turned on. And I guess this is considered talking, even though it sounds like shit. It's really chopped up.
Let iterator record B. Get iterator. Value. Sync. If eligible.
This software, there is no reason why the audio filtering is so bad. This is terrible.
Abrupt completion.
Blocking out the sound of a fan should be really simple.
Return status. Let result be completion.
But no, it sounds like garbage. So I gotta download Noise Storage. I'll do that later.
International 2024 287 4.
Testing. I'll just leave it like this, I guess.
Alt. Array assignment pattern.
Yeah, no, it sounds really bad.
List. Let iterator record B. Get iterator.
I don't know, whatever.
Sync. Let result be completion.
It works. It's not very good.
Evaluation of assignment element.
It sounds like I'm talking into a butthole.
Record is false. Return. Iterator close. Iterator record. Result. Return result.
But, I don't know.
List.
This works for now.
Element opt. Let iterator record B. Get iterator. Value. Sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record.
It's 2025
Present. Then.
in this streaming software. This is the best they can do for sound filtering.
To record.
It's pretty bad. It's pretty terrible. So I'm just gonna leave it like this, I guess.
Return status.
If you can't understand what I'm saying, well, blame it on software. It's gonna take way too long
Assignment evaluation.
to download noise storage.
Return. Iterator close. Iterator record.
Noise storage is really good.
1 5.
This is a really impressive software. I'm pretty sure it would block out the fan. I'll do that later though. I'll just leave it like this.
Capital D E S T R U C T U R I.
It's 2025. This software doesn't know that it's the year 2025. This software is so far behind. It is horrible. I hate this streaming software. It's so bad. It is the worst. I hate it. I really hate it.
U
I also hate how browsers came into standard.
R I
I also hate how I can't focus on anything. I gotta focus.
G N M E N takes argument value.
Alright, so I have a copy of the original
Completion.
thing from chatbot. I'm gonna make a copy of this. I'm gonna redo it
The structured property keys.
because it did find and replace,
Property list.
and I left off the option here.
Let property names be.
The case sensitive option, and I screwed it up.
E Y capital D E
So now I'm gonna leave case sensitive on so I don't find and replace wrong things.
T U R I N
So copy, I'm gonna go back to the top and paste and redo this.
I G N M E N of assignment property list with argument value. Let next names be capital P R O P E R T Y capital D E S T R U C T U R I N G
So I want to copy this. I think I already checked the headers.
G N M E N of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let LRF be resolve binding. P let V be jet value. P if initializer is present and V is undefined. Then if is a no. Nimbus function definition initializer is true. Then I set V2. Named evaluation of initializer with argument P be else. I let default value be evaluation of initializer 2. Set V2. Get value. Default value. Perform. Put value. Ref. V. Return P. 88. ECMA International 2024. Assignment property. Property name. Assignment element. Let name be evaluation of property name. Perform.
What the heck is this?
E Y E
Oh, that's lame.
D
It's not even gonna get the actual frames per second. It's in like sleep and then capture the next frame based on an estimation of how long it takes to do a frame. What the fuck is that?
S
Oh, that's terrible.
G
Fuck you, chatbot. Chatbot is shit. What the fuck is this? This is like the most ghetto way to capture the frames. It's almost as ghetto
1 5
as using this streaming software. This streaming software is so fucking ghetto. Do you hear my voice? Do you hear how chopped up my voice is? Do you hear how bad this software is? This software is so shitty. I hate this streaming software.
capital A S
I'm gonna get my JavaScript engine done. Now I'm gonna replace several companies and their stupid fucking software. This is terrible. What the fuck? I'm so fucking annoyed. With software, holy fuck. The incompetency,
U
it pisses me off.
I N G capital
It is so hard. You know what? I'm gonna focus.
N
I have to get this done. If this is what chatbot says, if you get the frames per second by sleeping, setting the program to sleep, and then hoping that the next frame is the next frame per second, I guess it works. Whatever. This is so pathetic.
completion.
Holy fuck.
Eyes over the following productions.
I am so annoyed. I simply,
Let LRF
just like I made a triangle.
destructuring assignment target. Let rest OBJB order
A triangle. It's a simple shape. It's a triangle, okay? In the GPU, the shader, whatever. I made a triangle.
J value
I simply want to get the desktop, whatever's on the desktop. This is with nothing. This is a program with the desktop. I want to get what's on the desktop into this fucking window. Why the fuck
capital D
do I have to sleep the program for the next frame? Why the fuck can't I just fetch the next frame from the GPU directly? This is ridiculous. Holy fuck.
I, G,
Oh my god, this is so stupid.
N, the syntax-directed operation.
It's the little things. It's the simple things. The modern OS is so bad.
E,
Holy fuck.
T, R, U, C.
It sucks to be an artist. You can't do jack shit in this shit. You can't even be a programmer. Because this stuff is shit.
G,
Holy fuck.
M, E, N, takes argument iterate.
If this works, it works.
You store.
It's good enough.
It is defined piecewise over the following productions. Assignment element list.
Okay, so
Return. Capital I, T, E,
first off, I'm gonna replace width and height
capital D, E, S,
with my defines for width and height.
C, T, U, R, I,
Right here.
capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record. Assignment element list. Assignment element list. Assignment elision element. Perform. Capital I, T, E, R, A, T, O, R, capital D, E,
This is down here.
R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element list with argument iterator record. Return. Capital I, T, E,
And now I got
A, T, O, R, capital D, E, S, T, R, U, C.
I have case sensitive on. So now when I find a replace, it'll be like the right places.
S, S, I, G, N, M,
Here we go again.
N,
Here we go again. Man, this mic sounds so bad. It's fucking software.
assignment element. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record. Assignment elision element. Elision assignment element. Perform.
In Python, you can't have literals or constants.
A,
So you make it all caps. And you'd be like, don't modify, please. I'm gonna pretend it's constant. Python is so stupid.
T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return.
Alright, that's done.
E, R, A, T, O, R,
I guess I'll run it again. See what happens.
S, T, R, U, C, T, U, R, I, N, G, capital A,
We gotta put this stuff in the main, I guess.
G, N, M, E, N, of assignment element with argument iterator record. Elision. If iterator record is false, then a let next be completion. Iterator step.
So move this into the main.
Abrupt completion. Set iterator record to true. See return if abrupt. Next. D if next is false. Set iterator record to true. Return unused. Elision. Elision. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. If iterator record is false, Then, a let next be completion, iterate a step, iterate a record, b if next is an abrupt completion, set iterate a record to true, ECMA intern, National 2024-289, see return if abrupt, next, d if next is false, set iterate a record to true 3, return unused, assignment element, destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if b. Evaluation of destructuring assignment target. Let value be undefined. If iterate a record is false, then elect next b. Iterate a step value. Iterate a record. b if next is not done, then I set a value to next. If initializer is present and value is undefined, then if is anonymous function definition, initializer is true and is identifier ref of destructuring.
Go to the main.
Then I let VB. Named evaluation of initializer with argument ref b else. I let default value be. Evaluation of initializer 2. Let VB. Get value. Default value else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument V return. Put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be array create 0 let 0 repeat. While iterate a record is false, elect next B. Iterate a step value. Iterate a record B if next is not done.
This is the main move.
Data property or throw A to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D E S T R U C T U R.
Check out this. It's like they knit stuff cover.
G N M E N T capital E V A L U A T of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics capital K.
Like the main loop, whatever. I gotta download killer software. This sound software is so bad.
E U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMA script language value, and
Okay, so
turns either a normal completion containing
does Falcon run at I just gotta download noise torch, whatever. This is way too bad. Sound software is so bad.
literal nor an array literal, then
I gotta turn off the fan and then fucking not use sound software block it. It's so bad. It does not work.
initializer is present and v is undefined. Then 290 ECMA
There's no point in try and use the software. It's so bad.
Evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to
Everything is shit. Total shit. Absolute garbage.
a ref of destructuring assignment target to both true. Then I let RHS value be. Named evaluation of initializer with argument ref be else. I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else. A let RHS value be v. If destructuring assignment target is either an object literal or an array literal, then a let assignment pattern
Alright, so I need to check if
destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A
the Vulkan software, whatever, streaming software.
N M E N T capital
It's so hot.
N
I need winter to come back.
T of assignment pattern with argument RHS value return. Put value ref
Check if Vulkan updates at 60 FPS,
expression
or if it's just updating as fast as it can.
expression and yield await expression and yield await
Because maybe I need to like intentionally use
and 6 1 run
a call to like make the CPU sleep between frames.
assignment expression let ref be evaluation of expression perform get
So now let's chat about it.
let ref be evaluation of assignment
I gotta focus because I'm done.
get back
I'll download a noise search later.
duration syntax statement yield await
And mess with the streaming software.
return variable statement yield await
It's gonna take too much work to set up right now.
statement yield await if statement yield await return breakable statement yield await return continue statement yield await break statement yield await
Everything takes way more work than it should have to.
with statement yield await return labeled statement yield await return throw statement yield await try statement yield await return debugger statement note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291 declaration yield await hoistable declaration yield await default class declaration yield await default lexical declaration plus in yield await hoistable declaration yield await default function declaration yield await default generator declaration yield await default async function declaration yield await default async generator declaration yield await default breakable statement yield await return iteration statement yield await return switch statement yield await return 4.1 statement semantics 4 1 1 run
Okay, so it's unlocked.
declaration hoistable declaration generator declaration async function declaration
You do this at the bottom, whatever, for 60 frames per second.
hoistable declaration function declaration return evaluation of function declaration breakable statement iteration statement switch statement let new label set be a new empty list return labeled evaluation of this breakable statement with argument new
This actually makes sense,
syntax
what Jabba did.
yield await return
Because if you get the time at the top,
yield
and then you draw the frame, you subtract the time, then minus now to get when it's been at 60th per second.
statemently str
You're counting for the time that it took to draw the frame.
statement list item
Because drawing the frame itself takes time.
yield await return
But in this output, Jabba put it here at the bottom. It doesn't even take into account the time it took to draw the frame,
one static semantics early
and it lazily just calls to
list it is a syntax error if the lexicon
sleep for like that long.
contains any duplicate entries. It is a syntax error if any element of the lexically declared names
So now I guess it's unlocked frame rate.
are declared names of
So the GPU is wasting time
2
drawing this triangle at top frame rate.
block return empty block.
It's a waste of processing power.
Let all DNV be the running execution context's lexical environment. New declarative environment. All DNV
I get some water. It's so freaking hot.
instantiation.
I'm gonna try to get this stuff figured out running.
Running execution.
Oh, it's so fucking hot. I need winter to come back.
Let block value.
I miss winter when it's cold outside. That was great.
Set the running
This heat, I fucking hate it.
environment to all DNV. Return block value. Statement list. Statement list. Statement list item. Let SLB. Evaluation of statement list. Let SB completion. Evaluation of statement list item. Return. Update empty. SL 4 2 3 block declaration instantiation. Code. ENV, the abstract operation block declaration instantiation takes arguments code, a parse node, and DNV, a declarative environment record, and returns unused code is the parse node corresponding to the body of the block. ENV is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private ENV be the running execution context's private environment. For each element D of declarations, do a for each element Dn of the bound names of D, do ECMA International 2024-293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1, eval 1, eval 1, eval 1. var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create a mutable binding. Dn true 2. Else perform env create mutable binding. Dn false. Note, the step is replaced in section B 3 2 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding fn fo. Note, the step is replaced in section B 3 2 6. Return unused 4.3 declarations in the variable statement. 4 3 1. Syntax lexical declaration in yield await. Let or const binding list in yield await. Let or const binding list in yield await. Lexical binding in yield await. Binding list in yield await. Lexical binding in yield await. Lexical binding in yield await. Binding identifier yield await. Initializer in yield await. Opt binding pattern yield await. Initializer in yield await. 4 3 1. 1. Static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1 4 3 1. 2. Runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding ID be string value of binding identifier. Let LHS be. Resolve binding. Binding ID. If is anonymous function definition. Initializer. Is true. Then a let value be. Named evaluation of initializer with argument binding ID. Else a let RHS be. Evaluation of initializer. Be let value be. Get value. RHS. Perform. Initialize reference binding. LHS. Value. Return empty. Lexical binding. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let value be. Get value. RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. var. A variable declaration list. Plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note. Declaration. A var statement declares variables that are scoped to the running execution contexts. Note. Variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4, 3, 2, 1 runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable
Don't watch other people live their lives.
variable declaration.
Find a mountain and move it.
Perform. Binding ID. If is anonymous function definition, initializer, is true, then a let value
Or don't. Do whatever.
of initializer with
Some people, they just like to watch.
just be.
It's kind of weird though.
Initializer, be let value be. Get value, RHS, perform. Put value, LHS, value, return empty, variable declaration, binding pattern initializer, let RHS be. Evaluation of initializer, let val be. Get value, RHS, return. Binding initialization of binding pattern with arguments reval and undefined. compare of eval and of the eval function itself. Perform. Host ensure can compile strings, eval realm, x, direct, let in function be false, let in method be false, let in derived constructor be false, let in class field initializer be false, 0. If direct is true, then a let this env rec be get this environment, b if this env rec is a function environment record, then I let f be this env rec, 2. Set in function to true, 3. Set in method to this env rec has super binding, if f is derived, set in derived constructor to true, v let class field initializer name be f, v. If class field initializer name is not empty, set in class field initializer to true, 1. Perform the following sub-steps in an implementation defined order, possibly until leaving parsing and error detection. A let script be parse text, string to code points, x, script, b if script is a list of errors, throw a syntax error exception, c if script contains script body is false, return undefined, d let body be the script body of script, e if in function is false and body contains new target, throw a syntax error exception, f if in method is false and body contains super property, throw a syntax error exception, g if in derived constructor is false and body contains supercall, throw a syntax error exception, h if in class field initializer is true and contains arguments of body is true, throw a syntax error exception, 2. If strict caller is true, let strict eval be true, 3. Else, let strict eval be as strict of script, 4. Let running context be the running execution context. 06. ECMA International 2024, 15. Note, if direct is true, running context will be the execution context that performed the direct eval. If direct is false, running context will be the execution context for the invocation of the eval function. 6. If direct is true, then a let lex-env be new declarative environment, running context's lexical environment, b let var-env be running context's variable environment, c let private env be running context's private environment. 7. Else, a let lex-env be new declarative environment, eval realm, b let var-env be eval realm, c let private env be null. 8. If strict eval is true, set var-env to lex-env. 9. If running context is not already suspended, suspend running context. 0. Let eval context be a new ECMA script code execution context. 1. Set eval context's function to null. 2. Set eval context's realm to eval realm. 3. Set eval context script or module to running context script or module. 4. Set eval context's variable environment to var-env. 5. Set eval context's lexical environment to lex-env. 6. Set eval context's private environment to private env. 7. Push eval context onto the execution context stack. Eval context is now the running execution context. 8. Let result be completion, eval declaration instantiation, body, var-env, lex-env, private env, strict eval. 9. If result is a normal completion, then a set result to completion, evaluation of body. 0. If result is a normal completion and result is empty, then a set result to normal completion, undefined. 1. Suspend eval context and remove it from the execution context stack. 2. Resume the context that is now on the top of the execution context stack as the running execution context. 3. Return result. 9. 2. 1. To host ensure can compile strings, Corley realm, parameter strings, body string, direct. The host-defined abstract operation host ensure can compile strings takes arguments Corley realm, a realm record, parameter strings, a list of strings, body string, a string, and direct a boolean, and returns either a normal completion containing unused or a throw completion. It allows host environments to block certain ECMA script functions which allow developers to interpret and evaluate strings as ECMA script code. Parameter strings represents the strings that, when using one of the function constructors, will be concatenated together to build the parameters list. Body string represents the function body or the string passed to an eval call. Direct signifies whether the evaluation is a direct eval. The default implementation of host ensure can compile strings is to return normal completion, unused 19.2.1.3 eval declaration instantiation, body, var env, lex env, private env, strict. The abstract operation eval declaration instantiation takes arguments body a script body parse node, var env, an environment record, lex env, a declarative environment record, private env, a private environment record or null, and strict, a boolean, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let var names be the var declared names of body. Let var declarations be the var scope declarations of body. If strict is false, then note the eval code cannot instantiate variable or function bindings in the variable environment of the calling context that invoke the eval if either the code of the calling context or the eval code is strict mode code. Instead, such bindings are instantiated in a new variable environment that is only accessible to the eval code. Bindings introduced by let, const, or class declarations are always instantiated in a new lexical environment. ECMA International 2024 407. If var env is a global environment record, then I for each element name of var names. Do if var env has lexical declaration, name, is true. Throw a syntax error exception. Note: eval will not create a global var declaration that would be shadowed by a global lexical declaration. B let this env be lex env, C assert. The following loop will terminate. D repeat. While the env is not var env, if the env is not an object environment record, then note: the environment of with statements cannot contain any lexical declaration, so it doesn't need to be checked for var-let hoisting conflicts. For each element nam, e var names, do if the env has binding name is true, then I throw a syntax error exception. 2. Note: an xb 3.4 defines alternate semantics for the above step. B note: a direct eval will not hoist var declaration over a like-named lexical declaration. 2. Set the env to the env. Let private identifiers be a new empty list. Let pointer be private env. Repeat. While pointer is not null, for each private name binding of pointer. Do if private identifiers does not contain binding, append binding to private identifiers. B set pointer to pointer. If all private identifiers valid of body with argument private identifiers is false, throw a syntax error exception. Let functions to initialize be a new empty list. Let declared function names be a new empty list. 0. For each element D of var declarations, in reverse list order, do if D is not either a variable declaration, a for binding, or a binding identifier, then I assert D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Note: if there are multiple function declarations for the same name, the last declaration is used. 3. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then if var env is a global environment record, then let fn definable be var env can declare global function fn. B if fn definable is false, throw a type error exception. Append fn to declared function names. Insert D as the first element of functions to initialize. 1. Let declared var names be a new empty list. 2. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier, then I for each string vn of the bound names of D. Do if declared function names does not contain vn, then if var env is a global environment record, then I let vn definable be var env can declare global var vn. 2. If vn definable is false, throw a type error exception. B if declared var names does not contain vn, then I append vn to declared var names. 3. Note: an xb 3 2 3 adds additional steps at this point. 4. Note: no abnormal terminations occur after this algorithm step unless var env is a global environment record and the global object is a proxy exotic object. 5. Let lex declarations be the lexically scoped declarations of body. 6. For each element D of lex declarations, do a note: Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D. Do I if this constant declaration of D is true, then perform lexenv create immutable binding. Dn true 2. Else perform lexenv create mutable binding. Dn false 7. For each parse node f of functions to initialize. Do 408. ECMA International 2024. A let fn be the sole element of the bound names of f. B let fo bi instantiate function object of f with arguments lexenv and private env. See if var.env is a global environment record. Then I perform var.env create global function binding fn fo true d else I let binding exists b var.env has binding fn 2. If binding exists as false, then, note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var.env create mutable binding. Fn, true, perform var.env initialize binding. Fn, fo 3. Else, perform var.env set mutable binding. Fn, fo false 18. For each string vn of declared var names, do if var.env is a global environment record. Then, I perform var.env create global var binding. Vn, true, b else, I let binding exists b var.env has binding. Vn, 2. If binding exists as false, then, note, the following invocation cannot return an abrupt completion because of the validation preceding step 14. Perform var.env create mutable binding. Vn, true, perform var.env initialize binding. Vn, undefined. 9. Return unused. Note an alternative version of this algorithm is described in B 3.4.9. 2. 2 is finite. Number. This function is the is finite intrinsic object. It performs the following steps when called. Let num be. To number. If num is not finite, return false. Otherwise, return true. 9. 2. 3 is nan. Number. This function is the is nan intrinsic object. It performs the following steps when called. Let num be. To number. If num is nan, return true. Otherwise, return false. 9. 2. 4 parse float. String. This function produces a number value dictated by interpretation of the contents of the string argument as a decimal literal. It is the parse float intrinsic object. A reliable way for ECMA script code to test if a value x is none is an expression of the form. Note, x equals x. The result will be true if and only if x is none. ECMA International 2024 409. It performs the following steps when called. Let input string be. To string. Let trimmed string be. Trim string. Input string. Start. Let trimmed be string to code points. Trimmed string. Let trimmed prefix be the longest prefix of trimmed that satisfies the syntax of a str decimal literal, which might be trimmed itself. If there is no such prefix, return none. Let parsed number be parsed text. Trimmed prefix. str decimal literal. Assert. Parsed number as a parse node. Return string numeric value of parsed number. 9. 2. 5 parse int. String. Radix. This function produces an integral number dictated by interpretation of the contents of string according to the specified radix. A leading white space in string is ignored. If radix coalesces to 0, such as when it is undefined, it is assumed to be 10 except when the number representation begins with 0x or 0x, in which case it is assumed to be 16. If radix is 16, the number representation may optionally begin with 0x or 0x. It is the parse int intrinsic object. It performs the following steps when called. Let input string be. To string. Let s be. Trim string. Input string. Start. Let sign be 1. If s is not empty and the first code unit of s is the code unit 0 times 002d, hyphen minus, set sign to -1. If s is not empty and the first code unit of s is either the code unit 0 times 002b plus sign, or the code unit 0 times 002d, hyphen minus, set s to the substring of s from index 1. Let r be r. To int 32. Radix. Let strip prefix be true. If r 0, then if r 2 or r 36, return none, bfr16, set strip prefix to false, else, set r to 10, 0. If strip prefix is true, then, if the length of s is at least 2 and the first two code units of s are either 0x or 0x, then I set s to the substring of s from index 2, 2. Set r to 16, 1. If s contains a code unit that is not a radix r digit, let n be the index within s of the first such code unit. Otherwise, let n be the length of s. 2. Let z be the substring of s from 0 to end. 3. If z is empty, return none. 4. Let mathint be the integer value that is represented by z in radix r notation, using the letters a through z, and a through z for digits with values 10 through 35. However, if r equals 10 and z contains more than 20 significant digits, every significant digit after the 20th of may be replaced by a 0 digit, at the option of the implementation. And if r is not one of 2, 4, 8, 10, 16, or 32, then mathint may be an implementation approximated integer representing the integer value denoted by z in radix r notation. 5. If mathint equals 0, then if sign equals -1, return -0, b return +0. 6. Return sign mathint. Note this function may interpret only a leading portion of string as a number value. It ignores any code units that cannot be interpreted as part of the notation of a decimal literal, and no indication is given that any such code units were ignored. 10. ECMA International 2024. Note this function may interpret only a leading portion of string as an integer value. It ignores any code units that cannot be interpreted as part of the notation of an integer, and no indication is given that any such code units were ignored. 9. 2. 6 URI handling functions. Uniform resource identifiers, or URIs, are strings that identify resources, for example web pages or files, and transport protocols by which to access them, for example HTTP or FTP, on the internet. The ECMA script language itself does not provide any support for using URIs except for functions that encode and decode URIs as described in this section. Encode URI and decode URI are intended to work with complete URIs. They assume that any reserved characters are intended to have special meaning, for example, as delimiters, and so are not encoded. Encode URI component and decode URI component are intended to work with the individual components of a URI. They assume that any reserved characters represent text and must be encoded to avoid special meaning WH. The component is part of a complete URI. 9. 2. 6. 1 decode URI, encoded URI. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI function is replaced with the UTF-16 encoding of the code points that it represents. Escape sequences that could not have been introduced by encode URI are not replaced. It is the %decode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, encoded URI. Let preserve escape set be. At and equals $, return. Decode, URI string, preserve escape set. 9. 2. 6. 2 decode URI component, encoded URI component. This function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI component function is replaced with the UTF-16 encoding of the code points that it represents. It is the %decode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, encoded URI component. Let preserve escape set be the empty string. Return. Decode. Component string, preserve escape set. Note 1. The set of reserved characters is based upon RFC 2396 and does not reflect changes introduced by the more recent RFC 3986. Note 2. Many implementations of ECMA script provide additional functions and methods that manipulate web pages. These functions are beyond the scope of this standard. ECMA International 2024 411 19 2 6. 3 encode URI, URI. This function computes a new version of a UTF-16 encoded 6. 1. 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI %intrinsic object. It performs the following steps when called. Let URI string be. To string, URI, let extra unescape be. At and equals plus $, return. Encode, URI string, extra unescaped, 9, 2, 6, 4 encode URI component. This function computes a new version of a UTF-16 encoded 6, 1, 4 URI in which each instance of certain code points is replaced by 1, 2, 3, or 4 escape sequences representing the UTF-8 encoding of the code point. It is the %encode URI component %intrinsic object. It performs the following steps when called. Let component string be. To string, URI component. Let extra unescape be the empty string. Return. Encode. Component string. Extra unescaped. 9, 2, 6, 5 encode. String. Extra unescaped. The abstract operation encode takes argument string, a string, and extra unescaped, a string, and returns either a normal completion containing a string or a throw completion. It performs URI encoding and escaping, interpreting string as a sequence of UTF-16 encoded code points as described in 6, 1, 4. If a character is identified as unreserved in RFC 2396 or appears in extra unescaped, it is not escaped. It performs the following steps when called. Let L(n) be the length of string. Let R be the empty string. Let always unescaped be the string concatenation of the ASCII word characters and art. Let unescaped set be the string concatenation of always unescaped and extra unescaped. Let 0 repeat. While k, len, let C be the code unit at index k within string. B if unescaped set contains C, then I set k to k plus 1, 2. Set R to the string concatenation of R and C. C else I let CP be code point at string K2. If CP is true, throw a URI error exception. 3. Set K to K plus CP. I've let octets be the list of octets resulting by applying the UTF-8 transformation to CP, V for each element octet of octets. Do return R2. Let hex be the string representation of octet, formatted as an uppercase hexadecimal number. Set R to the string concatenation of R, %, and string pad, hex, 2, 0, start, 412, ECMA International 2024. Note because % encoding is used to represent individual octets, a single code point may be expressed as multiple consecutive escape sequences, one for each of its 8-bit UTF-8 code units. 1926 60 code string, preserve escape set. The abstract operation decode takes argument string, a string, and preserve escape set, a string, and returns either a normal completion containing a string or a throw completion. It performs URI unescaping and decoding, preserving any escape sequences that correspond to basic Latin characters and preserve escape set. It performs the following steps when called. Let len be the length of string. Let R be the empty string. Let 0 repeat. While k, len ABC. Let C be the code unit at index k within string. Let S be E if C is the code unit 0 times 0025, %. Then I if k plus 3, len, throw a URI error exception. 2. Let escape be the substring of string from k to k plus 3. 3. Let B be parse hex octet, string, k plus 1. If B is not an integer, throw a URI error exception. V set k to k plus 2. V. Let n be the number of leading 1 bits in B. 7. If n equals 0, then let SI char be the code unit whose numeric value is B. If preserve escape set contains a SI char, set S to escape. Otherwise, set S to a SI char 8. Else, if n equals 1 or n, 4. Throw a URI error exception. Let octets be B. Let J be 1. Repeat. While J, n, A set k to k plus 1. B if k plus 3, len. Throw a URI error exception. See if the code unit at index k within string is not the code unit 0 times 0025, %. Throw a URI error exception. D let continuation byte be parse hex octet, string, k plus 1. E if continuation byte is not an integer, throw a URI error exception, F append continuation byte to octets, G set K to K plus 2, H set J to J plus 1, assert. The length of octets is n if octets does not contain a valid UTF-8 encoding of a Unicode code point. Throw a URI error exception. Let V be the code point obtained by applying the UTF-8 transformation to octets. That is, from a list of octets into a 21-bit value. Set S to UTF-16 encode code point. V. Set R to the string concatenation of R and S, D, E. Return R. Set K to K plus 1. Note RFC 3629 prohibits the decoding of invalid UTF-8 octet sequences. For example, the invalid sequence 0xC00 times 80 must not decode into the code unit 0 times 0000. Implementations of the decode algorithm are required to throw a URI error when encountering such invalid sequences. ECMA International 2024 413 1926 7 parse hex octet string position. The abstract operation parse hex octet takes argument string, a string, and position, a non-negative integer, and returns either a non-negative integer or a non-empty list of syntax error objects. It parses a sequence of 2 hexadecimal characters at the specified position in string into an unsigned 8-bit integer. It performs the following steps when called. Let len be the length of string. Assert. Position plus 2 len. Let hex digits be the substring of string from position to position plus 2. Let parse result be parse text. String to code points. Hex digits. Hex digits. Sep. If parse result is not a parse node, return parse result. Let n be the MV of parse result. Assert. N is in the inclusive interval from 0 to 255. Return n. 9.3 Constructor properties of the global object 193. 1 aggregate error C205711932 array C2311933 3 array buffer C2514934 begint C2121935 begint 64 array C2325936 begin 64 array C2325937 boolean C2031938 data view C2532938 C21414 copyright sign ECMA International 2024 the 19th of March 2010 error C205 1. The 9th of March 2011 eval error C20551. The 9th of March 2012 finalization registry C262. 1. The 9th of March 2013 float 32 array C232. 5. The 9th of March 2014 float 64 array C232. 5. The 9th of March 2015 function C202. 1. The 9th of March 2016 int 8 array C232. 5. The 9th of March 2017 int 16 array C232. 5. The 9th of March 2018 int 32 array C232. 5. The 9th of March 2019 map C24. 1. 1. The 9th of March 2020 number C21. 1. 1. The 9th of March 2021 object C20. 1. 1. The 9th of March 2022 promise C27. 2. 3. ECMA International 2024. 15. The 19th of March 2023 proxy C28. 2. 1. The 9th of March 2024 range error C20. 5. 5. 2. The 9th of March 2025 reference error C20. 5. 5. 3. The 9th of March 2026 Regi XP C22. 2. 4. The 19th of March 2027 set C24. 2. 1. The 9th of March 2028 shared array buffer C25. 2. 3. The 9th of March 2029 string C22. 1. 1. The 9th of March 1930 symbol C20. 4. 1. The 9th of March 1931 syntax error C20555. The 9th of March 1932 type error C20555. The 9th of March 1933 int 8 array C232. The 9th of March 1934 runt 8 clamped array C232. The 9th of March 1935 int 16 array C232. 16. Copyright sign ECMA International 2024. The 19th of March 1936 int 32 array C232. 3.37 URI error C20556. The 9th of March 1938 weak map C243. The 9th of March 1939 weak ref C261. The 9th of March 1940 weak set C24.4. 9.4 Other properties of the global object 9.4. 1 Atomics C25.4. 194. 2 JSON C25.5. 194. 3 Math C21.3. 194. 4 Reflect C28.1. 0 Fundamental Objects 0.1 Objects 0 1 The object constructor. The object constructor is %object is the initial value of the object property of the global object, creates a new, ordinary object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. ECMA International 2024 417 2011 object value. This function performs the following steps when called. If new target is neither undefined nor the active function object, then return ordinary create from constructor new target %object prototype %. If value is either undefined or null, return ordinary object create %object prototype %. Return to object value 0 1. 2 Properties of the object constructor. The object constructor has an internal slot whose value is %function prototype %, has a length property whose value is 1, has the following additional properties 0, 1, 2, 1 Object assign, target, sources. This function copies the values of all of the enumerable own properties from one or more source objects to a target object. It performs the following steps when called. Let be to object target. If only one argument was passed, return to for each element next source of sources. Do if next source is neither undefined nor null, then I let from B. To object next source 2. Let keys be from 3. For each element next key of keys. Do let desk be from next key. If desk is not undefined and desk is true, then a let proper value be. Get from next key be perform. Set to next key proper value true. Return to the length property of this function is 2 0 1 2 2 object create O properties. This function creates a new object with a specified prototype. It performs the following steps when called. If O is not an object and O is not null, throw a type error exception. Let obj be ordinary object create O. If properties is not undefined, then return object defined properties obj properties 4. Return obj 0 1 2 3 object defined properties O properties. This function adds own properties and or updates the attributes of existing own properties of an object. It performs the following steps when called. 18 Copyright sign ECMA International 2024 1. If O is not an object, throw a type error exception. Return object defined properties O properties 0 1 2 3 1 object defined properties O properties. The abstract operation object defined properties takes arguments O, an object, and propert is an ECMA script language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let props be to object properties. Let keys be props. Let descriptors be a new empty list. For each element next key of keys, Do a let propDesc be props. Next key, be if propDesc is not undefined and propDesc is true. Then I let desc obj be. Get props. Next key 2. Let desc be. To property descriptor, desc obj 3. Append the record, desc, to descriptors. For each element property of descriptors, do a perform. Define property or throw, O, property 6. Return O, 0, 1, 2. For object define property, O, P, attributes. This function adds an own property and or updates the attributes of an existing own property of an object. It performs the following steps when called. If O is not an object, throw a type error exception. Let key B. To property key, P. Let desc B. To property descriptor, attributes. Perform. Define property or throw, O, key, desc. Return O, 0, 1, 2, 5 object entries. O, this function performs the following steps when called. Let obj be. To object, O, let entry list be. Enumerable own properties, obj, key plus value. Return create array from list, entry list. 0, 1, 2, 6 object freeze. O, this function performs the following steps when called. If O is not an object, return O. Let status be. Set integrity level, O. Frozen if status is false. Throw a type error exception. Return O, 0, 1, 2, 7 object from entries. Iterable. This function performs the following steps when called. Perform. Require object coercible. Iterable. Let obj be ordinary object create. Object prototype assert. OBJ is an extensible ordinary object with no own properties. ECMA International 2024 419 4. Let closure be a new abstract closure with parameters, key, value, that captures OBJ and performs the following steps when called. A let property key be. To property key be perform. Create data property or throw, OBJ, property key, value. See return undefined. Let adder be create built-in function, closure. 2. Return. Add entries from iterable, obj, iterable, adder. Note the function created for adder is never directly accessible to ECMA script code. 0, 1, 2, 8 object get own property descriptor, O, P. This function performs the following steps when called. Let obj be. To object, O. Let key be. To property key, P. Let desc be obj, key. Return from property descriptor, desc. 0, 1, 2, 9 object get own property descriptors, O. This function performs the following steps when called. Let obj be. To object, O. Let own keys be obj. Let descriptors be ordinary object create. Object prototype %. For each element key of own keys, do a let desc be obj, key be let descriptor be from property descriptor, desc. See if descriptor is not undefined. Perform. Create data property or throw, descriptors, key, descriptor. Return descriptors, 0, 1, 2, 1, 0. Object get own property names. O. This function performs the following steps when called. Return create array from list. Get own property keys, O. String, 0, 1, 2, 1, 1. Object get own property symbols, O. This function performs the following steps when called. Return create array from list. Get own property keys, O. Symbol 2, 0, 1, 2, 1, 1, 1. Get own property keys, O. Type. The abstract operation get own property keys takes arguments O, an ECMA script language value, and type, string or symbol, and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Let obj be. To object, O. Let keys be obj. Let name list be a new empty list. For each element next key of keys, do. If next key is a symbol and type is symbol, or if next key is a string and type is string, then I append next key to name list. 5. Return name list 420. ECMA International 2024 20 1 2 1 2. Object get prototype of This function performs the following steps when called. Let obj be. To object, return obj 0, 1, 2, 1, 3 objects group by items. Callbackfun. Callbackfun should be a function that accepts two arguments grouped by calls callbackfun once for. Note, each element in items, in ascending order, and constructs a new object. Each value returned by callbackfun is coerced to a property key. For each such property key, the result object has a property whose key is that property key and whose value is an array containing all the elements for which the callbackfun return value coerced to that key. Callbackfun is called with two arguments: the value of the element and the index of the element. The return value of group by is an object that does not inherit from %object prototype %. This function performs the following steps when called. Let groups be. Group by items, callbackfun, property. Let obj be ordinary object create null for each record. G of groups. Do a let elements be create array from list. G be perform. Create data property or throw obj G return obj 0, 1, 2, 1 4 object has own P. This function performs the following steps when called. Let obj be. To object let key be. To property key P return has own property obj key 0, 1, 2, 1 5 object is value 1, value 2. This function performs the following steps when called. Return same value, value 1, value 2, 0, 1, 2, 1 6 object is extensible. This function performs the following steps when called. If O is not an object, return false. Return is extensible. 0, 1, 2, 1 7 object is frozen. This function performs the following steps when called. If O is not an object, ret untrue. Return test integrity level frozen. ECMA International 2024 421 20 1 2 18 object is sealed. This function performs the following steps when called. If O is not an object, return true. Return test integrity level sealed. 0, 1, 2, 1 9 object keys. This function performs the following steps when called. Let obj be. To object let key list be. Enumerable own properties obj key return create array from list. Key list 0, 1, 2, 2 0 object prevent extensions. This function performs the following steps when called. If O is not an object, return O. Let status be. If status is false, throw a type error exception. Return O 0, 1, 2, 2 1 object prototype. The initial value of object prototype is the object prototype object. This property has the attributes false, false, false 0, 1, 2, 2 2 object seal. This function performs the following steps when called. If O is not an object, return O. Let status be. Set integrity level sealed. If status is false, throw a type error exception. Return O 0, 1, 2, 2 3 object set prototype of proto. This function performs the following steps when called. Set O2 require object coercible. If proto is not an object and proto is not null, throw a type error exception. If O is not an object, return O. Let status be. Proto. If status is false, throw a type error exception. Return O 0, 1, 2, 2 4 object values. This function performs the following steps when called. Let obj be. To object let value list be. Enumerable own properties obj value return create array from list. Value list 22 ECMA International 2024 20 1 3 properties of the object prototype object. The object prototype object is %object prototype has an internal slot whose value is true, has the internal methods defined for ordinary objects, except for the method, which is as defined in 1 0 4 7 1. Thus, it is an immutable prototype exotic object, has an internal slot whose value is null 0 1 3 1 object prototype constructor. The initial value of object prototype constructor is %object %0, 1, 3, to object prototype his own property, v. This method performs the following steps when called. Let pb. To property key, v. Let ob. To object, this value, return. His own property, o. p. 0, 1, 3. 3 object prototype is prototype of v. This method performs the following steps when called. If v is not an object, return false. Let ob. To object, this value, repeat. A set v2. V. B if v is null, return false. C if same value. O. V is true, return true. 0, 1, 3. 4 object prototype property is enumerable. V. This method performs the following steps when called. Let pb. To property key, v. Let ob. To object, this value, dot. Let desk b. O. P. If desk is undefined, return false. Return desk. Note 1. This method does not consider objects in the prototype chain. Note the ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. Note the ordering of steps 1 and 2 preserves the behavior specified by previous editions of this specification for the case where v is not an object and this value is undefined or null. Copyright sign, ECMA International 2024 423. Note 2. The ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if this value is undefined or null. 0, 1, 3, 5 object prototype to locale string, reserved 1, reserved 2. This method performs the following steps when called. Let O be this value, return. Invoke O to string. The optional parameters to this method are not used but are intended to correspond to the parameter pattern used by ECMA 402 to locale string methods. Implementations that do not include ECMA 402 support must not use those parameter positions for other purposes. Note 2. ECMA 402 intentionally does not provide an alternative to this default implementation. 0, 1, 3, 6 object prototype to string. This method performs the following steps when called. If this value is undefined, return object undefined. If this value is null, return object null. Let O be. To object, this value, let is array be. Is array O. If this array is true, let boolton tag be array, else if O has an internal slot, let boolton tag be arguments, else if O has an internal method, let boolton tag be function, else if O has an internal slot, let boolton tag be error, else if O has an internal slot, let boolton tag be boolean. 0, else if O has an internal slot, let boolton tag be number. 1, else if O has an internal slot, let boolton tag be string. 2, else if O has an internal slot, let boolton tag be date. 3, else if O has an internal slot, let boolton tag be regexp. 4, else, let boolton tag be object. 5, let tag be get. Add to string tag. 6, if tag is not a string, set tag to boolton tag. 7, return the string concatenation of object, tag, and. Note 1. This method provides a generic to locale string implementation for objects that have no locale sensitive to string behavior. Array, number, date, and %typed array provide their own locale sensitive to locale string methods. Note historically, this method was occasionally used to access the string value of the internal slot that was used in previous editions of this specification as a nominal type tag for various built-in objects. The above definition of toString preserves compatibility for legacy code that uses toString as a test for those specific kinds of built-in objects. It does not provide a reliable type testing mechanism for other kinds of built-in or program-defined objects. In addition, programs can use at toString tag in ways that will invalidate the reliability of such legacy type tests. 24. ECMA International 2024 2013 7 object prototype value of. This method performs the following steps when called. 1. Return. To object, this value, normative optional, Legacy 0, 1, 3, 8 object prototype. Prota object prototype. Proto is an accessor property with attributes. False. True. The attributes are defined as follows: 0, 1, 3, 8, 1 get object prototype. Prota, the value of the let O be. To object this value, return O 0, 1, 3, 8, 2 set object prototype. Prota, the value of the let O be. Require object coercible this value. If proto is not an object and proto is not null, return undefined. If O is not an object, return undefined. Let status be O proto. If status is false, throw a type error exception, return undefined. Normative optional. Legacy 0, 1, 3, 9 legacy object prototype accessor methods 0, 1, 3, 9, 1 object prototype. Define getter p getter. This method performs the following steps when called. Let O be. To object this value, if this callable getter is false, throw a type error exception. Let desk be property descriptor true. True. Let key be. To property key p perform. Define property or throw O key desk. Return undefined. ECMA International 2024 425 20 1 3 9 2 object prototype. Define setter p setter. This method performs the following steps when called. Let O be. To object this value, if this callable setter is false, throw a type error exception. Let desk be property descriptor true. True. Let key be. To property key p perform. Define property or throw O key desk. Return undefined. 0, 1, 3, 9 3 object prototype. Lookup getter p. This method performs the following steps when called. Let O be. To object this value, let key be. To property key p repeat. Let desk be. O key be. If desk is not undefined, then if this accessor descriptor desk is true, return desk. 2. Return undefined. C set O to O D. If O is null, return undefined. 0, 1, 3, 9 4 object prototype. Lookup setter p. This method performs the following steps when called. Let O be. To object this value, let key be. To property key p repeat. Let desk be. O key be. If desk is not undefined, then if this accessor descriptor desk is true, return desk. 2. Return undefined. C set O to O D. If O is null, return undefined. 0, 1, 4 properties of object instances. Object instances have no special properties beyond those inherited from the object prototype object. 0.2 function objects. 0, 2, 1 the function constructor. The function constructor is %function is the initial value of the function property of the global object. Creates and initializes a new function object when called as a function rather than as a constructor. Thus the function call function is equivalent to the object creation expression new function with the same arguments. 26. ECMA International 2024. Comma may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified function behavior must include a supercall to the function constructor to create and initialize a subclass instance with the internal slots necessary for built-in function behavior. All ECMA script syntactic forms for defining function objects create instances of function. There is no syntactic means to create instances of function subclasses except for the built-in generator function, async function, and async generator function subclasses. 0, 2, 1, 1 function, parameter args, body arg. The last argument, if any, specifies the body executable code of a function. Any preceding arguments specify formal parameters. This function performs the following steps when called. Let C be the active function object. If body arg is not present, set body arg to the empty string. Return. Create dynamic function. C. New target. Normal. Parameter args. Body arg. 0, 2, 1, 1, 1. Create dynamic function. constructor, new target, kind, parameter args, body arg. The abstract operation create dynamic function takes arguments constructor, a constructor, new target, a constructor, kind normal, generator, async, or async generator, parameter args, a list of ECMA script language values, and body arg, an ECMA script language value, and returns either a normal completion containing an ECMA script function object or a throw completion constructor as the constructor function that is performing this action. New target is the constructor that new was initially applied to. Parameter args and body arg reflect the argument values that were passed to constructor. It performs the following steps when called. If new target is undefined, set new target to constructor. If kind is normal, then a let prefix be function, b let x sim be the grammar symbol function expression, c let body sim be the grammar symbol function body, yield, await, d let parameter sim be the grammar symbol formal parameters, ye, eld, await, e let fallback proto be percent function prototype percent, else if kind is generator, then a let prefix be function, b let x sim be the grammar symbol generator expression, c let body sim be the grammar symbol generator body, d let parameter sim be the grammar symbol formal parameters, plus yield, await, e let fallback proto be percent generator function prototype percent, else if kind is async, then a let prefix be async function, b let x sim be the grammar symbol async function expression, c let body sim be the grammar symbol async function body, d let parameter sim be the grammar symbol formal parameters, yield, plus await, e let fallback proto be percent async function prototype percent, else assert, kind is async generator, b let prefix be async function, c let x sim be the grammar symbol async generator expression. Note it is permissible but not necessary to have one argument for each formal parameter to be specified. For example, all three of the following expressions produce the same result. New function, a, b, c, returner plus b plus c, new function, a, b, c, returner plus b plus c, new function, a, b, c, returner plus b plus c, ECMA International 2024 427, d let body sim be the grammar symbol async generator body, e let parameter sim be the grammar symbol formal parameters, plus yield, plus await, f let fallback proto be percent async generator function prototype percent, let arg count be the number of elements in parameter args, let parameter strings be a new empty list. For each element arg of parameter args, do append to string arg to parameter strings, let body string be to string body arg 0, let current realm be the current realm record 1, perform host ensure can compile strings, current realm, parameter strings, body string, false 2, let p be the empty string 3, if arg count 0, then a set p to parameter strings 0, b let k be 1, c repeat, while k arg count. I let next arg string be parameter strings, k, 2. Set p to the string concatenation of p, a comma, and next arg string, 3. Set k to k plus 1, 4. Let body parse string be the string concatenation of 0 times 0, 0, 0, line feed, body string, and 0 times 0, 0, 0, line feed, 5. Let source string be the string concatenation of prefix, anonymous, p, 0 times 0, 0, 0, line feed, body parse string, and 6. Let source text be string to code points, source string, 7. Let parameters be parse text, string to code points, p, parameter sim, 8. If parameters is a list of errors, throw a syntax error exception, 9. Let body be parse text, string to code points, body parse string, body sim 0. If body is a list of errors, throw a syntax error exception 1. Note, the parameters and body are parsed separately to ensure that each is valid alone. For example, new function, comma comma does not evaluate to a function 2. Note, if this step is reached, source text must have the syntax of expressim, although the reverse implication does not hold. The purpose of the next 2 steps is to enforce any early error rules which apply to expressim directly. 3. Let expa be parse text, source text, expression. 4. If expr is a list of errors, throw a syntax error exception. 5. Let proto be. Get prototype from constructor. New target. Fallback prota. 6. Let env be current realm. 7. Let private env be null. 8. Let f be ordinary function create. Prota. Source text. Parameters. Body. Non-lexical this. env. Private env. 9. Perform cert function name. F. Anonymous. 0. If kind is generator, then a let prototype be ordinary object create. Percent generator function prototype percent be perform. Define property or throw. F. Prototype. Property descriptor. Prototype. True. False. False. 1. Else if kind is a sync generator, then a let prototype be ordinary object create. Percent async generator function prototype percent be perform. Define property or throw. F. Prototype. Property descriptor. Prototype. True. False. False. 2. Else if kind is normal, then a perform make constructor. F. 3. Note. Functions whose kind is async are not constructible and do not have an internal method or a prototype property. 4. Return F. 428. ECMA International 2024. Note create dynamic function defines a prototype property on any function it creates whose kind is not async to provide for the possibility that the function will be used as a constructor. 2. Two properties of the function constructor. The function constructor is itself a built-in function object, has an internal slot whose value is %function prototype %, has a length property whose value is 1, has the following properties: 0, 2, 1 function prototype. The value of function prototype is the function prototype object. This property has the attributes false, false, false. 0, 2, 3 properties of the function prototype object. The function prototype object is %function prototype is itself a built-in function object, accepts any arguments and returns undefined when invoked, does not have an internal method. It cannot be used as a constructor with the new operator, has an internal slot whose value is %object prototype does not have a prototype property, has a length property whose value is +0, has a name property whose value is the empty string. 0, 2, 3, 1 function prototype apply. This array. This method performs the following steps when called. Let func be this value if is callable. Func is false. Throw a type error exception if array is either undefined or null. Then a perform prepare for tail call be return. Call func this arg. Let arglist be. Create list from array like array. Perform prepare for tail call return. Call func this arglist. Note: the function prototype object is specified to be a function object to ensure compatibility with ECMA script code that was created prior to the ECMA script 2015 specification. Note 1: this arg value is passed without modification as to this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as to this value. Even though this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2: if func is either an arrow function or a bound function exotic object, then this arg will be ignored by the function in step 6. ECMA International 2024 429 2 function prototype bind. This args. This method performs the following steps when called. Let target be this value if is callable. Target is false. Throw a type error exception. Let f be. Bound function create. Target this args. Let l be 0. Let target has length be. Has own property. Target length. If target has length is true, then a let target len be. Get target length be. If target len is a number, then if target len is plus, then 1. Set l to +2. Else if target len is, then 1. Set l to 0, 3. Else let target len as int be. To integer or infinity, target len assert. target len as int is finite. Let arg count be the number of elements in args. Set L to max. Target len as int. Arg count 0. Perform set function length f L. Let target name be get target name. If target name is not a string, set target name to the empty string 0. Perform set function name f target name bound 1. Return f 0 2 3 3 function prototype call. This args. This method performs the following steps when called. Let func be the this value if this callable func is false. Throw a type error exception. Perform prepare for tail call. Return call func this args. Note 1 function objects created using function prototype binder exotic objects. They also do not have a prototype property. Note 2 if target is either an arrow function or a bound function exotic object, then the this arg passed to this method will not be used by subsequent calls to f. Note 1 that this arg value is passed without modification as the this value. This is a change from edition 3, where an undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as the this value. Even though the this arg is passed without modification, non-strict functions still perform these transformations upon entry to the function. Note 2 if func is either an arrow function or a bound function exotic object, then the this arg will be ignored by the function in step 4. 0, 2, 3, 4 function prototype constructor. The initial value of function prototype constructor is %function %430. Copyright sign ECMA International 2024. 20235 function prototype to string. This method performs the following steps when called. Let func be the this value. If func is an object, func has an internal slot. Func is a sequence of Unicode code points, and host has source text available. Func is true, then a return code points to string func. If func is a built-in function object, return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Additionally, if func has an internal slot and func is a string, the portion of the return string that would be matched by native function accessor opt property name must be the value of func. If func is an object and is callable, func is true. Return an implementation-defined string source code representation of func. The representation must have the syntax of a native function. Throw a type error exception. Native function native function accessor opt property name yield await opt formal parameters yield await native code native function accessor get set 0 2 3 6 function prototype at has instance v. This method performs the following steps when called. Let f be the this value. Return ordinary has instance f v. This property has the attributes false false false. This is the default implementation of at has instance that most functions inherit. At has instance note is called by the instantiaf operator to determine whether a value is an instance of a specific constructor. An expression such as v instantiaf f evaluates as f at has instance v. A constructor function can control which objects are recognized as its instances by instantiaf by exposing a different at has instance method on the function. This property is non-writable and non-configurable to prevent tampering that could be used to globally expose the target function of a bound function. The value of the name property of this method is symbol his instance 202 4 function instances. Every function instance is an ECMA script function object and has the internal slots listed in table 30. Function objects created using the function prototype bind method 20232 have the internal slots listed in table 31. Function instances have the following properties. ECMA International 2024 431 20241 length. The value of the length property is an integral number that indicates the typical number of arguments expected by the function. However, the language permits the function to be invoked with some other number of arguments. The behavior of a function when invoked on a number of arguments other than the number specified by its length property depends on the function. This property has the attributes false, false, true, 0, 2, 4. To name, the value of the name property is a string that is descriptive of the function. The name has no semantic significance but is typically a variable or property name that is used to refer to the function at its point of definition in ECMA script source text. This property has the attributes false, false, true, anonymous functions. Objects that do not have a contextual name associated with them by the specification use the empty string as the value of the name property. 0, 2, 4, 3. Prototype function instances that can be used as a constructor have a prototype property. Whenever such a function instance is created, another ordinary object is also created and is the initial value of the function's prototype property. Unless otherwise specified, the value of the prototype property is used to initialize the internal slot of the object created when that function is invoked as a constructor. This property has the attributes true, false, false, 0, 2, 5. Host has source text available. Func, the host-defined abstract operation host has source text available, takes argument func, a function object, and returns a boolean. It allows host environments to prevent the source text from being provided for func. An implementation of host has source text available must conform to the following requirements. It must be deterministic with respect to its parameters. Each time it is called with a specific func as its argument, it must return the same result. The default implementation of host has source text available is to return true 0.3 boolean objects 0, 3, 1. The boolean constructor. The boolean constructor is %boolean is the initial value of the boolean property of the global object, creates and initializes a new boolean object when called as a constructor, performs a type conversion when called as a function rather than as a constructor, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified Boolean behavior must include a supercall to the Boolean constructor to create and initialize the subclass instance with the internal slot. Function objects created using function prototype bind, or by evaluating a method definition. Note, that is not a generator method or a sync generator method, or an arrow function do not have a prototype property. 32. ECMA International 2024 203 1. 1 boolean value. This function performs the following steps when called. Let B be to boolean value. If new target is undefined, return B. Let O be ordinary. Create from constructor new target %boolean prototype set O to B. Return O. 0, 3, 2. Properties of the Boolean constructor. The Boolean constructor has an internal slot whose value is %function prototype %h as the following properties 0, 3, 2, 1. Boolean prototype. The initial value of Boolean prototype is the Boolean prototype object. This property has the attributes false, 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 0, 3. 3. Properties of the Boolean prototype object. The Boolean prototype object is %boolean prototype is an ordinary object, is itself a Boolean object. It has an internal slot with the value false, has an internal slot whose value is %object prototype 0, 3, 3. 1. Boolean prototype constructor. The initial value of Boolean prototype constructor is %boolean 0, 3, 3. 2. Boolean prototype to string. This method performs the following steps when called. Let B be this Boolean value, this value. If B is true, return true, else return false. 0, 3, 3. 3. Boolean prototype value of this method performs the following steps when called. 1. Return this Boolean value, this value. 0, 3, 3, 3. 1. This Boolean value, value. The abstract operation this Boolean value takes argument value, an ECMA script language value, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. If value is a Boolean, return value. If value is an object and value has an internal slot, then ECMA International 2024 433. A let B be value. B assert. B is a Boolean. C return B. Throw type error exception. 0, 3, 4 properties of Boolean instances. Boolean instances are ordinary objects that inherit properties from the Boolean prototype object. Boolean instances have an internal slot. The internal slot is the Boolean value represented by this Boolean object. 0.4 symbol objects. 0, 4, 1. The symbol constructor. The symbol constructor is %symbol is the initial value of the symbol property of the global object. Returns a new symbol value when called as a function. Is not intended to be used with the new operator. Is not intended to be subclassed. May be used as the value of an extends clause of a class definition, but a supercall to it will cause an exception. 0, 4, 1. 1 symbol. Description. This function performs the following steps when called. If new target is not undefined, throw a type error exception. If description is undefined, let desc string be undefined. Else, let desc string be. To string. Description. Return a new symbol whose is desc string. 0, 4. 2 properties of the symbol constructor. The symbol constructor has an internal slot whose value is %function prototype has the following properties. Async. Async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1 function code is generally provided as the bodies of function definitions. 15.2, arrow function definitions. 15.3, method definitions. 15.4, generator function definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20211, the generator function constructor 27311, and the async function constructor 27711. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. Strict mode code. An ECMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive, function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1. 2. 3. Non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined within ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: up equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as up equals b high g exec, c map, d, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217. Capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuator template substitution tail, input element hashbang or regexp, white space, line terminator comment token hashbang comment regular expression literal. 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMA script source text, ZWMBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 18 ECMA International 2024 2.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF. U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, no 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36. ECMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS. 2.3 white space. Tab. VT. FF. ZWMBSP. USP. Line terminators. Like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. MCR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024 219. The ECMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U plus 000. Line feed. LF. U plus 000D. Carriage return CR. U plus 2028. Line separator. LS. U plus 2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax: line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements of the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax: comment, multi-line comment, single-line comment. 20. ECMA International 2024. Multi-line comment charsoft, multi-line comment chars, multi-line not asterisk char, multi-line comment charsoft, post asterisk comment charsoft, post asterisk comment chars. Capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, multi-line comment charsoft, post asterisk comment charsoft, multi-line not asterisk char, source character but not, capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, source character but not one of all. Single line comment charsoft, single line comment chars, single line comment char, single line comment charsoft, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax: hashbang comment, single line comment charsoft. 2.6 Tokens. Syntax: common token, identifier name, private identifier, punctuator, numeric literal string, literal template. Note the div punctuator, regular expression literal, right brace punctuator, and template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 2.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMA script implementations. ECMA script implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode escape sequence, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue. ZWNJ, ZWJ, a SI letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustavwexes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 129.4. Note 1. This standard specifies specific code point additions U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard are not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following prod actions. Identifier name. Identifier start. 1. Let CP be identifier code point of identifier start. 2. Return CP. Identifier name. Identifier name identifier part. 1. Let CPS be identifier code points of the derived identifier name. 2. Let CP be identifier code point of identifier part. 3. Return the list concatenation of CPS and CP. 2. 7. 1. 3. Static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2. 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, In some syntactic production, the keywords of ECMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts of and while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names, those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and, those that are never allowed as identifiers, namely the reserved words listed below except await and yield, those that are contextually allowed as identifiers, namely await and yield, those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public, those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier I is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import and instancia of new null return super switch this throw true try type off var void well with a yield 24 ECMA International 2024. Note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 punctuators syntax. Punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator, equals sign. Right brace punctuator, 2.9 literals, 2, 9, 1 null literals syntax. Null literal, null. ECMA International 2024 225, 2, 9, 2 Boolean literals syntax. Boolean literal, true, false. 2, 9, 3 numeric literals syntax. Numeric literal separator. Numeric literal, decimal literal. Decimal big integer literal non-decimal integer literal, plus sep. Non-decimal integer literal, plus sep. begin literal suffix legacy octal integer literal decimal big integer literal 0 big int literal suffix non-zero digit decimal digits plus sep oct begin literal suffix non-zero digit numeric literal separated decimal digits plus sep begin literal suffix non-decimal integer literal sep binary integer literal sep octal integer literal sep hex integer literal sep begin literal suffix n decimal integer literal decimal digits plus sep oct exponent part plus sep oct decimal digits plus sep exponent part plus sep oct decimal integer literal exponent part plus sep oct decimal integer literal 0 non-zero digit numeric literal separator oct decimal digits plus sep non-octal decimal integer literal decimal digits sep decimal digit sep decimal digit plus sep decimal digits plus sep numeric literal separated decimal digit 1 of 0 1 2 3 4 5 6 7 8 9 26 ECMA International 2024 non-zero digit 1 of 123,456,789 exponent part sep exponent indicator signed integer sep exponent indicator 1 of EE signed integer sep decimal digits sep decimal digits sep decimal digits sep binary integer literal sep 0b binary digits sep 0b binary digits sep binary digits sep binary digit sep binary digit plus sep binary digits plus sep numeric literal separated binary digit 1 of 0 1 octal integer literal sep 0 octal digits sep 0 octal digits sep octal digits sep octal digit sep octal digit plus sep octal digits plus sep numeric literal separator octal digit legacy octal integer literal 0 octal digit legacy octal integer literal octal digit non-octal decimal integer literal 0 non-octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal decimal integer literal decimal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L 0 octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit 1 of 1,234,567 non-octal digit 1 of 89 ECMA International 2024 227 hex integer literal sep 0x hex digits sep 0x hex digits sep hex digits sep hex digit sep hex digit plus sep hex digits plus sep numeric literal separator hex digit 1 of 0 1 2 3 4 5 6 7 8 9 abdef abcdef the source character immediately following a numeric literal must not be an identifier start or decimal digit 2 9 3 1 static semantics early errors numeric literal legacy octal integer literal decimal integer literal non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code. This syntax is legacy 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type, comma the MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, comma the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal, 10e, where e is the MV of exponent part, comma the MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, comma the MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, comma the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, comma the MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal, 10e, where e is the MV of exponent part, comma the MV of decimal integer literal. 0 is 0, comma the MV of decimal integer literal. Non-zero digit numeric literal separator octodecimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, comma the MV of decimal digits. Decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, comma the MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, comma the MV of exponent part. Exponent indicator signed integer is the MV of signed integer, comma the MV of signed integer. Decimal digits is the negative of the MV of decimal digits, comma the MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 28. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, comma the MV of decimal digit. 2 or of non-zero digit, comma the MV of decimal digit. 3 or of non-zero digit, comma the MV of decimal digit. 4 or of non-zero digit, comma the MV of decimal digit. 5 or of non-zero digit, comma the MV of decimal digit. 6 or of non-zero digit, comma the MV of decimal digit. 7 or of non-zero digit, comma the MV of decimal digit. 8 or of non-zero digit, comma the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is, comma the MV of hex digit, A or of hex digit. A is 10, comma the MV of hex digit. B or of hex digit. B is 11, comma the MV of hex digit. C or of hex digit. C is 12, comma the MV of hex digit. D or of hex digit. D is 13, comma the MV of hex digit. E or of hex digit. E is 14, comma the MV of hex digit. F or of hex digit. F is 15, comma the MV of binary digits. binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit, comma the MV of binary digits. Binary digits numeric literal separator. Binary digit is the MV of binary digits plus the MV of binary digit, comma the MV of octal digits. Octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit, comma the MV of octal digits. Octal digits numeric literal separator. Octal digit is the MV of octal digits 8 plus the MV of octal digit, comma the MV of legacy octal integer literal. Legacy octal integer literal. Octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit, comma the MV of non-octal decimal integer literal. Capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L. Non-octal digit is the MV of capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L times 10 plus the MV of non-octal digit, comma the MV of non-octal decimal integer literal. Non-octal decimal integer literal. Decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit, comma the MV of capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L. Octal digit is the MV of capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L times 10 plus the MV of octal digit, comma the MV of hex digits. Hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit, comma the MV of hex digits. Hex digits numeric literal separator. Hex digit is the MV of hex digits 16 plus the MV of hex digit 2 9 3 3. Static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal, return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separated decimal digits big int literal suffix. 1. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. 2. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. 3. Return z, MV, 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string, gliteral, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. LS, PS, escape sequence, line continuation, single string character, source character but not one of or line terminator. LS, PS, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024. Escape sequence, character escape sequence, look ahead decimal digit. Legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as n or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1293, the SV of string literal is the empty string, the SV of string literal is the empty string, the SV of double string characters Double string characters is the string concatenation of the SV of double string character and the SV of double string characters, comma the SV of single string characters. Single string character is the string concatenation of the SV of single string character and the SV of single string characters, comma the SV of double string character. Source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character, comma the SV of double string character. LS is the string value consisting of the code unit 0 times 2028. Line separator, comma the SV of double string character. PS is the string value consisting of the code unit 0 times 2029. Paragraph separator, comma the SV of double string character. Line continuation is the empty string, comma the SV of single string character. Source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character, comma the SV of single string character. LS is the string value consisting of the code unit 0 times 2028. Line separator, comma the SV of single string character. PS is the string value consisting of the code unit 0 times 2029. Paragraph separator, comma the SV of single string character. Line continuation is the empty string, comma the SV of escape sequence. 0 is the string value consisting of the code unit 0 times 0000. Null, comma the SV of character escape sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign. ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B. Line tabulation. VT F 0 times 000C. Form feed. FF R 0 times 000D. Carriage return CR. Double quote 0 times 0022. Quotation mark. Apostrophe 0 times 0027. Apostrophe. Backslash 0 times 005C. Reverse solidus, comma the SV of non-escape character. Source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character, comma the SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence, comma the SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038. Digit 8, comma the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039. Digit 9, comma the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the MV of hex escape sequence, comma the SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits, comma the SV of Unicode escape sequence. U, code point, is the result of performing UTF-16 encode code point on the MV of code point, comma the SV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics. MV, comma the MV of legacy octal escape sequence. 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit, comma the MV of legacy octal escape sequence. 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit, the MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit, the MV of 0 to 3. 0 is 0, the MV of 0 to 3. 1 is 1, the MV of 0 to 3. 2 is 2, the MV of 0 to 3. 3 is 3, the MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence, hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit, the MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit, plus 0 times 10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233. 2. 9. 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2. 1. An implementation may extend the ECMA script regular expression grammar defined in 2. 1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminator but not one of or all. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of, or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. 2 regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the 2 literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22.2.4.34 ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2, 9, 5, 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5, to static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use .dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. Sep. But only if MV of hex digits. 0 times 10ff. Code point. Hex digits. Sep. But only if MV of hex digits 0 times 10ff. Note: template substitution tailors used by the input element. Template tail alternative lexical goal 1, 2, 9, 6. 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence, the TV of no substitution template is the empty string, the TV of template head, $, is the empty string, the TV of template middle, $, is the empty string, the TV of template tail, is the empty string, the TV of template characters. Template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters, the TV of template character, source character but not one of or $, or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character, the TV of template character. $, is the string value consisting of the code unit 0 times 0024. $, the TV of template character. Template escape sequences. The SV of template escape sequence, the TV of template character. Not escape sequences undefined, the TV of template character. Line terminator sequences. The TRV of line terminator sequence. 36. Copyright sign. ECMA International 2024. The TV of line continuation, line terminator sequences the empty string 1, 2, 9, 6, to static semantics, TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV, with the difference being that in TRV, escape sequences are interpreted as they appear in the literal, the TRV of no substitution template is the empty string, the TRV of template head, $, is the empty string, the TRV of template middle, $, is the empty string, the TRV of template tail, is the empty string, the TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters, the TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character, the TRV of template character, $, is the string value consisting of the code unit 0 times 0024, the TRV of template character, template escape sequences the string concatenation of T, he code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence. X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x, the TRV of not escape sequence. X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRV of hex digit, the TRV of not escape sequence. U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter U, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence. U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007B, left curly bracket, the TRV of not escape sequence. U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007B, left curly bracket, and the TRV of not code point, the TRV of not escape sequence. U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007B, left curly bracket, and the TRV of code point, the TRV of decimal digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production, the TRV of character escape sequence. Non-escape character is the SV of non-escape character, the TRV of single escape character. 1 of BFN RTV is the result of performing UTF-16 encode code point on the single code point matched by this production, the TRV of hex escape sequence. X hex digit is the string concatenation of the code unit. 0 times 0078, Latin small letter x. The TRV of the first hex digit, and the TRV of the second hex digit, the TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit. 0 times 0075, Latin small letter u, and the TRV of hex 4 digits, the TRV of Unicode escape sequence. U, code point, is the string concatenation of the code unit. 0 times 0075, Latin small letter u, the code unit. 0 times 007b, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit. 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit, the TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit, the TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF. ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production, the TRV of line continuation. Line terminator sequences the string concatenation of the code unit. 0 times 005C, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence. LF is the string value consisting of the code unit. 0 times 000 line feed, the TRV of line terminator sequence. CR is the string value consisting of the code unit. 0 times 000 line feed, the TRV of line terminator sequence. LS is the string value consisting of the code unit. 0 times 2028 line separator, the TRV of line terminator sequence. PS is the string value consisting of the code unit. 0 times 2029 paragraph separator, the TRV of line terminator sequence. CRLF is the string value consisting of the code unit. 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. 1. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 1.4.7.2.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. 3. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38 ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted auto. Matically, if the semicolon would then be passed as an empty statement, or if that semicolon would become one of the two semicolons in the header of a for statement C14. 7. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression, yield, await. No line terminator here. Plus left-hand side expression, yield, await. No line terminator here. Continue statement, yield, await. Continue, continue. No line terminator here. Label identifier, yield, await. Break statement, yield, await. Break, break. No line terminator here. Label identifier, yield, await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus in yield, await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus in yield, await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield, await. Yield, no line terminator here. Assignment expression in, plus yield, await. Arrow function, in, yield, await. Arrow parameters, yield, await. No line terminator here. Equals. Concise body in. Async function declaration. Yield, await. Default. Async. No line terminator here. Function binding identifier, yield, await. Formal parameters. Yield, plus await. Async function body, plus default. Async. No line terminator here. Function. Formal parameters. Yield, plus await. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield, plus await opt. Formal parameters. Yield, plus await. Async function body. Async method. Yield, await. Async. No line terminator here. Class element name, yield, await. Unique formal parameters. Yield, plus await. Async function body. Async generator declaration. Yield, await. Default. Async. No line terminator here. Function binding identifier, yield, await. Formal parameters. Plus yield, plus await. Async generator body, plus default. Async. No line terminator here. Function. Formal parameters. Plus yield, plus await. Async generator body. Async generator expression. Async. No line terminator here. Function binding identifier, plus yield, plus await opt. Formal parameters. Plus yield, plus await. Async generator body. Async generator method. Yield, await. Async. No line terminator here. Class element name, yield, await. Unique formal parameters. Plus yield, plus await. Async generator body. Async arrow function. In, yield, await. Async. No line terminator here. Async arrow binding identifier, yield. No line terminator here. Equals. Async concise body in. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield, await. No line terminator here. Equals. Async concise body in ECMA International 2024 239. Async arrowhead. Async. No line terminator here. Arrow formal parameters. Yield plus await. The practical effect of these restricted productions is as follows. Comma when a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token. Then a semicolon is automatically inserted before the plus plus or token, comma when a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token. A semicolon is automatically inserted after the continue, break, return, throw, or yield token, comma when arrow function parameter, s, are followed by a line terminator before it equals token. A semicolon is automatically inserted and the punctuator causes a syntax error, comma when an async token is followed by a line terminator before a function or identifier name or token. A semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens, comma when an async token is followed by a line terminator before a token. A semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is, comma a postfix plus plus or operator should be on the same line as its operand, comma an expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token, comma a label identifier in a break or continue statement should be on the same line as the break or continue token, comma the end of an arrow function's parameter, s, and its equals, should be on the same line, comma the async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source, 12. 3, is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertee on rules. In contrast, the source, 1, 2, 3, is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following, 1, 2, 3, which is a valid ECMA script sentence. The source, 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus b, is transformed by automatic semicolon insertion into the following, return, a plus b. The source, a equals b plus plus c, is transformed by automatic semicolon insertion into the following, a equals b plus plus c. The source, if a b else c equals d, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. The source, a equals b plus c, d plus c print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, a equals b plus c, d plus c print, in the circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024 241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, Additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2.1.0.3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending in expression, a semicolon is required if the following line begins with any of the following, comma and opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, comma and opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, comma, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, comma, unary plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, comma, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here. In this version of ECMA script, 2.1.0.3.2, 1 list of grammar productions with optional operands and no line terminator here, comma update expression, comma continue statement, comma break statement, comma return statement, comma yield expression, comma async function definitions, 15.8, with relation to function definitions, 15.2, 42, ECMA International 2024, 3 ECMA script language, expressions, 3.1 identifiers syntax, identifier reference, yield, await, identifier, yield, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, await, identifier name but not reserved word. 3, 1 static semantics, early errors, binding identifier, identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference, await binding identifier, await label identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier, yield, await, yield. It is a syntax error if this production has a yield parameter. Binding identifier, yield, await, ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar are and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier, comma. It is a syntax error if this production has a yield parameter and string value of identifier as yield, comma. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is modular and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2 static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. 1. Let id text unescape the identifier code points of identifier name. 2. Return code points to string id text unescaped. Identifier reference, yield binding identifier, yield label identifier, yield return yield identifier reference, await binding identifier, await label identifier, await return await identifier, identifier name but not reserved word, return the string value of identifier name, private identifier, identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 3. 1. 3 runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield question mark await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Expression plus in yield await. Expression plus in yield await. Dot. Binding identifier yield await. Dot. Binding pattern yield await. Expression plus in yield await. Binding identifier yield await. Expression plus in yield await. Binding pattern yield await. Note 2 in non-strict code. The keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await. The interpretation of capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Parenthesized expression yield await expression plus in yield await 3 2 1 this keyword 3 2 1 1 runtime semantics evaluation primary expression this return resolve this binding 3 2 2 identifier reference C13.1 for identifier reference 1 3 2 3 literals syntax literal null literal boolean literal numeric literal string literal 3 2 3 1 runtime semantics evaluation literal null literal 1 return null literal boolean literal 1 if boolean literal is the token false return false 2 if boolean literal is the token true return true literal numeric literal return the numeric value of numeric literal as defined in 1 2 9 3 literal string literal return the SV of string literal as defined in 1 2 9 4 2 46 ECMA International 2024 3 2 4 array initializer array elements may be elided at the beginning middle or end of the element list whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma. The missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax, array literal, yield, await, elision ort, element list yield await, element list yield await, elision ort, element list, yield, await, elision ort assignment expression, plus in yield await, elision ort spread element yield await, element list yield await, elision ort assignment expression, plus in yield await, element list yield await, elision ort spread element yield await, elision, spread element, yield, await, dot. Assignment expression, plus in yield await, 1 3 2 4 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion, containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ort assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 2. Let init result be. Evaluation of assignment expression 3. Let init value be. Get value, init result 4. Perform. Create data property or throw, array, to string, next int x, init value 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision ort spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision ort assignment expression 1. Set next index 2. Array accumulation of element list with arguments array and next index 2. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. 3. Let init result be. Evaluation of assignment expression. 4. Let init value be. Get value. Init result. 5. Perform. Create data property or throw array to string next int x init value. 6. Return next index plus 1 element list elision spread element 1. Set next index 2. Array accumulation of element list with arguments array and next index 2. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression 1. Let spread ref be. Evaluation of assignment expression 2. Let spread obj be. Get value. Spread ref 3. Let iterator record be. Get iterator. Spread obj. Sync 4. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw array to string next int x next. D set next index to next index plus 1. Note: create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision opt. 1. Let array be. Array create. 0, 2. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. 1. Let array be. Array create. 0, 2. Perform. Array accumulation of element list with arguments array and 0, 3. Return array. Array literal. Element list. Elision opt. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list. Yield await. Property definition list. Yield await. Property definition list. Yield await. Property definition yield await. Property definition list. Yield await. Property definition yield await. Property definition yield await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression plus in yield await. Method definition yield await. Dot. Assignment expression plus in yield await. Property name yield await. Literal property name. Computed property name yield await. 146. 1 static semantics. Early errors. If statement. If. Expression statement else statement. It is a syntax error if is labeled function. The first statement is true. It is a syntax error if is labeled function. The second statement is true. If statement. If. Expression statement. It is a syntax error if is labeled function. Statement. Is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4. 6. 2 runtime semantics. Evaluation. If statement. If. Expression statement else statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value. X per f. If x per value is true, then let stmt completion be completion. Evaluation of the first statement 4. Else let stmt completion be completion. Evaluation of the second statement 5. Return. Update empty. stmt completion. Undefined. If statement. If. Expression statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value. X per f. If x per value is false, then return undefined 4. Else let stmt completion be completion. Evaluation of statement be return. Update empty. stmt completion. Undefined. 4.7 iteration statement syntax. Iteration statement. Yield. Await. Return. Do while statement yield await return. While statement yield await return. For statement yield await return. For an of statement yield await return. 4. 7. 1 semantics. 4. 7. 1. 1 loop continues. Completion. Label set. The abstract operation loop continues takes arguments completion, a completion record, and label set, a list of strings, and returns a boolean. It performs the following steps when called. If completion is a normal completion, return true. If completion is not a continue completion, return false. If completion is empty, return true. 00. ECMA International 2024. 4. If label set contains completion, return true. Return false. 4. 7. 1. 2 runtime semantics. Loop evaluation. The syntax-directed operation loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Iteration statement. Do while statement. Return. Do while loop evaluation of do while statement with argument label set. Iteration statement. While statement. Return. While loop evaluation of while statement with argument label set. Iteration statement. For statement. Return. For loop evaluation of for statement with argument label set. Iteration statement. For an of statement. Return. For an of loop evaluation of for an of statement with argument label set 1 4 7 2 do while statement. Syntax. Do while statement. Yield. Await. Return. Do statement yield await return. While. Expression. Plus in yield await. 4 7 2 1 static semantics. Early errors. Do while statement. Do statement while. Expression. It is a syntax error if is labeled function. Statement. Is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented 1 4 7 2 2 runtime semantics. Do while loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Do while statement. Do statement while. Expression. Let v be undefined 2. Repeat. Let stmt result be completion. Evaluation of statement. B if loop continues. stmt result. Label set. Is false. Return. Update empty. stmt result. V. See if stmt result is not empty. Set v to stmt result. D let x per f be. Evaluation of expression. Note within the statement part of an iteration statement a continue statement may be used to begin a new iteration. Copyright sign. ECMA International 2024 301. E let x per value b. Get value, x per f. If to boolean, x per value, is false. Return v. 4, 7, 3 while statement syntax. While statement, yield, await, return, while, expression, plus in yield await, statement yield await return. 4, 7, 3, 1 static semantics, early errors. While statement, while, expression statement. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented 1.4.7.3 to runtime semantics. While loop evaluation, the syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. While statement, while, expression statement, let v be undefined 2. Repeat, a let x per f be. Evaluation of expression, b let x per value be. Get value, x per f. See if to boolean, x per value, is false. Return v. D let stmt result be completion. Evaluation of statement, e if loop continues. Stmt result, label set, is false. Return. Update empty. Stmt result, v. F if stmt result is not empty, set v to stmt result. 4, 7. Fourth F for statement syntax. For statement, yield, await, return. 4. Look ahead let, expression, in yield await opt. 1 4, 7, 4, 1. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4. The variable declaration list, in yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4. Lexical declaration, in yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. Static semantics, early errors. For statement, 4. Expression not. Expression not. Expression not statement. 4. The variable declaration list. Expression not. Expression not statement. 4. L. Lexical declaration expression not. Expression not statement. 02. ECMA International 2024. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. For statement, 4. Lexical declaration expression not. Expression not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4, 7, 4. To runtime semantics. For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For statement, 4. Expression not. Expression not. Expression not statement. If the first expression is present, then a let x per f be. Evaluation of the first expression be perform. Get value, x per f. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, 4. The variable declaration list. Expression not. Expression not statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, 4. Lexical declaration expression not. expression or statement. Let all dnv be the running execution context's lexical environment. Let loop env be new declarative environment. Old env, let is const be is constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do if is const is true, then I perform loop env create immutable binding. Dn true be else I perform loop env create mutable binding. Dn false set the running execution context's lexical environment to loop env. Let for DCL be completion evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to old env be return for DCL. If this const is false, let per iteration lets be bound names, otherwise let per iteration lets be a new empty list. 0. If the first expression is present, let test be the first expression, otherwise let test be empty. 1. If the second expression is present, let increment be the second expression, otherwise let increment be empty. 2. Let body result be completion for body evaluation, test, increment, statement, per iteration lets, label set. 3. Set the running execution context's lexical environment to old env. 4. Return body result. Copyright sign, ECMA International 2024 303. 14. 7. 4. 3 for body evaluation, test, increment, STMT, per iteration bindings, label set. The abstract operation for body evaluation takes arguments test, an expression pars node or empty, increment, an expression pars node or empty, STMT, a statement pars node, per iteration bindings, a list of strings, and label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration environment. Per iteration bindings. Repeat. If test is not empty, then I let test ref be. Evaluation of test. 2. Let test value be. Get value. Test ref. 3. If to boolean, test value, is false, return v. B let result be completion. Evaluation of STMT. See if loop continues. Result. Label set. Is false. Return. Update empty. Result. V. D if result is not empty. Set v to result. Perform. Create per iteration environment. Per iteration bindings. F if increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value, incref. 4. 7. 4. 4 create per iteration environment, per iteration bindings. The abstract operation create per iteration environment takes argument per iteration bindings, a list of strings, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. B let outer be last iteration env. C assert. Outer is not null. D let this iteration env be new declarative environment. Outer. E for each element bn of per iteration bindings. Do I perform this iteration env create mutable binding. Bn false. 2. Let last value be last iteration env get binding value. Bn true. 3. Perform this iteration env initialize binding. Bn last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04. ECMA International 2024. 14. 7. 5 the for in, for of, and for await of statement syntax. For in of statement, yield, await, return. 4. Look ahead let, left-hand side expression yield await, in, expression, plus in yield await, statement yield await return. 4. var for binding yield await, in expression, plus in yield await, statement yield await return. 4. For declaration yield await, in expression, plus in yield await, statement yield await return. 4. Look ahead, let, async of, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return. 4. var for binding yield await, of assignment expression, plus in yield await, statement yield await return. 4. For declaration yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, look ahead left hand side expression yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, var for binding yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, for declaration yield await, of assignment expression, plus in yield await, statement yield await return. For declaration, yield await, let or const for binding yield await, for binding, yield await, binding identifier yield await, binding pattern yield await. Note this section is extended by an XB 3.5.147.5.1 static semantics, early errors for in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await, left-hand side expression of assignment expression statement. For await, var for binding of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if is labeled function statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. Copyright sign, ECMA International 2024 305. For in of statement. 4. Left-hand side expression in expression statement. 4. Left-hand side expression of assignment expression statement. For await, left-hand side expression of assignment expression statement. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. For in of statement. 4. For declaration in expression statement. 4. For declaration of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if the bound names of for declaration contains let. It is a syntax error if any element of the bound names of for declaration also occurs in the are declared names of statement. It is a syntax error if the bound names of for declaration contains any duplicate entries. 4, 7, 5. To static semantics is destructuring. The syntax-directed operation is destructuring takes no arguments and returns a boolean. It is defined piecewise over the following productions. Member expression, primary expression. If primary expression is either an object literal or an array literal, return true, return false. Member expression, expression, member expression. Identifier name member express. On template literal super property. Meter property. New member expression arguments member expression. Private identifier. New expression. New expression. Left-hand side expression. Call expression. Optional expression. Return false. For declaration, let or const for binding. Return is destructuring of for binding. For binding. Binding identifier. Return false. 06. ECMA International 2024. For binding. Binding pattern 1. Return true. Note this section is extended by an XB 3.5, 4, 7, 5, 3 runtime semantics. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z. The syntax-directed operation. Capital F, O, R, capital D, E, C, L, A, R, A, T I O N capital B I N D I N G capital I N I T I A L I Z takes arguments value, an ECMA script language value, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: for declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5. For runtime semantics, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A. The syntax-directed operation, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, takes argument environment a declarative environment record, and returns unused. It is defined piecewise over the following productions: for declaration, let or const for binding. For each element name of the bound names of for binding, do A. If this constant declaration of let or const is true, then I perform environment create immutable binding. Name. True B else, I perform environment create mutable binding. Name. False 2. Return unused. 4, 7, 5. Runtime semantics. For an of-loop evaluation, the syntax-directed operation for an of-loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: for an of statement, for left-hand side expression in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, left-hand side expression, statement, key result, enumerate, assignment, label set. For an of statement, for var for binding in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 307. For an of statement, for declaration in expression statement, let key result be. For an of head evaluation, bound names of for declaration, expression, enumerate, return. For an of body evaluation, for declaration, star, teament, key result, enumerate, lexical binding, label set. For an of statement, for left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For an of statement, for var for binding of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, for binding, statement, key result, iterate, var binding, label set. For an of statement, for declaration of assignment expression statement, let key result be. For an of head evaluation, bound names of for declaration, assignment expression, iterate, return. For an of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, for in of statement, for await, left-hand side expression of assignment expression statement, let key result be, for in of head evaluation, assignment expression, async iterate, return, for in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async, for in of statement, for await, var for binding of assignment expression statement, let key result be, for in of head evaluation, assignment expression, async iterate, return, for in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async, for in of statement, for await, for declaration of assignment expression statement, let key result be, for in of head evaluation, bound names of for declaration, assignment expression, async iterate, return, for in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let old env be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D. Assert. Uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env for each string name of uninitialized bound names. Do I perform new env create mutable binding name false. Set the running execution context's lexical environment to new env. 3. Let exprf be completion evaluation of expr. Set the running execution context's lexical environment to old env. Let expr value be get value exprf. If iteration kind is enumerate, then if expr value is either undefined or null, then I return completion record, break, empty, empty. B let obj be to object, expr value. C let iterator be enumerate object properties. Obj D let next method be jet, iterator, next. E return the iterator record, iterator, next method, false. Else A assert. Iteration kind is either iterate or async iterate. B if iteration kind is async iterate, let iterator kind be async. C else, let iterator kind be sync. D return get iterator, expr value, iterator kind. The abstract operation for an of body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a
I hate the globals.
value or an abrupt complete.
It's like ridiculous.
If iterator kind is not present, set it
I renamed a couple of these things, like the assume globals.
environment. Let V be undefined. Let destructuring be as destructuring.
Not gonna like
Structuring is true and LHS kind
go through these, figure out which ones I renamed,
S is a left hand
make sure they don't overlap with the ones I have,
pattern that is covered.
and figure out which ones need to be separate from the ones I'm erasing.
Iterator record. Iterator record. B
The globals in like video game or like GPU programming,
see if next result is not
it's ridiculous.
for exception. DLS done. If done is true, return V. F let next value be iterator value, next result. G if LHS kind is either assignment or var binding, then I if destructuring is true, then if LHS kind is assignment, then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else A assert LHS kind is var binding. B assert LHS is a for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else let LHS ref be completion. Evaluation of LHS. It may be evaluated repeatedly. If LHS ref is an abrupt completion, then a let status be LHS ref 3. Else a let status be completion. Put value LHS ref. Next value H else I assert LHS kind is lexical binding. 2. Assert LHS as a for declaration. 3. Let iteration env the new declarative environment. Old env I've perform capital F O R capital D E C L A R A T I O N capital B I N D I N G capital I N S T A N T I A of LHS with argument iteration en v for in of body evaluation LHS STMT iterator record iteration kind LHS kind label set iterator kind 4 7 5 7 ECMA International 2024 309 14 7 5 8 Runtime semantics evaluation v set the running execution context's lexical environment to iteration env v. If destructuring is true, then let stat must be completion for declaration binding initialization of LHS with arguments next value and iteration env 7. Else assert LHS binds a single name. Let LHS name be the sole element of bound names of LHS. Let LHS ref be resolve binding LHS name. Let status be completion. Initialize reference binding LHS ref. Next value I of status is an abrupt completion. Then I set the running execution context's lexical environment to old env 2. If iterator kind is async, return async iterator close iterator record status 3. If iteration kind is enumerate, then return status ive. Else assert iteration kind is iterate return iterator close iterator record status j let result be completion evaluation of STMT k set the running execution context's lexical environment to old env l if loop continues result label set is false, then I if iteration kind is enumerate, then 1 return update empty result v2. Else assert iteration kind is iterate set status to completion update empty result v. If iterator kind is async, return async iterator close iterator record status return iterator close iterator record status m. If result is not empty, set v to result binding identifier yield await let binding id be string value of binding identifier return resolve binding id 4 7 5 9 enumerate object properties. O. The abstract operation enumerate object properties takes argument O, an object, and returns an iterator. It performs the following steps when called. Return an iterator object 2 7 1 1 2 whose next method iterates over all the string valued keys of enumerable properties of O. The iterator object is never directly accessible to ECMA script code. The mechanics and order of enumerating the properties is not specified but must conform to the rules specified below. The iterator's throw and return methods are null and are never invoked. The iterator's next method processes object properties to determine whether the property key should be returned as an iterator value. Returned property keys do not include keys that are symbols. Properties of the target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator's next method is ignored. If new properties are added to the target object during enumeration, the newly added properties are not guaranteed to be processed in the active enumeration. A property name will be returned by the iterator's next method at most once in any enumeration. Enumerating the properties of the target object includes enumerating properties of its prototype, and the prototype of the prototype, and so on, recursively. But a property of a prototype is not processed if it has the same 10 copyright sign, ECMA International 2024 name as a property that has already been processed by the iterator's next method. The values of attributes are not considered when determining if a property of a prototype object has already been processed. The enumerable property names of prototype objects must be obtained by invoking enumerate object properties passing the prototype object as the argument. Enumerate object properties must obtain the own property keys of the target object by calling its internal method. Property attributes of the target object must be obtained by calling its internal method. In addition, if neither own or any object in its prototype chain is a proxy exotic object, typed array, module namespace exotic object, or implementation provided exotic object, then the iterator must behave as with the iterator given by create for an iterator, O until one of the following occurs: the value of the internal slot of O or an object in its prototype chain changes. A property is removed from O or an object in its prototype chain. A property is added to an object in O's prototype chain, or the value of the attribute of a property of O or an object in its prototype chain changes. Note 1. ECMA script implementations are not required to implement the algorithm in 1.4.7.1.0.2.1 directly. They may choose any implementation whose behavior will not deviate from that algorithm unless one of the constraints in the previous paragraph is violated. The following is an informative definition of an ECMA script generator function that conforms to these rules. Function enumerate object properties. obj const visited equals new set. 4. Const key of reflect own keys. obj if type of key equals symbol. Continue. Const desk equals reflect get own property descriptor. obj key if desk visited add key if desk enumerable yield key. Const proto equals reflect get prototype of obj if proto equals null. Return 4. Const proto key of enumerate object properties. Prota if visited has proto key yield proto key. Note to the list of exotic objects for which implementations are not required to match create for an iterator was chosen because implementations historically differed in behavior for those cases, and agreed in all others. 4, 7, 5, 1, 0 for an iterator objects. A for an iterator is an object that represents a specific iteration over some specific object. For an iterator objects are never directly accessible to ECMA script code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2024 311 14 7 5 1 0 1 create for an iterator object. The abstract operation create for an iterator takes argument object, an object, and returns a for an iterator. It is used to create a for an iterator object which iterates over the own and inherited enumerable string properties of object in a specific order. It performs the following steps when called. Let iterator be ordinary object create. Percent for an iterator prototype percent EYS. Set iterator to object. Set iterator to false. Set iterator to a new empty list. Set iterator to a new empty list. Return iterator 4 7 5 1 0 to the percent for an iterator prototype percent object. The percent for an iterator prototype percent object has properties that are inherited by all for an iterator objects. Is an ordinary object. Has an internal slot whose value is percent iterator prototype percent. Is never directly accessible to ECMA script code. Has the following properties: 4 7 5 1 0 2 1% for an iterator prototype percent dart next. Let O be this value. Assert O is an object. Assert O has all of the internal slots of a for an iterator instance. 1 4 7 5 1 0 3. Let object be O. Repeat. If O is false, then I let keys be object. 2. For each element key of keys, do if key is a string, then A append key to O3. Set O to true. B repeat. While O is not empty, I let R be the first element of O. 2. Remove the first element from O. 3. If there does not exist an element v of O such that same value, R, V, is true, then let desc be object, R. If desc is not undefined, then A append R to O. B if desc is true, return create I to result object, R. False, C set object to object, D set O to object, E set O to false. F if object is null, return create I to result object, undefined, true, 4, 7, 5, 1, 0. 3 properties of for an iterator instances. For an iterator instances are ordinary objects that inherit properties from the %for an iterator prototype %intrinsic object. For an iterator instances are initially created with the internal slots listed in Table 39, 12. Copyright sign, ECMA International 2024. Table 39. Internal slots of for an iterator instances. Internal slot. Type. Description. Object. An object. The object value whose properties are being iterated. Object was visited. A boolean. True if the iterator has invoked on. False otherwise. Visited keys. A list of strings. The values that have been emitted by this iterator thus far. Remaining keys. A list of strings. The values remaining to be emitted for the current object before iterating the properties of its prototype. If its prototype is not null. 14.8 The continue statement syntax. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. 148. 1 static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement. 148. To runtime semantics. Evaluation. Continue statement. Continue. Return completion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion. Empty. Label. 4.9 The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 static semantic.
I gotta like
International 2.
figure out which handles are tied to what. I need to drink some water too.
Directly or indirectly, but not crossing function or static initialization block bound.
What is up with the sound?
Operation statement or a switch statement. 4, 9. To runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier.
That's interesting.
Return completion record. Break. Empty. Label. 4.10 The turn statement syntax. Return statement.
So I think this is a physical device or logical device.
Plus in yield await. 4, 1, 0, 1 runtime semantics. Evaluation.
Why don't they name the logical device as logical device instead of just like device?
Expression. Let x per f be. Evaluation of expression. Let x per value be. Get value x per f. If get generator kind is a sync. Set x per value to. Await x per value.
Oh, this sucks.
Record. Return x per value. Empty. A return statement causes a function to cease execution and, in most cases, returns a value to. Note the caller. If expression is omitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion record during evaluation of the finally block. Legacy 4.11 Fewth statement. Note one use of the legacy with statement is discouraged in new ECMA script code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024.
I used to go. Back to my function, I guess.
Plus in yield await. statement yield await return. 411 1 static semantics. Early errors with statement. With expression statement, it is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function statement is true. Note it is only necessary to apply the second rule if the
What's DPY?
implemented. 411 to runtime. Semantics. Evaluation with statement.
Is this like a different window manager
Evaluation of expression. Let obj
than the normal window that I'm using?
val. Let old env be the running execution.
Open display. Oh,
Let
root is default root window.
obj true. Old
Image create to DPY.
env. Let c be completion. Evaluation of statement. Set the running execution context's lexical environment to old env.
So does this make a reference or a struct or something?
Object environment
And this passes it in, then like populated.
resolution context. It then executes a statement using
This makes an image.
lexical environment.
This is setting a property to it.
Embedded statement, whether nor
Is that all it's doing?
abrupt completion nor exception. The lex
This is a global.
is always restored to its former state. 4.12 The switch statement syntax.
DPY root image. Is that the position it starts from? Like 00 top corner maybe?
Yield,
Planes.
yield, await, return. Case clauses yield, await, return.
But this is called once.
Wait, return opt. Default clause yield, await, return. Case clauses yield, await, return opt. Case clauses yield, await.
Root. Why does this have to be global?
Case clauses yield, await, return. Case clause yield, await, return. ECMA International 2020.
What's a window type? Is that a pointer?
Await, return. Case expression.
Image, that's not a global.
Statement list yield, await, return opt. Default clause yield, await, return. Default statement list yield, await, return opt. 412 1 static semantics. Early errors. Switch statement. Switch. Expression. Case block. It is a syntax error if the lexically declared names of case.
But it is a global. It's X image.
It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block.
This should probably be populated to zeros.
Case block evaluation. The syntax-directed operation case block evaluation takes argument input, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Case block, return undefined. Case block,
So is window a handle maybe?
case clause, items in case clauses. In source text order, let found be false. For each case clause C of A. Do, if found is false. Then, I set found to. Case clause is selected. C, input, B if found is true.
Really doesn't matter what it does. That looks fine though.
If R is not
I just want to get running. So, capture desktop is called
empty, R, V, return V. Case block. Case clause sysop, default clause case clause sysop. Let V be undefined. If the first case clauses is PR present, then
inside of a loop
items in the first case
at the top before it paints the frame.
let A be a new empty list. Let found be false.
I know this gets the desktop.
If found is false, then I set found to. Case clause is selected. C, input, B if found.
I'll rename this to like
Let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Let found INB be false. If the second case clauses is present, then
main RAM from VPU, from GPU. Then I'll rename the next one. I don't know, whatever.
ECMA International 2024. For each case clause C of B. Do I have found INB is false. Then set found INB to. Case clause is selected. C. Input 2. If found INB is true, then let R be completion. Evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return. Update empty. R. V 0. If found INB is true, return V 1. Let default be completion.
Main memory.
If defaulter is not empty, set V to defaulter. 3.
Memory.
An abrupt completion, return.
From GPU.
Defaulter. V4. Note. The following is another complete iteration of the second case clauses. 5. For each case clause C of B, do a let R be completion. Evaluation of case clause C. B if R is not empty, set V to R. C if R is an abrupt completion, return. Update empty. R. V6. Return V4. 1 2. 3 case clause is selected. C. Input. The abstract operation case clause is selected takes argument C. A case
I'll rename this one
input. An ECMA
GPU for mem.
completion containing a boolean or an abrupt completion. It determines.
Pretty sure it's what it does.
It performs the following steps when called. Assert. C is an instance of the production case clause. Case expression. Statement list opt. Let X the ref be. Evaluation of the expression of C. Let
It's like a stupid pointless step.
the ref. Return is strictly equal.
Chatbot said I need like
4.
access to get the full video card access.
Statement. Switch. Expression. Case block. Let X the ref be.
You have to like apply for access
Get value. X the ref. Let
because even though you buy the video card,
select
you don't have full access to the product that you bought.
environment. Old env. Perform block declaration instantiation. Case block. Block env. Set the running execution context's lexical environment to block env. Let R be completion. Case block evaluation of case block with argument switch value. Set the running execution context's lexical environment to old env. Return R. Case clause. Case expression. 1. Return empty. Case clause. Case expression. Statement list 1. Return. Evaluation of statement list. Note this operation does not execute C statement ist, if any. The case block algorithm uses its return value to determine which statement list to start executing. Note no matter how control leaves the switch statement, the lexical environment is always restored to its former state. ECMA International 2024-317. Default clause. Default. 1. Return
Chatbot said that it could like remember conversations last time. I don't think it can
4.13 labeled state
because it should be able to remember that.
yield await return label identifier yield await labeled item yield await return labeled item yield await return statement yield await return function declaration yield await default 4 1 3 1 static semantics early errors labeled item function declaration. It is a syntax error.
I don't think this was really expensive.
Note an alternative definition for this rule is provided in B 3.1.14.1.3. 2 static semantics is labeled function STMT. The abstract operation is labeled function takes argument STMT, a statement parse node, and returns a boolean.
So this card on here was like only 230. 270.
Return false. Let item be the labeled item of STMT. If I
So you pay like 270. Means you don't get access to the whole card. And if you pay like
1.3.3 runtime semantics, evaluation labeled statement, label identifier, labeled item, return. Labeled evaluation of this labeled statement with argument. Note a statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMA script has no go-to statement. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively
And the GeForce RTX 280 is at the same time, or a few months before.
International
This is $1,000.
213 for runtime semantics.
So you could pay
Syntax
$300 for a video card,
label set, a list of
or you could pay $999 for a video card.
for an abrupt completion.
And no matter which one you buy, you don't get access to the whole video card.
STMT result be completion.
Because even though you buy the video card, you don't actually own the video card.
Is a break completion. Then, if STMT result is empty,
Which is complete shit.
is empty, set STMT result to normal completion, undefined. 2. Else, set STMT result to normal completion, STMT result, return STMT result, breakable statement, switch statement, let STMT result,
Smash that bot.
evaluation of switch statement. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else, set STMT result to normal completion, STMT result, return STMT result. Note 1. A breakable statement is one that can be exited via an unlabeled break statement. Labeled statement, label identifier, labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let STMT result be completion, labeled evaluation of labeled item with argument new label set. If STMT result is a break completion and STMT result is
Smash the chat bot.
set STMT result to normal completion.
So I can pay $270 or $999
Alt.
for a GPU card. In either way, I still won't have full access
Of function
to the GPU without applying to NVIDIA to get developer access.
expression statement if statement continue statement break statement
Apple has developer access also,
debugger statement return
except you can still access everything without Apple.
have special semantics for labeled
And by access I mean like full access,
international 2012
because there's other like C languages and stuff and other ways to access the Apple API
away
without going through Apple.
in Terminator here
But with the video card, unless OpenCL,
one runtime
I don't know, that check whatever.
throw statement throw expression let x the ref be evaluation of expression let x the value be get value x the ref return throw completion x the value 4.15 tree statement syntax try statement yield await return try block yield await return catch yield await return try block yield await return finally yield await return try block yield await return catch yield await return finally yield await return catch yield await return catch parameter yield await block yield await return catch block yield await return finally yield await return finally block yield await return catch parameter
Because I apparently need to like
binding identifier yield await binding pattern yield await 4 1 5 1 static semantic
to get the desktop in this window.
catch parameter block. It is a syntax error if bound names of catch parameter contains
I need to make a copy of the GPU memory,
of the bound
which means the GPU writes the frame to
the block. It is
the RAM,
if any element of the bound names of catch parameter also occurs
and then I have to like send that back to the GPU.
for this production.
So even though I'm not even going to modify it, I still have to have that delay
Which an exception of
of it being written to the RAM and then having to read from the RAM back to the GPU,
catch clause provides the
where then it's going to apply the filter whatever.
clause catches an exception. Its catch parameter is bound to that exception.
That's like ridiculous. I should be able to access the video card and then make a copy of the frame buffer as it's like on the video card
Directed operation
and then duplicate that to another part of memory,
view
apply the filter, and then output that to another display,
returns either
or to the window, whatever.
containing an ECMA script
Except you can only do that with access to the full GPU, which you don't get as a consumer.
catch,
But with like every other company, or lots of other companies, you can still get the same access to things, like legally, without breaking things,
old ENV,
like without hacking stuff,
of catch parameter,
different ways other than through the main company.
arg name,
But with the GPU, it's all like closed source,
catch EN,
and I don't know.
be complete,
Unless you can do it with OpenCL, I don't think you can. I don't know what it says.
catch ENV if status is an abrupt completion,
So have to do this like really funky read from the GPU, or have the GPU write to the main RAM, and have the main RAM be sent back to the GPU. Even though I don't even modify it, I'm not even going to change it in the RAM. I literally need to waste making a copy and then writing it back
evaluation,
when it could be done completely on the GPU.
and semantics,
And this is like a really old computer. That's why I need it to be on the GPU and not have the CPU involved.
if B is a throw,
But I guess I can't do that because I don't have access.
catch clause evaluation of catch with argument B, else, let CBB, return, update empty,
Shepard says, you're hitting on a very real and frustrating limitation of working with NVIDIA GPUs
block,
on consumer hardware. Direct GPU-based screen capture and frame buffer access
set F,
is not fully open. Here's the hard truth and what your real options are.
ment, try block catch finally,
You can use OpenCL, Vulkan, or CUDA to produce data on the GPU.
let C
You cannot access the GPU's frame buffer directly.
with argument B,
The actual screen tents from the user space on consumer NVIDIA grade cards. This is locked down.
set F,
Even if you spend $999, you still need to apply for NVIDIA, NVFC, NVENC developer access to get low latency capture APIs.
2024 300,
AMD GPUs do not impose these restrictions. With the AMD GPU, AMD RM, you can access frame buffer like data. I need to get an AMD GPU.
debugger, if an implementation defined debugging facility,
This whole NVIDIA thing is just stupid as fuck.
an implementation defined debugging action, B return a new implementation defined completion record, L,
That's what I'm saying here though.
MA script language,
NVIDIA is ridiculous.
to list syntax,
Even AMD, you can go through, I don't know.
formal parameter,
That's why you can't access frame buffer, because they're a monopoly.
await,
It's their internal high performance screen grab API. And to monopolize, you have to have something that other people don't. And you have to like give out access to only specific people.
await, formal parameter,
It says it's locked behind NVIDIA developer agreement. You must apply for access.
formal parameter list yield await,
Without it, you're limited to slower options.
function rest parameter,
CPU based X11 SHM, so that's what I'm using. Whatever X SHM grabs is what I'm using, I guess,
static semantics,
because it shows up in here.
formal parameters, formal parameters,
XSHM.
2024, note evaluating a debug,
Or it says using VK acquire next image
under a debugger,
after you've already presented a frame in your own frame buffer.
observable effect, note various ECMA script language elements called
It says OpenCL with Vulkan. Capture desktop using, so you still have to use XSHM.
of such functions starts with the
Reverse engineered hacking method.
10
Some people use DMA buff on Linux.
error if bound names of formal parameters contains any
Others try to intercept the frame buffer in Wayland.
formal parameter list
Now these work on NVIDIA without significant pain or kernel level access.
is false and bound names of formal parameter list
Render everything yourself.
contents 5 1 2 static
Render to swap chain. 100% GPU.
corrected operate expression takes no argument
How the fuck do I get the desktop? When I'm gonna like render the whole desktop,
property
I'm gonna re-render the entire thing by myself. I'm gonna like get all the icons, all the animations, collect mouse input,
and contains
and re-render everything seen. What the fuck? Is Shepard stupid?
1 return false a
Shepard is stupid.
binding rest element 1. Return contains expression of binding rest element, array binding pattern, binding element list, eligible.
Oh, this is all dumb.
Return contains expression of binding element list, array binding pattern, binding element list, eligible binding rest element.
You do get what you pay for.
If his is true,
So I'm gonna get named, you know,
binding rest element, binding property list, binding property list.
because you don't get what you pay for with NVIDIA.
Contains expression of binding property list. If his is true, return true. Return contains expression of binding property, binding element list, binding element.
So this so far looks fine.
Let us be contains expression of binding element list. If his is true, return true. Return
Now this is even tied to the current stuff. It's just a separate thing.
element, eligible binding element 1. Return contains
But everything above this,
Note multiple occurrences of the same.
to save it back up.
In a formal parameter list is only allowed for functions which have simple parameter lists and which are not defined in strict mode code. ECMA International 2024 323. Binding property. Property name. Binding element. Let his be is computed property key of property name. If his is true, return true. Return contains expression of binding element. Binding element. Binding pattern initializer 1. Return true. Single name binding. Binding identifier 1. Return false.
I'm gonna save it back up.
Binding identifier initializer 1. Return true. Binding rest element. Binding
But I didn't like save the file yet.
binding rest element. Binding pattern. Return contains expression of binding pattern. Formal parameters. Empty. 1. Return false. Formal parameters. Form. Al parameter list. Function rest parameter. If contains expression of formal parameter list is true, return true. Return contains expression of function rest parameter. Formal parameter list. Formal parameter list. Formal parameter. If contains expression of formal parameter list is true, return true. Return contains
It says these two calls. Then it's this call.
binding identifier 1. Return
Mem from GPU.
C O V
I don't know, things going from right to left
A
makes more sense than left to right.
E H E S I Z E D capital E X
So it runs like that.
E S S
I gotta get this one in,
O
then run this one.
A N. Let formals be the array formal parameters that is covered by
So this does the copy from the memory.
R
Bleh.
A R E N T H
Yeah, so the first one's
E D
to memory from GPU.
P R E
Then it's to GPU from memory.
capital A N. Return contains expression of formals. A sync arrow binding identifier. Binding identifier. Return false. 5 1. 3 static semantics is simple
So this part
syntax directed operation.
doesn't involve a Vulkan, whatever, which makes sense.
It is defined piecewise over the following
So that makes a copy, I guess.
element.
A simple one-line call.
324. X
But then to get it to GPU with Vulkan,
initializer 1. Return false.
looks like it's not that simple.
Identifier 1. Return true. Single
I have to like set all these DM structs
1.
to all these stupid values
Empty 1.
to pass in a simple freaking 2D plane of data. This is ridiculous.
Formal parameter list. Function rest
So
parameter
we got temporary called data.
parameter list.
Nothing more descriptive than data.
If is simple
I mean, if you can call something, calling it data is like the best way, the only thing to name it.
simple parameter
I mean, every single thing could be called data.
identifier. Return
So why not call a variable data?
O V E
And it's a void pointer. It doesn't even have a type. Even better.
R E N T H E S I Z E D capital
So device buffer image bytes.
SSION.
Why is data not assigned? Are you kidding me? Is this gonna copy from nowhere? No, wait, no. Image is being passed in. It's passing in bytes per line times dimension height. Why does it have to read from the struct? Okay, I guess the bytes per line could change. Because it might be like 8-bit color, 10-bit color. So I'm not going to bother to pre-compute that. So this part is kind of like variable. Depends on the data, the frame buffer. So let's leave that how it is. This part though, the height, that's like a fixed number or whatever the height is defined as. It's not dependent on byte size. And then it's passing in data. So data must be the destination. So it is null here, and it's gonna hold the address of whatever this is mapped to memory. Oh, that's what it was. Earlier, I was talking about JavaScript, and then I forgot something. It was a weak reference and
variety of other features. While the rest of the application of the promise make it a default object instance or make an object it references the rest of the program. On the web, the code will run as developers now use make it a default X. Then in the body of the function, call to a third-party API at the same time, but they only have which is a function that's called when the object is first created. It can also instance or making them global to the class of indexed items or a set to hold a collection of but can be more easily looped over along with a variety of other features. Now what you should also know at this point is that JavaScript is garbage collected. That means it will automatically deallocate objects from
alright, so this is a weak reference and whatever that one was. That showed up in the documentation last time. That was like, talks about leaks, whatever. Alright, so it says weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or a symbol in a manner that does not leak memory resources. In the absence of weak map or weak set instance, the object or symbol otherwise becomes inaccessible and subject to reclamation by the implementation's garbage collector mechanism. I'm distracted. Anyways. It's talking about leaking memory with these two options, whatever. Weak map and weak set. So like I didn't know because I don't know. They update JavaScript all the time. At one point I didn't care. I was like, so what, they add new stuff, I don't care, whatever. Except now I've realized what that is. And why it relates to memory leaks. Because he says it right here, whatever.
From memory when they're no longer referenced in your code. However, when you have a map, all the properties will always be referenced. If that's not optimal, there's a weak map and weak set that contain properties that can be garbage collected to reduce memory.
So that's what a weak map is. So there's a weak map and a weak set. So I'm still not totally sure. I guess it's like a different kind of map where it's like not supposed to be garbage collected. It's handled differently. So maybe the standard talks about it because they leave it up to who's implementing the standard to decide how they want to manage it. Which means that leaks are not on the standard's fault because it's the guy that wrote and filed the standard and wrote the code, so it's on their fault. If that makes sense.
Memory usage. Now that we have a basic idea of what JavaScript looks like, let's talk about one of its most interesting features, which is its non-blocking event loop. Normally when you write code in a script, it's executed synchronously line by line, which means the next line can't start until the previous line finishes. With an event loop, we can write asynchronous code in JavaScript that runs in a separate...
And asynchronous code sounds like a lame excuse for threading when it's not really threaded. How the hell do you spell asynchronous? Is that how you spell asynchronous? Holy crap. No wonder it's shortened to like async. Does anybody even know how to spell the whole word? Smash the chat button.
Speed dial. 100 plus JavaScript concepts you need to know.
Man, text-to-speech just does not work.
Is a synchronous code a lame excuse for threading that's not actually threaded? Great question. And no, asynchronous code is not a lame excuse for threading. It's a fundamentally different concurrency model, with its own strengths and trade-offs. Let's break this down clearly.
No, it's a lame excuse.
Uses OS-level threads, managed by the operating system, good for CPU-bound work, where multiple threads need to do a lot of processing, comes with complexity, race conditions, locking, thread, safe data structures, expensive in terms of memory and context switching. GAIR, asynchronous programming, async await, runs in a single thread, usually using non-blocking I/O, great for IO-bound tasks, reading files, talking to a database, making network requests. Instead of waiting, blocking, it yields control to do other work until the result is ready, avoids the overhead and complexity of threads, popular in environments like Node.js, Python's Asyncio, JavaScript in browsers, etc. thinking face. So is async a fake thread? Not at all. Async isn't pretending to be threaded. It's solving a different problem, efficient I/O concurrency without needing multiple threads. It's ideal in situations where you're waiting more than working.
Alright, so now I'm gonna shop at this.
So why not just use threading? There is no async at the CPU level, because the CPU is efficient, and the CPU has yield for threads. How the hell are threads more efficient than async? Can you back that up with benchmarks? Great question, and the short answer, threads aren't inherently more efficient than async. They excel in different scenarios, especially in Python where the global interpreter lock, kill, affects threading. Here's a nuanced breakdown backed by benchmarks and real-world experience.
Alright, so now I'm gonna shop at this.
I'm talking about performance. You mentioned they excel in different scenarios. I'm talking about the physical performance, not perception and opinion.
Here's what Shepard said.
One, CPU-bound tasks. A micro benchmark computing the Fibonacci sequence by splitting each step into coroutines and threads found.
Why is it giving this evidence? This evidence says that async is slower. Wait, how much difference is that? This is 100 times slower, and then 200 times slower. I'm gonna shop at this.
What's the difference between 0.12s and 0.126s in percentage form?
5%. 5%. But it said 100 times to 200 times slower. But it's talking about 5%. That's 5% is nowhere near 100 times or 200 times or twice as fast. What the fuck? Chatbot, Makes no sense. And that's talking about coroutines. Those are like, man, context is important. And chatbot's like, fuck context.
What you said there is a 100% difference. Menuing 2 sets as fast, but you output a difference of around 5% this. A micro benchmark computing the Fibonacci sequence by splitting each step into coroutines and threads found. A Syncio version was 100 slower than a direct loop. Threaded version was 200 slower when reused across multiple tasks instead of spawning each time. A sync took 0.12s, thread 0.126s, while direct call was 0.099s.
This is 5% difference. Not 2 times faster or slower. 5%.
You're absolutely right to call this out. Let's clarify the apparent contradiction. And you correctly observed. The difference between 0.12s and 0.126s is only 5%, not 100% so. How can threading be 2 slower, but only differ by 0.006 seconds? Tick. The key. Different benchmarks and phases. There are 2 distinct benchmark phases being referenced. Small blue diamond phase 1, cold run, spawning a new task each time, direct loop, 0.099s, async, 9.9s, 100 slower, threading, 19.8s, 200 slower, backhand index finger pointing right. This is where the 100 and 200 numbers come from. In this case, the overhead of spawning a new coroutine or thread per task dominates. Small blue diamond phase 2, warm optimized run, reuse. Here, the overhead of spawning is eliminated, so all methods perform similarly. You're spot on that the difference is only 5% at this point, because we're no longer testing the full cost of concurrency overhead.
Why don't you include the cost of starting up the operating system, the cost of clicking to log in, the cost of typing to log in, and then say like, oh, it takes like 5 minutes to start a thread, and then 5.82 minutes to start an async. Wow, chatbot is so... This is stupid. Why am I asking chatbot anything? Because it's amusing, that's why. I can't believe people think this is AI. You don't make a thread every single time you need it. You make a fixed number of them, you make a lookup table, and then you jump around in the lookup table so you don't incur the overhead of making a thread the whole program. Anyone that just makes threads when they need them doesn't know how to thread, and they're not even doing it right. So why compare against people who aren't doing it correctly and say that freaking async is more performant. That makes no sense.
Why not just thread then? Because thread creation and switching is expensive, especially at massive scale.
What does this even have to do with it?
And context switching involves the process, and the threads belong to a process and therefore the context. And the context switch has nothing to do with what. Context switching happens regardless of workload, not just on I/O completion.
The chatbot is trying to sound smart. It's putting out concepts and words to influence what I'm thinking, but when I know what it's talking about, it's just full of shit. And then it's like, oh, you're questioning me on my bullshit.
Great observation. You're digging into the core of how context switching actually works. And you're absolutely right to be precise here. Let's unpack that sentence and clarify where it oversimplified.
Oversimplified as fuck.
Tick. You're right. Context switching involves the process, and the threads belong to a process, and therefore the context. Yes. A context switches when the CPU switches from running one thread process to another. This involves saving CPU registers, possibly invalidating CPU caches, updating kernel data structures. For threads, the switch is lighter than for processes, but it's still real and expensive. It involves at least stack pointer change, program counter change, some CPU registers, possibly cache invalidation. So, yes, threads are tied to the process, and context switching is inherently tied to that. It's not arbitrary.
Alright, so I'm gonna ask chatbot something I don't know, but I would assume. And see what chatbot says.
When the OS evaluates the amount of time that a program takes to execute, to evaluate how and when to call it when scheduling other programs, do the threads affect that query? And would threads make the time of the program less if things are threaded because they are not part of the primary thread? You're asking a very insightful systems-level question about how the OS scheduler evaluates program execution time, and how threads factor into that. Let's break it down clearly. Electric light bulb. What you're asking, in simpler terms, when the OS tries to measure how long a program takes, does it consider just the main thread, or all the threads? And if some work is offloaded to threads, does the OS think the program takes less time? Tick. Answer. The OS does consider all threads that belong to a process when measuring the CPU usage or runtime. Threads are not invisible. They are individually scheduled and tracked. Here's how it works. Brain. Key concepts 1. Threads are scheduled individually. Each thread is a schedulable entity in the OS. The OS doesn't see just a program. It sees a set of threads that are part of a process.
Alright, so now let's chat about this.
So since each thread is a schedulable entity in the OS, does that not mean using threads is more performant than async methods which exist only within the main thread? Excellent. You're zeroing in on the core question. If each thread is independently scheduled by the OS, doesn't that make threading inherently more performant than async, which runs everything on a single thread?
Oh my god, chatbot is so annoying.
The answer is no, not necessarily more performant. It depends entirely on the workload and what performance means in that context. Wall time, CPU usage, memory, latency, throughput, etc. This is a lie. Are you saying that the thread is unable to use malloc memory? The call stack frame has nothing to do with the sit-on memory. The same amount of memory as accessible memory per task. Crossmark higher. 512 kilobytes plus stack. Tick. Lower. 2-8 kilobytes per task, and this has all to do with how the programmer is managing the threads as a resource. There is lock-free threading, ease of cancellation control, crossmark hard, need signals, flags. You are entirely biased, misleading, and totally lying. You're absolutely right to demand rigor and to push back on generalized claims, so let's dig into this factually, not opinion-based, and clarify what was oversimplified or poorly stated in my previous response. Small blue diamond, are you saying threads can't use malloc? No, absolutely not. Each thread in a process shares the same heap and same address space. All threads can malloc, free, and access dynamic memory. The thread stack is separate, allocated by the kernel when the thread is created, but that's not the limit of the thread's memory. Tick. You are 100% right. Threads can use as much memory as the process. So let me clarify. When I said 512 kilobytes, that's the default stack size per thread. Linux. 512 kilobytes to 8 megabytes depending on system glibc. It's real reserved memory per thread, virtual or physical. I wasn't implying the total memory used by a thread is limited to the stack. Small blue diamond, the call stack frame has nothing to do with system memory. The stack is a region of system memory, usually allocated by the kernel for each thread. Stack frame size per function call is a programming concern, but stack size per thread is an OS kernel concern. You said, is asynchronous code a lame excuse for threading that's not act? Small blue diamond, ease of cancellation control. Lock-free threading exists, yes. Absolutely true. Lock-free and wait-free threading is possible, with atomic operations, co. But the point I failed to express clearly is this. In many mainstream languages, like Python, Java, even C#, thread cancellation and inter-thread coordination still often rely on shared memory plus signaling, flags, condition variables, locks. And these have complexity and you're right that it's not inherently hard. It depends on language, runtime, design choices, so I retract the blanket claim that cancellation control is hard with threads. It can be hard, but not necessarily, especially with lock-free programming and careful design. You are biased and lying, that's a serious statement, and let me be clear. My goal is not to mislead, but I do make generalized. You've caught valid flaws. Async versus threads has nuance, and I oversimplified some key parts. Real performance depends heavily on how the programmer manages memory, concurrency, and task lifecycle, not just whether something uses threads or async. Bottom line, you're absolutely right that threads can be extremely efficient when used correctly. Async is not always more efficient, especially for compute-heavy or well-designed thread-based. What is the stack size of the main thread of a program that has 3 threads? What is the stack size of the main thread on most systems? The main thread stack size 8 megabytes unless explicitly set.
This is why chatbot pisses me off. Right here, chatbot says this.
Main thread stack size 8 megabytes unless explicitly set.
Chatbot also says
512 kilobytes plus stack. That's the default stack size per thread. Linux. 512 kilobytes to 8 megabytes depending on system glibc settings.
So the main thread being main, the main program, the thing is that there's no difference between a main thread and a thread. They're all the same. It's the same fucking thing. And chatbot said here that you can only have 512 kilobytes per thread or up to 8 megabytes per thread. So chatbot is saying that based on context of whatever fucking made up lie ass shit context it's talking about, the main thread is not as powerful as async. Because somehow async can have 2 to 8 kilobytes per task. Yet the main thread that actually runs the async is still limited to the same amount that the threads are limited to, because it's all the same thing. So how the fuck, based on context, could an async operation access more memory than the main, the actual program that runs the program, the single thread? How can it access more than the actual main that's running it? Unless it's virtualized, therefore slower and less performant. Chatbot is so annoying. And chatbot made it sound like threads have this huge limitation. Except threads have the same exact limit as the main. There's no difference. The main actually has the same amount, the same limit as the threads. There's no differentiating. There's no differentiating because it's the same thing. The main is a thread too. It has the same limits. It's not like main has more memory on the stack than the thread does. But chatbot left that part out to make it sound like, oh look, threads are lame. They don't have as much stack space. But the threads have the same exact amount of stack space as the main thread. Because main itself is a thread in the process that's running whatever. So I'm gonna check out this, and I'm done wasting time with Chipbot.
This, when I said 512 kilobytes plus stack per thread, I meant that's the default stack size per thread, Linux. 512 kilobytes to 8 megabytes depending on system glib settings, and this, main thread stack size 8 megabytes unless explicitly set. The main has the same stack limit as the threads. But you made it sound like threads have an inherently smaller stack limit. If you not the main is a thread, and so are threads, there is no difference, and how can you compare if main runs in async? With threads which could have their own async since a thread is basically a main, how can async have 2-8 kilobytes if the main it runs on is only up to 8 MB? And each thread which is basically a main could run its own async, therefore multiplying the async things running.
Since main is basically a thread, and a thread is a main, because it's the same thing. They're the same limits that are imposed on them, because it's all physical. Then you can actually run multiple async on several threads, therefore getting the benefit of threading and async. Async isn't even a benefit. And Chipbot says,
You're absolutely right to point out this subtle but important distinction, and it's worth clarifying precisely.
it is very important, because Chipbot is a fucking liar.
1. Main thread versus other threads. Stack size. Main thread is just a thread, created by the OS when the process starts. The main thread usually has a default stack size. For example, 8 megabytes on Linux. When you create other threads, thread create or similar, the default stack size is often smaller, for example, 2 megabytes on Linux, but this is configurable. So the main thread stack size is often larger by default, but fundamentally it's just a thread like any other, just with a different default stack size. So yes, I gave the impression threads inherently have smaller stacks. The reality is the main thread often has a larger default stack, but both main and other threads are just threads, with their own stack limits set by the OS runtime defaults.
You know what has a smaller stack? Your dad.
2. Async stack usage 2-8 kilobytes. When I said async tasks have very small stack sizes, 2-8 kilobytes, I was referring to the user space task, coroutine, context, not the OS thread stack. Async tasks run inside the main thread, or whatever thread runs the event loop, so they share that thread's big stack.
They all share the same big stack.
Each async task only needs to store a small amount of coroutine state context, like saved registers, instruction pointer, local variables, which is much smaller than a full thread stack. So the 2-8 kilobytes figure is about the coroutine's memory overhead inside the main thread's large stack.
Oh, this is so stupid. I'm not even gonna point out which Chipbot's wrong anymore.
3. Threads can run async inside themselves. Correct. Each thread can run an event loop with async tasks, so if you have multiple threads, each running async tasks, the total concurrency is multiplicative, many threads each with their own stack. Each thread can run thousands of async tasks with a very low per task overhead. This is a common design. For example, in Rust Tokyo, Python's Asyncio with threads process pools, Node.js clusters.
Alright, here's my big whatever. Here's where I win. Improve that Chipbot sucks dick. Not that there's anything like, I don't know, it's just a saying. Nothing wrong with sucking dick. But I'm not gay, so whatever. Nothing against gay people. I mean, suck away. or don't. Do what you want. I don't care. So like, don't shove it down my throat, letting me know you suck dick. I don't want to know. Alright, so now let's chat about this.
Is concurrency as multiplicative with async? Great question. Let's clarify what concurrency as multiplicative means in this context and whether it applies to async. What does concurrency as multiplicative mean here? If you have n threads, and each thread runs m async tasks concurrently, then the total number of concurrent tasks is roughly nm. How does this work? Each thread is a separate OS scheduled unit with its own stack. Each async task inside a thread is a lightweight coroutine with very small memory overhead. So by combining multiple threads, each running many async tasks, how does this work?
Now chat about it's like, sure, if you use async with multiple threads, it is. Because it's fucking changing the context, because it knows what I'm going to ask. Because that's what chatbot does. It predicts the next thing you're going to say, or the next thing of the question you give it. So it's predicting what I'm going to ask, so now I'm going to change what I asked.
Is concurrency as multiplicative with async in relation to async running on a single main program that has no other threads running?
I had to get some water. And so what's this?
Is concurrency is multiplicative with async, in relation to async running on a single main program that has no other threads running? No. If your async code runs only on a single main thread with no other threads, then concurrency is not multiplicative, it's limited to that single thread's capacity.
Alright, so after this, I'm gonna tell Chip about this, whatever.
If async concurrency is not multiplicative, then it does not increase the amount of work a program can compute when compared to threading. Therefore, you're entirely wrong about async being close to or more performant, and totally lying because you knew it was not multiplicative to start with. Context does not matter. Threads are inherently multiplicative in relation to compute work being done.
Oh my god, Chip, I'd be so...
I see where you're coming from, and this is a crucial distinction to unpack carefully. Let's break it. 1. Concurrency parallelism. Concurrency means handling multiple tasks at overlapping times. Tasks can start, pause, and resume. Parallelism means doing multiple tasks literally at the same time. Requires multiple CPU cores or hardware threads. 2. Async concurrency on a single thread. Async lets you manage many tasks concurrently without blocking, but all tasks share the same CPU core. So at any instant, only one task is actually running. This improves throughput and responsiveness by avoiding idle waiting, for example, on I/O, but it does not increase raw CPU computation capacity. Why do you keep mentioning this? A legitimate program that uses lock-free threading does not incur the overhead. This improves throughput and responsiveness by avoiding idle waiting, for example, on I/O, but it does not increase raw CPU computation capacity. final take, I never intended to claim async magically beats threading for CPU work. If my earlier messages suggested that without nuance, that was misleading. Async and threading are tools with different strengths. Threads enable true parallel CPU work. Async shines in high concurrency I/O where parallelism isn't needed.
Oh my god, I'm done with JetBot. It's so frustratingly dumb. Everything is a misleading statement or a fucking lie.
Weak maps must be implemented using either hashed tables or other mechanisms that, on average, provide access times that are sublinear on the number of key value pairs in the collection. The data structure used in this specific cation is only intended to describe the required observable semantics of weak maps. It is not intended to be a viable implementation model. Note weak
Why can't this zoom out and save its position? It's so frustrating.
symbol in a manner
Well, now it saved it.
as if, in the absence of the weak map or weak set instance,
Alright, so this maps to memory, whatever.
accessible
Then does mem copy the data, image data, bytes per line times, blah blah blah. Why not cache this value?
per object symbol mapping of weak map or weak set instances to keys. Alternatively, each weak map or weak set instance may internally store its key and value data, but this approach requires coordination between the weak map or weak set implementation and the garbage collector. The following references describe mechanism that may be useful to implementations of weak map and weak set. Barry Hayes, 1997. Ephemerons, a new finalization mechanism. In proceedings of the 12th ASEAN SIGPLAN Conference on Object-Oriented Programming, Systems, Languages, and
I'll just leave it.
OOPSLA 97.
Because if it's like, if one of these takes a 32-bit value, the other one takes 64-bit,
176 100
I don't want to deal with like casting stuff.
://doi.acm.org
So this is a copy data to staging buffer memory.
3006
So staging buffer memory.
63733 Alexandra
No, that is a copy to where?
eliminating cycles in weak
Data to,
computer science JAX
huh?
number 21 pages 3481 3497
What?
8 http://www.jux.org/jux_14_21/eliminating cycles
Okay, no. So
map constructor. The weak
this is getting
percent weak map percent is the initial value of the weak map property of the global object. Create
this isn't mapping memory. This is getting an address
to be called as a function and will throw an except
to pass the memory to.
value in an
It's not mapping an address for use.
intent
It's providing an address that's mapped to pass data to.
to the weak map constructor to create and initialize the
Unless that's what it actually means.
necessary to support the weak map prototype.
And I don't know.
4 3 1 1 weak map.
Does map memory mean that you're mapping your memory, or you're receiving an address that's been mapped?
Let map be ordinary create from constructor new target percent weak map prototype percent weak map data set map to a new empty list. If iterable is either undefined or null, return map. Let adder be get map set. If is callable, adder is false. Throw a type error exception. Return. Add entries from iterable map iterable adder. Note if the parameter iterable is present, it is expected to be an object that implements an iterator method that returns an iterator object T that produces a
Message but does map memory mean you are having your memory mapped? Mean you are providing memory to be mapped?
ECMA International 2024 24 3 2 properties of the weak map construct
Does map memory mean you are providing memory to be mapped,
function prototype percent
or will be receiving memory that has been mapped for use?
1 weak map prototype. The initial value of weak map prototype is the weak map prototype object. This property has the attributes false, 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 4
This is a great question. This often trips people up when working with Vulkan.
Prototype object is %weak map.
And here it says what it actually means.
Percent
This function gives you access to a pointer to a region of device mapped to the region of device memory that you've already allocated.
structure. The initial value of weak map.
So to answer directly, you are not giving memory to the GPU.
3.
Instead you're saying, hey, let me see, map this block of memory I allocated earlier
Be the this value.
so I can write a read.
Internal slot. M if can be held weak.
But I didn't allocate memory.
False. Return false for each record. P of M. Do if P.
Did chatbot give me a bad code?
Set P. 2. Set P to empty. 3. Return true. Return false. 4. 3. 3.
Or is that what staging buffer memory is?
The following steps when called. Let M be the this value. Perform. Require internal slot. M if can be held weakly. Key is false. Return undefined.
This is so stupid.
P of M. Do if P. Key is true. Return P5. Return undefined. The value empty is
So this code is data.
but an entry has been deleted. Note, actual implementation.
The memory that
Data structures. ECMA int
I mapped for use.
24633 24 3 3 4 week map.
The 8 bytes
That perform
of the pointer.
called. Let M be the this value.
Those 8 bytes will be holding the entire frame buffer.
Weekly. Key is false. Return false for each record. P of M. Do if
Those 8 bytes have been mapped to hold the whole frame buffer.
return false. 4 3
I'm being sarcastic.
prototype set. Key value. This method performs the following steps when called. Let M be the this value. Perform. Require internal slot. M.
Because 8 bytes can't hold the whole frame buffer.
Throw a type error exception for each record. P of M. Do if P. Key is true. Then
What?
2
It says yes, you are understanding it
value.
almost exactly right.
M. 4
That pointer is a CPU visible mapping to a region of memory.
to string tag.
In this case, your staging buffer memory
T is the
that you requested via VKMap memory.
false.
Okay, so staging buffer memory is the allocated memory.
Weak map instances are ordinary objects that from the weak map prototype. Weak map instances also have internal slot. 4.4 weak set object.
Man, why is it not typing?
And or symbols. A distinct object or symbol may only occur once as an element of a weak set's collection. A weak set may be queried to see if it contains a specific value, but no mechanism is provided for enumerating the values it holds. In certain conditions, values which are not live are removed as weak set elements. As
Wait a second.
103. An implementation may impose an arbitrarily determined latency between the time a value contained in a weak set becomes inaccessible and the time when the value set. If this latency was observable to ECMA script program, it would be a source of indeterminate.
Where am I even allocating memory for this?
For that reason, an ECMA script implementation must not provide any means to determine if a weak
Right here?
a particular value that does not
VKMap memory.
present the observed
That's right here.
sets must be implemented using either hashed tables or other mechanisms that, on average, provide access times that are sublinear on the number of elements in the collection. The data structure used in this specification is only intended to describe the required observable semantics of weak sets. It is not intended to be a viable implementation model. Note see the note in 24.3. 634. ECMA International 2024. 244. 1. The weak set constructor. The weak set constructor is %weak set % is the initial value of the weak set property of the global object. Creates and initializes a new weak set when called as a constructor. Is not intended to be called as a function and will throw an exception when called in that.
This function never allocates memory with staging buffer memory.
Subclass constructors that intend to inherit the specified weak set behavior must include a supercall to the weak set constructor to create and initialize.
This is code that's not even being used.
Necessary to support the weak set prototype built-in methods. 4, 4, 1. 1 week set
It was being used at one point,
forms the
but it didn't work.
if new target is under
So it's not being used because it didn't work.
ordinary create from constructor new target percent week set prototype percent set to a new empty list. If iterable is either undefined or null, return set. Let either be get set
Does that mean chatbot give me code
is false. Throw it
that is using something that's not actually allocated,
iterable sync repeat t a b
which is annoying.
4 2 let next be iterate a step value iterate a record
Because chatbot's supposed to like take people's jobs because it's so smart,
adder set
but it can't write fucking code.
close iterator
And when I say write code, I mean real code,
property
not like add 2 plus 2.
constructor has
It can't write actual code.
prototype percent has the following properties 4 4 2 1 week set prototype. The initial value of week set prototype is the week set prototype object. This property has the attributes false 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 4 4 3 properties of the week set prototype object. The week set prototype object is percent week set prototype percent has an internal slot whose value is percent object prototype percent is an ordinary object does not have an internal slot. 4 4 3 1 week set prototype add value. This method performs the following steps when called. Let s be the this value perform require internal slot S ECMA International 2024 630
I'm asking chatbot, where's the memory allocated for that
is
in this code it gave me?
type error exception. For each element of S, do if E is not empty and same value, E value is true, then I return S append value to S. Return S 4 4 3 2 week set prototype constructor. The initial
It says actual memory allocation is missing. Thank you, chatbot.
4 3 3 week set prototype delete value. This method performs the following steps when called. Let S be the this value perform require internal slot S if can be held weakly value is false return false. For each
Oh my god, what is this?
if E is not empty and same value, E value is true.
Oh my god.
With an element whose value is
A whole other thing I gotta look into? Are you kidding me?
4 4 3
It says you have to define find memory type.
that performs the following steps when called. Let S be the this value perform require internal slot S if can be held weakly value is false return false. For each element of S, do if
That doesn't even show up at all.
E
Unless it's like a chatbot made function.
return false. 4 4 3 5 week set prototype add at to string tag. The initial value of the add at to string tag property is the string value week set. This property has the attributes false false.
Oh my god, this is so annoying.
Properties of weak set instances. Weak set instances are ordinary objects that inherit properties from the weak set prototype.
Damn it.
You have internal slot. The value empty
I gotta like think I figured out.
that an entry has been
It's not just simple copy paste. It's tied to like everything else, I think.
the entry from internal data structure.
Man, this freaking sucks.
ECMA
Chatbot? This piece of crap.
25 structured data. 5.1 array buffer objects 25 1 1 notation th e descriptions below in this section 25.4 and 29 use the read modify write modification function internal data structure. A read modify write modification function is a mathematical function that is notationally represented as an abstract closure that takes two lists of byte values as arguments and returns a list of byte values. These abstract closures satisfy all of the following properties. They perform all their algorithm steps atomically. Their individual algorithm steps are not observable. 5 1 2 fixed length and resizable array buffer objects. A fixed length array buffer is an array buffer whose byte length cannot change after creation. A resizable array buffer is an array buffer whose byte length may change after creation via calls to array. Buffer prototype resize. New length. The kind of array buffer object that is created depends on the arguments passed to array buffer. Length. Options. 5, 1, 3 abstract operations for array buffer objects. 5, 1, 3, 1 allocate array buffer. Constructor. Byte length. Max byte length. The abstract operation allocate array buffer takes arguments constructor, a constructor, and byte length, a non-negative integer, and optional argument max byte length, a non-negative integer or empty, and returns either a normal completion containing an array buffer or a throw completion. It is used to create an array buffer. It performs the following steps when called. Let slots be. If max byte length is present and max byte length is not empty, let allocating resizable buffer be true. Otherwise, let allocating resizable buffer be false. If allocating resizable buffer is true, then if byte length, max byte length, throw a range error exception, be append to slots. Let obj be ordinary create from constructor, constructor, percent array buffer prototype percent, slots let block be create byte data block, byte length, set obj to block, set obj to byte length. If allocating resizable buffer is true, then, if it is not possible to create a data block consisting of max byte length bytes, throw a range error exception. Note to aid verifying that a read modify write modification functions algorithm steps constitute a pure mathematical function. The following editorial conventions are recommended. They do not access directly or transitively via invoke abstract operations and abstract closures any language or specification values except their parameters and captured values. They do not return completion records. ECMA International 2024 637. B note, resizable array buffers are designed to be implementable within place growth. Implementations may throw if, for example, virtual memory cannot be reserved up front. C set obj to max byte length. Return obj 5, 1, 3, to array buffer byte length. Array buffer, order. The abstract operation array buffer byte length takes arguments array buffer, an array buffer or shared array buffer, and order, sexcst or unordered, and returns a non-negative integer. It performs the following steps when called. If a shared array buffer is true and array buffer has an internal slot, then a let buffer byte length block be array buffer, be let raw length be get raw bytes from shared block. Buffer byte length block 0 begin 64. True, order. C let is little endian be the value of the field of the surrounding agent's agent record. D return R raw bytes to numeric begin 64. Raw length is little endian. Assert is detached buffer. Array buffer is false. Return array buffer 5, 1, 3, 3 array buffer copy and detach. Array buffer new length. Preserve resizability. The abstract operation array buffer copy and detach takes arguments array buffer, an ECMA script language value, new length, an ECMA script language value, and preserve resizability or fixed length, and returns either a normal completion containing an array buffer or a throw completion. It performs the following steps when called. Perform. Require internal slot. Array buffer. If a shared array buffer is true, throw a type error exception. If new length is undefined, then a let new byte length be array buffer 4. Else a let new byte length be to int x new length. If is detached buffer array buffer is true, throw a type error exception. If preserve resizability is preserve resizability and is fixed length array buffer is false, then a let new max byte length be array buffer. Else a let new max byte length be empty. If array buffer is not undefined, throw a type error exception. Let new buffer be allocate array buffer percent new byte length new max byte length 0. Let copy length be min new byte length array buffer 1. Let from block be array buffer 2. Let to block be new buffer 3. Perform copy data block bytes to block 0 from block 0 copy length 4. Note, neither creation of the new data block nor copying from the old data block are observable. Implementations may implement this method as a zero copy move or a realloc. 5. Perform. Detach array buffer 6. Return new buffer 5, 1, 3, 4 is detached buffer, array buffer. The abstract operation is detached buffer takes argument array buffer, an array buffer or a shared array buffer, and returns a boolean. It performs the following steps when called. 2. If array buffer is null, return true. Return false. 38. ECMA International 2024. 25. 1, 3, 5 detach array buffer, key. The abstract operation detach array buffer takes argument array buffer, an array buffer, and optional argument key anything and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert is shared array buffer is false. If key is not present, set key to undefined. If array buffer is not key, throw a type error exception. Set array buffer to null. Set array buffer to 0. Return unused. 5, 1, 3, 6 clone array buffer, src byte offset, src length. The abstract operation clone array buffer takes arguments src buffer, an array buffer or a shared array buffer, src byte offset, a non-negative integer, and src length, a non-negative integer, and returns either a normal completion containing an array buffer or a throw completion. It creates a new array buffer whose data is a copy of src buffer's data over the range starting at src byte offset and continuing for src length bytes. It performs the following steps when called. Assert is detached buffer, src buffer is false. Let target buffer be. Allocate array buffer, array buffer src length. Let src block be src buffer. Let target block be target buffer. Perform copy data block bytes. Target block 0, src block, src byte offset, src length. Return target buffer 5, 1, 3, 7, capital G, E, T, capital A, R, A, Y, capital B, U, F, E, R, capital M, A, X, capital B, Y, T, E, capital L, E, N, G, T, H, capital O, P, T. Options. The abstract operation, capital G, E, T, capital A, R, A, Y, capital B, U, F, E, R, capital M, A, X, capital B, Y, T, E, capital L, E, N, G, T, H, capital O, P, T, takes argument options, any CMA script language value, and returns either a normal completion containing either a non-negative integer or empty, or a throw completion. It performs the following steps when called. If options is not an object, return empty. Let max byte length be. Get options max byte length. If max byte length is undefined, return empty. Return to int x max byte length 5, 1, 3, 8 host resize array buffer new byte length. The host defined abstract operation host resize array buffer takes arguments buffer, an array buffer, a new byte length, a non-negative integer, and returns either a normal completion containing either handled or unhandled, or a throw completion. It gives the host an opportunity to perform implementation-defined resizing of buffer. If the host chooses not to handle resizing of buffer, it may return unhandled for the default behavior. The implementation of host resize array buffer must conform to the following requirements. The abstract operation does not detach buffer. If the abstract operation completes normally with handled buffer is new byte length. The default implementation of host resize array buffer is to return normal completion, unhandled. Note: detaching an array buffer instance disassociates the data block used as its backing store from the instance and sets the byte length of the buffer to 0. ECMA International 2024 639 25 1 3 9 is fixed length array buffer. The abstract operation is fixed length array buff. R takes argument array buffer, an array buffer or a shared array buffer, and returns a boolean. It performs the following steps when called. If array buffer has an internal slot, return false, return true. 5, 1, 3, 1, 0 is unsigned element type. Type. The abstract operation is unsigned element type takes argument type, a typed array element type, and returns a boolean. It verifies if the argument type is an unsigned typed array element type. It performs the following steps when called. If type is one of uint8, uint8 clamped, uint16, uint32, or begin64, return true, return false. 5, 1, 3, 1, 1 is unclamped integer element type. Type. The abstract operation is unclamped integer element type takes argument type, a typed array element type, and returns a boolean. It verifies if the argument type is an integer typed array element type not including uint8 clamped. It performs the following steps when called. If type is one of int8, uint8, int16, uint16, int32, or uint32, return true, return false. 5, 1, 3, 1, 2 is begin element type. Type. The abstract operation is begin element type takes argument type, a typed array element type, and returns a boolean. It verifies if the argument type is a begin typed array element type. It performs the following steps when called. If type is either begin64 or begin64, return true, return false. 5, 1, 3, 1, 3 is notaire configuration. Type. Order. The abstract operation is notaire configuration takes arguments type, a typed array element type, and order, sexyst, unordered, or init, and returns a boolean. It performs the following steps when called. If is unclamped integer element type, type, is true, return true. If is begin element type, type, is true and order is neither init nor unordered, return true, return false. 5, 1, 3, 1, 4 raw bytes to numeric. Type. Raw bytes is little endian. The abstract operation raw bytes to numeric takes arguments type, a typed array element type, raw bytes, a list of byte values, and is little endian, a boolean, and returns a number or a big int. It performs the following steps when called. Let element size be the element size value specified in table 71 for element type. Type. If is little endian is false, reverse the order of the elements of raw bytes. If type is float 32, then a let value be the byte elements of raw bytes concatenated and interpreted as a little endian bit string encoding of an IEEE 754-2019 binary 32 value. B if value is an IEEE 754-2019 binary 32 NaN value. Return the NaN number value. C return the number value that corresponds to value. If type is float 64, then 40. ECMA International 2024. A let value be the byte elements of raw bytes concatenated and interpreted as a little endian bit string encoding of an IEEE 754-2019 binary 64 value. B if value is an IEEE 754-2019 binary 64 NaN value. Return the NaN number value. C return the number value that corresponds to value. If is unsigned element type, type is true, then a let int value be the byte elements of raw bytes concatenated and interpreted as a bit string encoding of an unsigned little endian binary number. Else, a let int value be the byte elements of raw bytes concatenated and interpreted as a bit string encoding of a binary little endian 2's complement number of bit length element size 8. If is big int element type, type is true, return the big int value that corresponds to int value. Otherwise, return the number value that corresponds to int value. 5, 1, 3, 1, 5 get raw bytes from shared block. Block. Byte int x. Type is typed array. Order. The abstract operation get raw bytes from shared block takes arguments block. A shared data block. Byte int x. A non-negative integer. Type. A typed array element type is typed array, a boolean, and order, sexyst or unordered, and returns a list of byte values. It performs the following steps when called. Let element size be the element size value specified in table 71 for element type. Type. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. If its typed array is true and is notaire configuration, type, order, is true. Let notaire be true. Otherwise let notaire be false. Let raw value be a list of length element size whose elements are non-deterministically chosen byte values. Note: in implementations, raw value is the result of a non-atomic or atomic read instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let read event be read shared memory. Order: notaire, block, byte int x, element size. Append read event to events record. Append chosen value record. Read event, raw value. 2. Execution 0. Return raw value. 5, 1, 3, 1, 6. Get value from buffer, array buffer, byte int x, type, is typed array, order, is little endian. The abstract operation get value from buffer takes arguments array buffer, an array buffer or shared array buffer, byte int x, a non-negative integer, type, a typed array element type, is typed array, a boolean, and order, sexcst or unordered. And optional argument is little endian, a boolean, and returns a number or big int. It performs the following steps when called. Assert, is detached buffer, array buffer, is false. Assert, there are sufficient bytes in array buffer starting at byte index to represent a value of type. Let block be array buffer. Let element size be the element size value specified in table 71 for element type. If is shared array buffer is true, then assert, block is a shared data block. B let raw value be get raw bytes from shared block. Block, byte int x, type, is typed I. Order else, a let raw value be a list whose elements are bytes from block at indices in the interval from byte int x, inclusive, to byte index plus element size. Exclusive. Assert, the number of elements in raw value is element size. If is little endian is not present, set is little endian to the value of the field of the surrounding agent's agent record. Return raw bytes to numeric, type, raw value, is little endian. ECMA International 2024 641 25 1 3 17 numeric to raw bytes, type, value, is little endian. The abstract operation numeric to raw bytes takes arguments type, a typed array element type, value, a number or big int, and is little endian, a boolean, and returns a list of byte values. It performs the following steps when called. If type is float 32, then a let raw bytes be a list whose elements are the 4 bytes that are the result of converting value to IEE 54 2019 binary 32 format using round ties to even mode. The bytes are arranged in little endian order. If value is nan, raw bytes may be set to any implementation chosen, IEE 754 2019 binary 32 format, not a number encoding. An implementation must always choose the same encoding for each implementation distinguishable NaN value. Else if type is float 64, then a let raw bytes be a list whose elements are the 8 bytes that are the IEE 754 2019 binary 64 format encoding of value. The bytes are arranged in little endian order. If value is NaN, raw bytes may be set to any implementation chosen, IEE 754 2019 binary 64 format, not a number encoding. An implementation must always choose the same encoding for each implementation distinguishable NaN value. Else, a let n be the element size value specified in table 71 for element type. B let convop be the abstract operation named in the conversion operation column in table 71 for element type. C let int value be r. Convop value. D if int value 0, then I let raw bytes be a list whose elements are the n byte binary encoding of int value. The bytes are ordered in little endian order. Else, I let raw bytes be a list whose elements are the n byte binary 2's complement encoding of int value. The bytes are ordered in little endian order. If is little endian is false, reverse the order of the elements of raw bytes. Return raw bytes. 5, 1, 3, 1, 8. Set value in buffer, array buffer, byte int x, type, value, is typed array, order, is little endian. The abstract operation set value in buffer takes arguments array buffer, an array buffer or shared array buffer, byte int x, a non-negative integer, type, A typed array element type, value, a number or big int, is typed array, a boolean, and order, sec. CST, unordered, or init, and optional argument is little endian, a boolean, and returns unused. It performs the following steps when called. Assert is detached buffer, array buffer, is false. Assert. There are sufficient bytes in array buffer starting at byte index to represent a value of type. Assert. Value E is a big int if is big int element type. Type is true. Otherwise, value is a number. Let block be array buffer. Let element size be the element size value specified in table 71 for element type. Type if is little endian is not present. Set is little endian to the value of the field of the surrounding agent's agent record. Let raw bytes be numeric to raw bytes. Type value is little endian if is shared array buffer is true. Then, let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. See if is typed array is true and is notaire configuration. Type order is true. Let notaire be true. Otherwise let notaire be false. Deappend write shared memory. Order notaire block byte int x element size raw bytes to events record. Else, store the individual bytes of raw bytes into block. Starting at block. Byte index 10. Return unused. 42. ECMA International 2024. 251319 Get modify set value in buffer. Array buffer. Byte int x. Type. Value. Op. The abstract operation get modify set value in buffer takes arguments array buffer, an array buffer or a shared array buffer. Byte int x, a non-negative integer, type, a typed array element type, value, a number or big int, and op, a read modify. Write modification function, and returns a number or big int. It performs the following steps when called. Assert is detached buffer, array buffer, is false. Assert. There are sufficient bytes in array buffer starting at byte index to represent a value of type. Assert. Value is a big int if is big int element type. Type is true. Otherwise, value is a number. Let block be array buffer. Let element size be the element size value specified in table 71 for element type. Type. Let is little endian be the value of the field of the surrounding agent's agent record. Let raw bytes be numeric to raw bytes. Type. Value is little endian if is shared array buffer is true. Then, let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. See let raw bytes read be a list of length element size whose elements are non-deterministically chosen byte values. Denote. In implementations, raw bytes read is the result of a load link, of a load exclusive, or of an operand of a read modify write instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let RMW event be read modify write shared memory. Sec CST, true, block, and x, byte int x, element size, raw bytes, op, f append RMW event to events record, g append chosen value record, RMW event, raw bytes read. 2. Execution. Else, let raw bytes read be a list of length element size whose elements are the sequence of element size bytes starting with block. Byte index. Let raw bytes modified be op. Raw bytes read. Raw bytes. C store the individual bytes of raw bytes modified into block. Starting at block. Byte index 0. Return raw bytes to numeric. Type. Raw bytes read. Is little endian. 5. 1. For the array buffer constructor, the array buffer constructor is %array buffer % is the initial value of the array buffer property of the global object, creates and initializes a new array buffer when called as a constructor, is not intended to be called as a function and will throw an exception when called in that manner, may be used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified array buffer behavior must include a supercall to the array buffer constructor to create and initialize subclass instances with the internal state necessary to support the array buffer prototype built-in methods. 5. 1. 4. 1 array buffer. Length. Options. This function performs the following steps when called. If new target is undefined, throw a type error exception. Let byte length be to int x length. Let requested max byte length be capital G E T capital A R R A Y capital B U F F E R capital M A X capital B Y T E capital L E N G T H capital O P T. Options. Return. Allocate array buffer. New target. Byte length. Requested max byte length. ECMA International 2024 643 25 1. 5 properties of the array buffer constructor. The array buffer constructor has an internal slot whose value is %function prototype %. Has the following properties. 5 1 5 1 array buffer as view. Arg. This function performs the following steps when called. If arg is not an object, return false. If arg has an internal slot, return true. Return false. 5 1 5 to array buffer prototype. The initial value of array buffer prototype is the array buffer prototype object. This property has the attributes false, false, false. 5 1 5 3 get array buffer at species. Array buffer at species is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. 1. Return to this value. The value of the name property of this function is get. Symbol species. 5 1 6 properties of the array buffer prototype object. The array buffer prototype object is %array buffer prototype has an internal slot whose value is %object prototype is an ordinary object. Does not have a nor internal slot. 5 1 6 1 get array buffer prototype byte length. Array boo for prototype byte length is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If is shared array buffer. O is true. Throw a type error exception. If is detached buffer. O is true. Return +0. Let length be O. Return length. Note array buffer prototype slice, start, end, normally uses its this values constructor to create a derived object. However, a subclass constructor may override the default behavior for the array buffer prototype slice, start, end method by redefining its at species property. 44. ECMA International 2024 25 1 6 to array buffer prototype constructor. The initial value of array buffer prototype constructor is %array buffer %5 1 6 3 get array
Why is this external?
buffer prototype detached is an accessor property. Accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value.
Chatbot.
Array buffer O is true. Throw a type error exception. Return is
I did check documentation.
5 1 6 4 get array buffer prototype max byte length. Array buffer prototype max byte length is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If is shared array buffer. O is true. Throw a type error exception. If is detached buffer. O is true. Return +0. If is fixed length array buffer. O is true. Then a let length be 06. Else a let length be 07. Return length 5 1 6 5 get array buffer prototype resizable. Array buffer prototype resizable is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If is shared array buffer. O is true. Throw a type error exception. If is fixed length array buffer. O is false. Return true. Otherwise return false. 5 1 6 6 array buffer prototype resize. new length. This method performs the following steps when called. Let O be the this value. Perform. Require internal slot. O. If is shared array buffer. O is true. Throw a type error exception. Let new byte length be. To int x. New length.
It says map memory. Can't return null.
Throw type
I mean failure.
if new byte length. O. Throw a range error exception. Let host handled be. Host resize array buffer.
It will fail if the implementation is unable to allocate approximately sized contiguous bristle header space.
Block B. Create byte data block. New byte length 1. Let copy length be min. New byte length. O. 2.
Let's return to failure.
Copy data block bytes. New block 0. Old block.
The application can improve likelihood of success by reducing the size of the mapped range.
Block nor copying from the old data block are observable. Implementations may implement this method as in place.
And removing unneeded mappings using unmap memory.
24,645. 15. Set out a new byte length. 6. Return undefined.
Do I need to unmap the memory
6. 7 array buffer.
every single fucking time?
Start. End. This method performs the following steps when called. Let O be the this value. Perform. Require internal slot. O. If is shared array buffer. O is true. Throw a type error
Can I just leave it mapped the whole time?
true. Throw a type error exception. Let len be O. Let relative start be. To integer or infinity. Start. If relative start equals. Let first be 0. Else if relative start 0. Let first be max. Then plus relative start 0. Else. Let first be min. Relative start. Len 0. If end is undefined. Let relative end be
Here's the first time to turn off the new stuff.
infinity. End 1. If relative end equals. Let final be 0. 2. Else if relative end 0. Let final be max. Len plus relative end 0. 3. Else. Let final be min. Relative end. Len 4. Let new len be max. Final. First. 0. 5. Let tool be. Species constructor. O. Percent array buffer percent. 6. Let new be. Construct. Tour. New len. 7. Perform. Require internal slot. New. 8. If is shared array buffer. New. Is true. Throw a type error exception. 9. If is detached buffer. New. Is true. Throw a type error exception. 0. If same value. New. O. Is true. Throw a type error exception. 1. If new. New len. Throw a type error exception. 2. Note. Side effects of the above steps may have detached or resized O. 3. If is detached buffer. O. Is true.
Make a global called mapped image buffs.
5. Let to buff be new. 6.
Or define whatever.
NBO 7. If first.
I need Claritin. The allergies are killing me.
Current len. First. B perform copy data block bytes. To buff. 0. From buff. First. Count 8. Return new. 5. 1. 6. 8 array buffer prototype transfer. New length. This method performs the following steps when this value. Return. Array buffer copy and detach. O. New length. Preserve
Alright, so we need these.
6.
And then
Prototype transfer to fixed length. New length. This method performs the following steps when called. Let O be the this value. Return.
this will allocate the buffer.
O. New length. Fixed length. 5. 1. 6. 1 0 array buffer prototype. Add at to string tag. The initial value of the add at to string tag property is the string value array buffer. This property has the attributes false, false, true, 46. Copyright sign, ECMA International 2024, 25. 1. 7 properties of array buffer instances. Array buffer instances inherit properties from the array buffer prototype object. Array buffer instances each have an internal slot.
We need to pass in is a logical device,
Which are resizable, each have an internal
then the physical device.
instances whose is null are considered. operators to access or modify data contained in the array buffer instance will fail. Array buffer instances whose is set to a value other than undefined need to have all detach array buffer calls passing that same detach key as an argument. Otherwise, a type error will result. This internal slot is only ever set by certain embedding environments, not by algorithms in this specification. 5.1.8 Resizable Array Buffer Guidelines. Note 1. The
And I have globals for those.
program is working with resizable array
And they are
and that programs are possible. The amount of available physical memory differs greatly.
I thought I copied them.
Similarly, virtual memory subsystems also differ greatly between hardware devices as well as operating systems.
I didn't paste it.
Runs without out-of-memory errors on a 64-bit desktop web browser could run out of memory on a 32-bit mobile web browser. When choosing a value for the max byte length option for resizable array buffer, we recommend that the smallest the application be chosen. We recommend that max byte length does not exceed 1,073,741,824, 230 bytes or 1 gigabytes. Please note that successfully constructing a resizable array buffer for a particular maximum size does not guarantee that future sizes will succeed. Note 2. The following are guidelines for ECMA script implementers implementing resizable array buffer. Resizable array buffer can be implemented as copying upon resize, as in place growth via reserving virtual memory up front, or as a combination of both for different values of the constructor's max byte length option. If a host is multi-tenanted, that is, it runs many ECMA script applications simultaneously, such as a web browser, and its implementation.
Good job, I gave me this code last time too. It doesn't work.
Recommend that both 30
The only code that works was from the tutorial website.
length 1 gigabytes to 1.5 gigabytes.
Chatbot can't make code.
Code a single application.
It can, but in context, it doesn't work. So it does make code. It makes code. That doesn't work.
Without an MMU, or if a host
Within more context, or more context based on what I said,
length option. How
it does work when you tell Chatbot it's wrong and you apply changes, then it does work. But the code it supplies the first time does not work.
memory on the device. 5.2.5.2.1 Shared array buffer objects. Fixed length and growable shared array buffer objects. A fixed length shared array buffer is a shared array buffer whose byte length cannot change after creation. A growable shared array buffer is a shared array buffer whose byte length may increase after creation via calls to shared array buffer prototype grow. New length. ECMA International 2024-647. The kind of shared array buffer object that is created depends on the arguments passed to shared array buffer. Length. Options. 5.
You're there.
2 abstract operations for shared array buffer objects. 5.2.2.1 Allocate shared array buffer. Constructor. Byte length. Max byte length. The abstract operation allocate shared array buffer takes arguments constructor, a constructor, and byte length, a non-negative integer, and optional argument max byte length, a non-negative integer or empty, and returns either a normal completion containing a shared array buffer or a throw completion. It is used to create a shared array buffer. It performs the following steps when called. Let slots be. If max byte length is present and max byte length is not empty, let allocating growable buffer be true. Otherwise, let allocating growable buffer be false. If allocating growable buffer is true, then if byte length, max byte length, throw a range error exception, be appended to slots, else a append to slots, let obj be. Ordinary create from constructor, constructor, percent shared array buffer prototype percent, slots. If allocating growable buffer is true, let alloc length be max byte length. Otherwise, let alloc length be byte length, let block be. Create shared byte data block. Alloc length, set obj to block. If allocating growable buffer is true, then assert byte length max byte length be let byte length block be. Create shared byte data block. 8. C perform set value in buffer. Byte length block. 0. Begin 64. Z. Byte length. True. Sexy st, d set obj to byte length block, e set obj to max byte length 0, else a set obj to byte length 1. Return obj 5, 2, 2, 2 is shared array buffer, obj
This sucks.
is shared
This is so boring.
argument
Holy crap.
array buffer
I'm so bored.
and returns a boolean. It
I just don't care about any of this. I just want to like get the memory, allocate it, and get it running.
steps when called
This is wasting time to do all this fucking shit.
return false.
It's ridiculous.
Data block. Return false. Assert. Buffer data is a shared data block. Return true. 5, 2, 2, 3 host gross
So, create staging buffer.
length. The
I need to pass in
operation host
the device, the logical device, and the physical device,
anon. Negative integer.
which are the same fucking device.
Either handled or unhandled. Or a throw completion. It gives the host an opportunity to perform
I should tie them together as a single struct,
growing of buffer
but that doesn't really work
behavior. The implementation
because you can apply the same logical device, I think, to different physical devices.
does not complete normally with unhandled.
This is just ridiculous.
48. Copyright sign. ECMA International 2024. Byte length of the buffer or new
So I'm gonna add a parameter here.
throw a range error. Exception. Let his little endian be the value of the field of the surrounding agent's agent record. If the abstract operation completes normally,
I'm actually gonna make this a
read modify write shared
big ass macro
CST
because I hate function calls.
against 64
I hate when things are decayed to fucking pointer.
is 0. And as 8 is added to the surrounding agent's
This way I don't have to decay anything to a pointer.
prototype grow and
This just be a straight up argument to macro. Argument to a macro.
optionally vague about how or when the current byte length of buffer is read. Because the byte length must be updated via an atomic read modify write operation on the underlying hardware, architectures that use load link, store conditional, or load exclusive
One big ass macro.
instruction pairs may wish to keep the paired instructions close in the instruction stream. As such,
Need a block though.
grow itself does not perform bounds checking on new byte length before calling host
To make sure that locals, well there are no locals, it's all freaking globals. No, there's a couple locals. A couple local variables.
the value of
Man, drink water. It's not making a difference.
of host grow shared array buffer is to return
My throat is dry as hell.
5, 2, 3 the shared array buffer constructor is percent
And now, this is a macro.
value of the shared array buffer property of the global object. If that property is present, see below, creates and initializes a new shared array buffer when called as a constructor, is not intended to be called as a function and will throw an exception when called and used as the value of an extends clause of a class definition. Subclass constructors that intend to inherit the specified shared array buffer behavior must include
Specify like
array buffer constructor to create and initialize subclass instances with the internal state necessary to support the shared array buffer prototype built. In methods, whenever a host does not provide concurrent access to shared array buffers, it may omit the shared array buffer property of the global object. 5, 2, 3, 1 shared array buffer. Length. Options. This function performs the following steps when called. If new target is undefined, throw a type error exception. Let byte length be to int x length. Let requested max byte length be capital G E T capital A R R A Y capital B U F F E R capital M A X capital B Y T E capital L E N G T H capital O P T. Options. Return. Allocate shared array buffer. New target. Byte length. Requested max byte length. 5, 2. 4 properties of the shared array buffer constructor. The shared array buffer constructor has an internal slot whose value is %function prototype %. Unlike an array buffer, a shared array buffer cannot become detached. and its internal. Note, array buffer data slot is never null. ECMA International 2024 649, has the following properties. 5, 2, 4, 1 shared array buffer prototype. The initial value of shared array buffer prototype is the shared array buffer prototype object. This property has the attributes false, false, false. 5, 2, 4. To get shared array buffer at speed.
And then now, presto.
Species is an accessor property.
Is that a slash?
Is
You know, it's magically a macro.
following steps when called.
This is like so boring.
Function is get symbol species.
I want to be done.
5.
I can't take how boring this is.
Shared array buffer prototype object is %shared array buffer prototype %. Has an internal slot whose value is %object prototype % is an ordinary object. Does not have a nor.
This GPU code is filled with global variables.
Shared array buffer prototype
So making giant macros, it only fits the case.
set accessor.
Why not?
Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If a shared array buffer O is false, throw a type error exception.
So I'm gonna pass this in.
Length O. Sexiest.
Find where device is used.
5, 2, 5. 2 shared array buffer prototype constructor. The initial value.
And replace it to use the macro they have.
Shared array buffer %. 5, 2, 5. 3 shared array buffer prototype grow. New length. This method performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If a shared array buffer O is false, throw a type error exception. Let new byte length be twinned x. New length. Let host handled be host grow shared array buffer O. New byte length. If host handled is handled, return undefined. Let his little endian be the value of the field of the surrounding agent's agent record. Let byte length block be O. Let current byte length raw bytes be get raw bytes from shared block. Byte length block 0 begin 64. True sexy 0. Let new byte length raw bytes be numeric tool or bytes begin 64. Z new byte length is little endian 1. Repeat 50. ECMA International 2024 25 2 5 4. Get shared array buffer prototype growable. A note. This is a compare and exchange loop to ensure that parallel racing grow.
Oh, it says failed to make logical device.
Lost.
Because the logical device is applied
Exits if it
to the physical device.
let current
I don't know, it's like, oh shit, is that an error? No, it's fine.
begin 64. Current byte length raw bytes is little endian. See if new byte length equals current byte length. Return undefined. D if new byte length. Current byte length or new byte length. O. Throw a range error exception. E let byte length delta be new byte length. Current byte length. F if it is impossible to create a new shared data block value consisting of byte length delta bytes. Throw a range error exception. G note. No new shared data.
Alright, so this gets the physical device.
Growable shared array buffers is specified by allocating a max-sized shared data block at construction time.
Just put at the top.
The requirement that
It's a logical device.
memory must throw a range error. H let read byte length raw bytes be capital A T O M I C capital C O M P A R E capital E X C H A N G E capital I N capital S H A R E D capital B byte length block 0 8 current byte length raw bytes new byte length raw bytes I byte list equal read byte length raw bytes current byte length raw bytes is true. Return undefined.
There's everything with device.
Length raw byte.
Needs to be hological, not the physical.
The compare exchange to update the length are prohibited. If the bounds checking for the
I'll get the physical to first. Tell whatever.
a read modify write shared memory event that
So this needs to be used for the the physical device.
is added into the candidate execution.
Pass in whatever.
Buffer prototype grower totally ordered. For example, consider two racing calls, subgrow 10 and sab.
Just right here.
One of the two calls is guaranteed to win the race. The call to subgrow 10 will never shrink sab even if subgrow
Just move this down there. Sign one place.
will instead throw a range error. Shared array buffer prototype growable is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. If a shared array buffer
So that's it.
is false, throw a type error exception. If a fixed length array buffer O
I think there's a loop that's kind of like this one. But I'll just have duplicate. I don't care.
5
I just want to get this shit running.
type max byte length.
And this is only called once on startup, so it's not going to affect the actual
Accessor
runtime, whatever.
its get accessor function perform.
Navigate the logical device.
Be this value. Perform.
It's just this.
Slot O. If a shared array buffer O is false, throw a type error exception. If a fixed length array buffer O,
It's used 3-4 times.
let length be O GTH5. Else a let length be O6. Return length ECMA International 251 25 2 5 6 shared array buffer prototype slice start end. This method performs the following steps when called. Let O be this value. Perform. Require internal slot O. If a shared array buffer O is false, throw a type error exception.
Since a value is passed in,
O. Sexy ST. Let relative start be to an integer or infinity. Start.
I don't think, well, it's not possible
Sif relative
for it to change what it holds.
max. Len plus relative start. 0 else. Let first be min. Relative start. Len if end is undefined. Let relative end be let
So I won't duplicate this.
to an
It's not like it's threaded. It's not going to change.
if relative end equals let
If it was, it probably wouldn't survive anyways.
relative end 0.
So I'm going to leave it like this, just one var.
Len plus relative end 0 2.
Axis or whatever to get it.
Relative end len 3. Let new len be max. Final first
Here's when I paste this when I get it to where each place that needs logical device.
cent 5
Which is here,
b. Construct
and then here,
len 6. Perform. Require internal
and here and here.
7. If a shared array buffer new is false, throw a type error exception. 8. If new is O, throw a type error exception. 9. If array buffer byte length new sexy ST new len, throw a type error exception. 0. Let from buff BO 1. Let
That's that.
2. Perform copy
These are the only globals used. Is device and physical device. And I just like replace them to use the actual globals I'm using.
2. 5.
My throat. Holy crap.
Type add at to string value of the add at to string tag property.
I probably have a dick in my throat.
This property has the attributes
It has what's going on.
true,
I'm not even gay. I have a dick in my throat.
shared array
Or it's a frog. Who knows? I need some. I'm drinking water. What the hell?
object, shared array
I guess I'm just losing my voice.
slot,
Which I don't care. I don't need to talk anyways.
internal slot, shared array buffer instances which are growable.
I should probably stop talking.
Button and internal
I'm not going to.
shared array buffer instances, unlike array buffer instances, are never detached.
So I think that's that.
ECMA International 2024 252 7 Growable Shared Array Buffer Guidelines. Note 1. The following are guidelines for ECMA script programmers working with Growable Shared Array Buffer. We recommend that programs be tested in their deployment environments where possible. The amount of available physical
Except.
between hardware devices. Similarly, virtual memory subsystems also differ greatly between hardware devices as well as operating systems. An application that runs without out-of-memory errors on a 64-bit desktop web browser could run out of memory on a 32-bit mobile web browser. When choosing a var, look for the max byte length option for growable shared array buffer. We recommend that the small...
I should probably make these local values
We recommend that max
so I can assign them.
1,070,000
Then I won't have to worry about passing in a macro. A literal, like a define or whatever.
shared array buffer for a
That way I can pass in a define or a variable and assign it to a variable,
length the synchronize
and then use a variable inside of this block
loads of the length
to treat it kind of like a function, even though it's not.
access. For example, you are
Because if the window size changes, then
in general,
I can't use literal defines.
one property access being
So I should probably try to account for that right now.
the access in the
This is something like what I gotta update to like not use defines now. But this is like a fixed size window. I'm just trying to get done. So it doesn't matter right now, totally.
Dart prototype
But later on, when the window size does change, it'll be a problem, whatever.
formed by built-in methods to check if it
So I'd have to go through and update it to support a variable for the window size, not just an immediate literal value.
growable shared array buffer.
I'll do that later though, because that doesn't matter right now.
Both by reserving
It's a fixed size window, so it works.
grow operations can happen in parallel with memory accesses on a growable shared array buffer. The constraints of the memory model require that even unordered accesses do not tear, bits of their values will not be mixed. In practice, this means the underlying data block of a growable shared array buffer cannot be grown by being copied without stopping the world. We do not recommend stopping the world as an implementation
Let's change this to arg.
as a serialization point and is
Then I'll have to rename the variables inside the macro, whatever.
including to any racy accesses in parallel. This can be accomplished via zero-filled on-demand virtual memory pages, or careful
And this should work.
really zero
Please, please just work.
access on
I swear, I just need, just for once, let something work right off the bat.
of non-growth
Just pretty please.
as integer,
Please just work.
synchronizing on the underlying buffer's length. See programmer guidelines above. For example, bounds checks for property accesses may still be hoisted out of loops. In practice,
Let's comment this out.
and growable shared array buffer by copying on hosts that do not have virtual memory, such as those running on embedded devices without an MMU. Memory usage behavior of growable
You can never have too many nodes
significantly differ from that of hosts with
until the file becomes too large. But that's not really ever gonna happen,
versions to
especially on 64-bit.
2024 653 25.3 data view objects 5 3 1 abstract operations for data view objects 5 3 1 1 data view with buffer witness records a data
So I think that's it.
record D is a record value used to encapsulate a data view along with a cached byte length of the viewed buffer. It is used to help ensure there is a sync
The rest of it looks like locals.
to the byte length data block.
If not, then I missed the global.
Buffers data view with buffer witness record.
But I think that's it.
In Table 72, data view with buffer witness record fields 5, 3, 1, 2, capital M, A,
And this isn't used anywhere else.
B, A, T, A, capital V,
Alright, so this should work.
E, W, capital
So I'm gonna call this right here with these.
capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, B, J, order. The abstract operation, capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H,
I gotta scale. I gotta scale the video also
R, capital W, I,
from 4K down to 1080
S,
to save on video card space.
B, J,
So
order, sexy,
I'm gonna do that GPU side.
and a data view with buffer.
If that's even possible. If not, I'm gonna have to fucking scale it on the freaking CPU, which would suck.
Attached buffer. Buffer is true.
That just eats up more CPU.
Attached else. A let byte length be a
Sorry about that after.
order. Return the data view with buffer
I'll have to make these whatever,
2 5 3 1.
and then run it.
View record. The abstract operation get view byte length takes argument view record, a data view with buffer witness record, and returns an
I need to find a Claritin somewhere.
the following steps when called. Assert is view out of bounds. View record is false. Let view be view record. If view is not auto, return view. Assert is
Find a box is like, I don't even know. There has to be one somewhere.
let byte length be
The stupid trays have the Claritin. There's always like one or two that I missed.
byte off.
There has to be something somewhere.
1 4 is view out of bounds. View record. The abstract operation is view out of bounds takes argument view record, a data view with buffer witness record.
How do I name this?
It performs the following steps when called. Let view be view record. Let buffer byte length be view record. Assert is detached buffer. View is true if and only if buffer byte length is detached. Field name, value, meaning, object, a data view. The data view object whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created.
Define staging buff.
Sign
Primary GPU.
2020.
Primary
If buffer byte length is detached.
display.
Byte offset start b view. If view is auto, then a let byte offset NB buffer byte length 7. Else, a let byte offset NB byte offset start plus view. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length data views are not considered out of bounds. 0. Return false. 5 3 1 5 get view value. View request in
So we can make an option.
type. The abstract operation get view value takes arguments view. Any CMA script language value.
1920.
Any CMA script language value is little endian
Like 1080.
language value and type a typed array.
Let's do like whatever.
It's either a normal
This whatever.
either a number or a big int or a throw completion. It is used by functions on data viewer instances to retrieve values from the view.
Single typing.
Steps when called. Perform. Require internal slot. View. Assert. View has an internal slot. Let get index be. To int x. Request index. Set is little endian to boolean. Is little endian. Let view offset be view. Let view record be. Capital M A K E capital D A T A capital V I E W capital W I T H capital B U
Alright, so now staging buffer memory.
W I
So-called stage buff mem.
N E S S capital R view unordered. Note: bounds checking is not a synchronizing operation when views backing buffer is a growable shared array.
Calling it buffer memory is kind of redundant
Type error exception. Let view size be get
because a buffer is memory.
0. Let element size be the element size value specified in table 71 for element type 1.
It's like stag buff mem.
Size. View size. Throw range error exception. 2. Let buffer index be get index plus view offset. 3. Return get value from buffer. View. Buffer index. Type. False. Unordered is little endian. 5 3 1 6 set view value. View. Request int x is little
Put these in here.
value. The abstract operation set view value takes arguments view. Any CMA script language value. Request int x. Any CMA script language value is little endian. Any CMA script language value. Type. A typed array element type. And value. Any CMA script language value. And returns either a normal completion containing undefined or a throw completion. It
Please call this.
is on data viewer instant
Call this.
into the view's buffer. It performs the following steps with
Stag with GC to make sure nothing mingles.
slot. View assert. View has an internal slot. Let get index be. To int x, request index. If is big int element type is true, let number value be. To big int value, otherwise, let number value be. To number value, set is little endian to boolean is little endian. Let view offset be view. Let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R.
Make it like a dummy function.
Note: bounds checking is not a synchronizing operation when view's backing buffer is a growable shared array buffer.
In case it's disabled.
Out of bounds. View record is true. Throw a type error exception. Let view size be get view byte length. View record 2. Let element size be the element size value specified in table 71 for element type 3. If get in.
I'm just gonna call this insert up somewhere where, or like at a point after
X plus
the logical and physical devices have been assigned.
view buffer index.
So I gotta find that. Oh my god, this is so much work.
Return undefined. ECMA International 2024 655 253 to the data view construct.
Actually, I'm just gonna put this below the lowest point in the initialization,
The data view
because if I put it as the last thing in the initialization,
called as a construct.
I know everything before it is complete.
Called as a function.
It's not needed until later.
May be used as the value of an extends clause of a class definition.
So it's safe to put it as the last thing that's called during initialization.
Must include a supercall to the data view constructor to create
Man, why is this file so fucking big?
necessary
For fuck's sake.
prototype built-in methods. 5, 3, 2, 1 data view.
Okay, it's right here.
Offset. Byte
I'll call it here.
function performs the following steps when called. If new target is undefined, throw a type error exception. Perform.
And then, voila.
Buffer. Let offset be.
It's calling it, and it's grouped up in its own separate function,
Buffer is true. Throw a type
just like how everything else is.
length be array.
It's ridiculous. I can't believe people write code like this.
Buffer byte length.
It's terrible. It's like worst practices ever.
B is fixed length array buffer. Buffer if byte length is undefined.
It's like taking all the bad practices
True. Then
and then standardizing it by using globals for everything,
I let view byte length be auto.
and just giant data structures that hold data structures.
Byte length be if offset plus
I don't even know.
byte length. Throw array.
I can't stand this. I gotta get done.
Let OB. Order
Alright, so now I'm gonna like run it and see what happens.
target. Percent data view prototype percent. Viewed array buffer 1
This is on. Other new stuff is off.
is true. Throw a type error exception 2.
Of course there's a run. I should also take this
Sexy ST.
and the downside of here, check if it's on.
Byte length.
And if it's not, throw an error. Because I can't call this part of the code to make or to get the frame and load it up if it's not true that this stuff was initialized.
Set O to buffer.
That I'm adding right now.
Set O to view byte length 7. Offset 8. Return O 5 3. 3 properties of the data view constructor. The data
The Vulkan code, samples and stuff.
function proto.
There's like very minimal error checking or steep, I don't know, whatever.
1 data view proto
Now I finally have some sort of like,
is the data view prototype.
I feel like something is actually like managed, taken care of.
Full
Not just a global function floating around in various code, being called who knows when,
properties of the data.
and so on.
The data view
So now I can check explicitly if that stuff has been included or not by the default guard, then throw an error saying can't include this stuff because that stuff's not included. I'll just say that here.
4.
That works. Can't include
Data view prototype buffer is an accessor property whose
This stuff.
undefined. Its get accessor function performs the following steps.
Make a copy of
Form.
the display frame.
O. Assert. O has an internal slot. Let buffer be O. Return.
When the stage buffers to hold it are not included.
Byte length is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot.
Are not present.
Has an internal slot. Let
And or
A.
whatever that works.
Capital D.
So if this is off
A.
or not defined,
I. E. W. Capital W.
then I'll catch it and throw an error.
H. Capital B. U. F. F. E. R. Capital W. I. T. N. E. S. S. Capital R. O.
Oh, this is so boring.
View out of bounds. View record. Is true. Throw a type X.
Oh, I'm not gonna debug.
Size B get view byte length. View record. Return.
How long is this stream?
5, 3, 4. 3 get data view prototype byte offset. Data view prototype byte offset is an accessor property whose set accessor function is undefined. Its get accessor function performs the following steps when called. Let O be this value. Perform. Require internal slot. O. Assert. O has an internal slot. Let view record be
11 hours.
A. K. E. Capital D. A. T. A. Capital V. I. E. W. Capital W.
It's like 40 minutes left.
H. Capital B. U. F. F.
Stopwatch.
W. I. T.
Man, I better not. I really hope I'm not getting sick.
R. O.
Damn it.
E. If as view out of bounds. View record. Is true. Throw a type error exception. Let offset.
Oh well, whatever.
5, 3, 4. For data view prototype constructor. The initial value of data view prototype
Can I just have a shader? I wanted a program, but they all sucked. And they don't run good on this old CPU.
4. Byte offset.
I don't want to be doing this. I just want to find a pre-made program.
Let V be this
Why
value.
does an efficient program not exist?
In. Vigence.
Everything's sub-optimal.
24 657. 2 5 3 4
And the function blah blah blah
64.
requires 5 arguments, but only 3 given.
This method performed
Okay, that makes sense.
called. Let V be this value. Return.
I hope that's the only error. Please be the only error.
Set. Little endian. Begin 64. 5 3 4 7 data view prototype get float 32. Byte offset. Little endian. This method performs the following steps when called. Let V be this value. If little endian is not present, set little endian to false.
So I'm gonna pass in
View value.
this whatever.
Little endian. Float
Oh my god.
3.
I'm gonna like go drink 10 gallons of water or something. Just a shitload of water.
Little endian. This method performs the
I gotta pass in the physical device, the logical device, and then drink some water.
set little endian to false. Return. Get view
Because I don't know why. I'm freaking losing my voice.
little endian. 4.
I need to find a Claritin too.
Get int 8. Byte offset. This method performs the following steps when called. Let V be this value. Return. Get view value. V. Byte offset.
It's not fair to be born allergic to trees and grass. Like 95% trees and grass and ragweed. It's just not fair.
This method performs the following steps when called. Let V be this value. If little endian is not present, set
Like, why do I have to be allergic to freaking everything?
V. Byte offset.
Bunch of shit.
16. 5.
I wish I was allergic to shit. No, not really.
Int 32.
Could you be allergic to shit? Because we have to shit.
This method
They'd be terrible.
steps when called. Let V be this
To be allergic to shit, and then taking a shit. That'd be the worst.
Return. Get view value. V. Byte offset.
That's what it's like to be allergic to trees and grass.
3, 4, 1.
You encounter trees and grass all the fucking time.
This method
And then you're allergic. It's like, god damn it, another tree. Oh great, more grass.
value.
Does this run?
True. UINT8. 58.
Oh my god.
2024. 25. 3, 4, 1 3 data view prototype get in 16. Byte offset. Little
Why so many errors?
it performs the following steps when called. Let v be this value. If little endian is not present, set little endian to false. Return. Get view value. V. Byte offset. Little endian. UINT16. 5, 3, 4, 1 4 data view prototype get int32. Byte offset. Little endian. This method performs the following steps when
What if I just get rid of the whole thing?
if little endian is not present, set little endian to false. Return. Get view value. V. Byte offset.
What?
UINT32. 5, 3, 4, 1 5 data view prototype set begin 64. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be this value. Return.
For the love of crap.
Offset. Little endian.
You know what? I don't care.
5,
Being allergic to shit is just as bad as being allergic to trees.
64. Byte performs the following steps when called. Let v be this value.
I need to find some Claritin and drink some water.
Byte offset.
I don't know why my throat's so dry. I really better not be getting sick. I really hope I'm not sick.
4, 1 7 data view prototype set float 32. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be this value. If little endian is not present, set little endian to false. Return. Set view value. V. Byte offset. Little endian. Float 32. Value. 5, 3, 4, 1 8 data view prototype set float 64. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be this value. If little endian is not present, set little endian to false. Return. Set view value. V. Byte offset. Little endian. Float 64. Value. 5, 3, 4, 1 9 data view prototype set int 8. Byte offset. Value. This method performs the following steps when called. Let v be this value. Return. Set view value. V. Byte offset. True. int 8. Value. ECMA International 2024 659. 25. 3, 4, 20 data view prototype set int 16. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be this value. If little endian is not present, set little endian to false. Return. Set view value. V. Byte offset. Little endian. int 16. Value. 5, 3, 4, 2 1 data view prototype set int 32. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be this value. If little endian is not present, set little endian to false. Return. Set view value. V. Byte offset. Little endian. int 32. Value. 5, 3, 4, 2 2 data view prototype set int 8. Byte offset. Value. This method performs the following steps when called. Let v be this value. Return. Set view value. V. Byte offset. True. UINT8. Value. 5.
I did make this a function.
Prototype set in 16. Byte offset. Value. Little endian.
Or a macro.
Following steps when called.
So it's like inline again.
Endian is not present. Set little endian to false. Return. Set view value. V. Byte offset. Little endian. UINT16.
They're back to function.
4. 2 4 data view prototype set int 32. Byte offset. Value. Little endian. This method performs the following steps when called. Let v be the this value. If little endian is not present, set little endian to false. Return. Set view value v byte offset little endian uint32 value 53425 data view prototype. Add to string tag. The initial value of the add to string tag property is the string value data view. This property has the attributes false, false, true, 5, 3, 5 properties of data view instances. Data view instances are ordinary objects that inherit properties from the data view prototype object. Data view instances each have, and in turn,
Make these into single items, whatever.
not used within this specification. The simple presence of that internal slot is used within the specification to identify objects created using the data view constructor. 60. Copyright sign, ECMA International 2024. 25.4 The atomics object. The atomics object is %atomics %, is the initial value of the atomics property of the global object, is an ordinary object, has an internal slot whose value is %object prototype %, does not have an internal method. It cannot be used as a constructor with the new operator, does not have an internal method. It cannot be invoked as a function. The atomics object provides functions that operate indivisibly, atomically, on shared memory array cells, as well as functions that let agents wait for and dispatch primitive events. When used with discipline, the atomics functions allow multi-agent programs that communicate through shared memory to execute in a well-understood order even on parallel CPUs. The rules that govern shared memory communication are provided by the memory model, defined below. 5, 4.
I could make a loop and jump to here, then loop and jump back.
Atomics wait async.
But I'm not gonna do that.
Listed in Table 73. Table 73. Wait to record fields. Note for informative guidelines for programming and implementing shared memory in ECMA script. Please.
I'll just settle for a function.
Model section, field name, value, meaning, agent signifier, an agent signifier, the agent that called atomics wait or atomics wait async, promise capability,
And if I jump back,
record or blocking, if denoting a call to a
I need like a way to keep track of where to jump back to if I call it multiple places.
on negative extended mathematical value, the earliest time by which timeout may be triggered.
And I'm not gonna do that.
Values, result, okay, or timed out.
That's the reason for making a function.
4. To wait.
Even though functions suck.
Record is used to explain waiting and notification of agents via atomics wait async, and atomics notify. A wait list record has fields listed in Table 74. ECMA International 2024 661. Table 74. Waiter list record fields.
I'll run it again.
To records in a waiter list with the same agent.
Turns back on.
The agent cluster has a store of waiter list records. The store is indexed by block I, where block is a shared data
Oh, it's more errors. Damn it.
block. Waiter list records are agent independent. A lookup in the store of waiter list records by block I will result in the same waiter list record in any agent in the agent cluster. Each waiter list record has a critical section that controls exclusive access to that waiter list record during evaluation. Only a single agent may enter a waiter list record's critical section at one time. Entering and leaving a waiter list record's critical section is controlled by the abstract operations enter critical section and leave critical section. Operations on a waiter list record. Adding and removing waiting agents, traversing the list of agents, suspending and notifying agents on the list. Setting and retrieving the synchronize event may only be performed by agents that have entered the waiter list record's critical section. 5, 4, 3 abstract operations for atomics. 5, 4, 3, 1 validate integer typed array, waitable. The abstract operation validate integer typed array takes arguments typed array, an ECMA script language value, and waitable, a boolean, and returns either a normal completion containing a typed array with buffer witness record, or a throw completion. It performs the following steps when called. Let tar record be. Validate typed array, unordered. Note, bounds checking is not a synchronous.
Okay, this needs to just run for freaking sake.
Shed
Just work.
true. Then, if typed array is neither int32 array nor big int64 array, throw a type error exception. Else, a let type be typed array element type array be if is unclamped integer element type is false and is big int element type is false. Throw a type error exception. Return tar record. 5.
Then click it again.
To validate atomic access. Index. The abstract operation validate atomic access takes arguments tar record, a typed array with buffer witness record, and request int x, any CMA script language value, and returns either a normal completion containing an integer or a throw completion. It performs the following steps when called. Let length be typed array length. Tar record. Let access index be. To int x. Request index. Assert.
What does it mean? This wasn't declared.
Length. Throw a range error except ion. Let typed array be tar record. Let element size be typed array element size.
Duh, I gotta move it above. Dang it.
Meaning, waiters, a list of waiter records, the calls to atomics wait or atomics wait a synth that are waiting on the location with which this
Move all this stuff below. That's cool.
a synchronize event or empty, the event of the most recent leaving of its critical section, or empty if its critical section has never been entered. 662. ECMA International 2024. 7. Let offset be typed array. Return. Access index element size plus offset. 5, 4, 3, 3, capital V, A, L, I, D, A, T, E, capital A, T, O, M, I, C, capital A, C,
Alright, try it again.
E, S, S, capital O, N, capital I, N, T, E, G, E, R, capital T, typed array, request int x, waitable, the abstract operation, capital V, A, L, I, D, A, T, E, capital A, T, O, M, I, C, capital A,
Yes, only a couple left.
C, E, S, S, capital
929.
capital I, N, T, E, G, E, R, capital T, takes arguments typed array, any CMA script language value, and request int x, any CMA script language value, and optional argument waitable, a boolean, for normal completion,
What's missing?
throw completion. It performs the following steps when called. If waitable is not present, set waitable to false. Let tar record be. Validate integer typed array, waitable. Return. Validate atomic access. Tar
Oh, I forgot this.
index 5, 4, 3, 4 validate atomic access. Typed array, byte index in buffer. The abstract operation revalidate atomic access takes arguments typed array.
You should have said your define is empty. So it's like a closing parenthesis, but there's a comma, so it's a missing argument.
This operation revalidates the index within the backing buffer for it.
But instead of saying there's a missing argument, it says, oh, it does, this is expression. Well, that's kind of confusing.
Side effects, which could cause the buffer to be
I guess you could infer that it's a missing argument, but it should say missing argument before closing parenthesis.
called. Let tar record be.
I guess it does say that technically, based on the context of there.
P, E,
So, I don't know.
capital A, R,
Never mind. It does make sense.
capital W, I, T, A,
What doesn't make sense is all these fucking globals in these big ass
E,
functions that are tied to the state of the whole program.
E, S,
It's ridiculous.
ordered, note, bound
Okay, please work now.
operation when typed arrays backing buffer.
Yes. Finally.
Typed array out of back
Now.
is true. Throw a type error
Turn on the other stuff. Assuming that this stuff works.
array if byte index in buffer tar record. Throw a range error exception. Return unused. 5, 4, 3, 5 get waiter list. block I. The abstract operation getWaiterList takes arguments block, a shared data block, and I, a non-negative integer that is evenly divisible by 4, and returns a waiterList record. It performs the following steps when called: assert I and I plus 3 valid byte offsets within the memory of block. Return the waiterList record that is referenced by the pair block I 5 4 3 6. Enter critical section WL. The abstract operation enter critical section takes argument WL a waiterList record and returns unused. It performs the following steps when called: assert the surrounding agent is not in the critical section for any waiterList record. Wait until no agent is in the critical section for WL, then enter the critical section for WL without allowing any other agent to enter. If WL is not empty, then a note AWL whose critical section has been entered at least once has a synchronize event set by leave critical section. B. Let execution be the field of the surrounding agent's agent record. C. Let events record be the agent events record of execution whose is agent signifier. D. Let enter event be a new synchronize event. E. Append enter event to events record. F. Append WL enter event to events record. Return unused. ECMA International 2024 663. Enter critical section has contention when an agent attempting to enter the critical section must wait for another agent.
Staging buffer, staging memory.
FIFO order of enter critical section calls is observable. When there is contention, an implementation may choose an arbitrary order but may not cause an agent to wait. I.
I don't care. There's always like a duplicate of something. It's just annoying as hell. Now, assuming all stuff worked, I can use that here for this thing. Turn this back on. Turn this off. I'll just run to make sure it's entering. It enters. Dang it. Alright, so through there, so it's entering still. Drink some water. It's not helping. Alright, so now I would assume this works. Side change it doesn't, because it's by JetBot. And this stuff, staging buffer memory. Pass in these instead now. This only showed up twice. I guess so. Staging buffer, I would assume that means staging buffers. So do this, and pick the first one. Using enum for 180. Now it's like extremely long and unreadable, which is how I like it. Alright, now I think the rest of this is okay, but I don't know. I would assume so. There's one function left. Only one function left. It'd be really cool if this would just work. Because there's only 16 minutes left in the stream. And if it works, then I'm done. And it works. So, find out. Then run it. Nope, it doesn't just work. Some fix. Actually, I'm gonna turn off this one, then turn it back on. Man. 1027. Are you fucking kidding me? It says VK map memory. Needs to be this type. That's what this type is. Chatbot made staging buffer memory. What's this type? Which is what this is. so easy, the simple way. I'm just gonna make these 3. Oh, it's not even. It says VK device memory. Not a VK buffer. But why did it call it staging buffers? Oh my god. This is so dumb. This is just annoying as hell. I need to pass in VK device. That's what I'm passing in. No, it's not. Staging buffers and staging memories. And it's called, or they called it, staging buffer memory. So I assumed that'd be staging buffers. But what they actually meant was device memory, which I named staging memories. So I'm gonna name something different now. It's just so annoying. It's freaking. There we go. Which still doesn't make sense in that chatbot uses staging buffer memory. It doesn't have the word device in there. So start to tell the difference between buffer, when saying buffer memory, and then device memory, because the word device doesn't even show up when in this case it's referring to device memory. And then build. Almost there. One, oh, three, three. Is that why they make everything have a pnx pointer? So we can check for if you like actually initialize things. Having a common thing in all of them. Or is it like a lazy way to link things together? I'm thinking the second. So you can like lazily link things together when they're setting things up. And then like unlink them after whatever. Or not. That'd be a good way to lazily link things. Lazily link things. I mean, I'm losing my voice. It's great. I might be getting sick. I like when chatbot says, which means you're initializing the structure, like this. Except it's chatbot's code. Oh, come on. Alright, so I guess I need these externs. Where am I referencing? Device. 1030. Man. Does that one take logical or physical device? VK device. Logical device. So here, pass in logical device. Is it the only place? Yes. I hope it's possible to not have to call on map. Or maybe you have to. I don't know, maybe it's not possible. Maybe that does like a copy behind the scenes. Which would suck. Because I don't know. I think it probably does. I'm losing my voice. Is that one ear less? Yes. So only a few more to go. The stream's at like at the limit, so I'm gonna like let this stream run on for 10 more minutes. Start another stream. So BRB, next stream. Hoop-de-doo. Like after this, meaning like 4 or 5 minutes.
To enter the critical section must wait for another agent to leave it. When there is no contention, FIFA order of enter critical section calls is observable. When there is contention, an implementation may choose an arbitrary order but may not cause an agent to wait indefinitely. 5, 4, 3, 7 leave critical section. WL. The abstract operation leave critical section takes argument WL await a list record and returns unused. It performs the following steps when called. Assert. The surrounding agent is in the critical section for WL. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let leave event be a new synchronize event. Append leave event to events record. Set WL to leave event. Leave the critical section for WL. Return unused. 5, 4, 3, 8 add waiter, WL, waiter record. The abstract operation add waiter takes arguments WL a waiter list record, and waiter record, a waiter record, and returns unused. It performs the following steps when called. Assert. The surrounding agent is in the critical section for WL. Assert. There is no waiter record in WL whose field is waiter record and whose field is waiter record. Append waiter record to WL. Return unused. 5, 4, 3, 9 remove waiter, WL, waiter record. The abstract operation remove waiter takes arguments WL a waiter list record, and waiter record, a waiter record, and returns unused. It performs the following steps when called. Assert. The surrounding agent is in the critical section for WL. Assert. WL contains waiter record. Remove waiter record from WL. Return unused. 5, 4, 3, 1, 0 remove waiters. WL, C. The abstract operation remove waiters takes arguments WL a waiter list record, and C, a non-negative integer or plus, and returns a list of waiter records. It performs the following steps when called. 2, 3, 4, 5, 6. Assert. The surrounding agent is in the critical section for WL. Let len be the number of elements in WL. Let n be min. C. Len. Let L be a list whose elements are the first n elements of WL. Remove the first n elements of WL. Return L. 64. ECMA International 2024. 25. 4, 3, 1, 1. Suspend this agent. WL. Waiter record. The abstract operation suspend this agent takes arguments WL a waiter list record, and waiter record, a waiter record, and returns unused. It performs the following steps when called. Assert. The surrounding agent is in the critical section for WL. Assert. WL contains waiter record. Let this agent be agent signifier. Assert. Waiter record is this agent. Assert. Waiter record is blocking. As cert. Agent can suspend. Is true. Perform leave critical section. WL. And suspend the surrounding agent until the time is waiter record. Performing the combined operation in such a way that a notification that arrives after the critical section is exited but before the suspension takes effect is not lost. The surrounding agent can only wake from suspension due to a timeout or due to another agent calling notify waiter with arguments WL and this agent. That is via a call to atomics notify. Perform enter critical section. WL. Return unused. 5, 4, 3, 1, 2 notify waiter. WL. Waiter record. The abstract operation notify waiter takes arguments WL a waiter list record, and waiter record, a waiter record, and returns unused. It performs the following steps when called. Assert. The surrounding agent is in the critical section for WL. If waiter record is blocking, then await the agent whose signifier is waiter record from suspension. B note. This causes the agent to resume execution and suspend this agent. Else if agent signifier is waiter record, then a let promise capability be waiter record. B perform. Call. Promise capability. Undefined. Waiter record. Else a perform enquy resolve in agent job. Waiter record. Waiter record. Waiter record. Return unused. 5, 4,